Yoshlik, bolalik, o'smirlik davridan toki hayot o'g'irlarni oxirgi damlargacha mana shu yerda qo'llangan roman qo'shib yozuvchi Luqmon Bo'roqan qalamiga mana
kechasining mana shu ilmiy konferensiyamizning qatnashchilari sizlar bilan shunday bir ajoyib jonda diydorlashtirganimdan mamnunman. Bu ham bo'lsa mana shu ustoz O'ktam Pardayevich Umurzoqovning sharofotidan deb bemalol aytishimiz mumkin. Hozir juda ajoyib bir hujjatli film ko'rdik. Furqajon sizga juda katta rahmat. Bundan ham keyingi ijodlaringizga barkamollik tilab qolaman. Endi bugun biz o'zi aslida xotira kechasi yig'ilib turibmiz, lekin aslida O'ktam Pardayevichni biz har kuni, har soat, har lahza xotirlab turamiz. Mana shu kitobni yozish jarayonida men mana shu Irrigatsiya institutida yurar ekanman, mana shogirdlar bilan gaplashar ekanman, u kishining safdoshlar bilan gaplashar ekanman, buni juda chuqur his qildim. Chunki mana qaysi bir kishining shogirdlari yoki safdoshlari bilan gaplashganda har bittasi u kishini faqat ko'zda yosh bilan esladi. Chunki bu hali domla Bahodir Suyunch ta'kidlaganday, u kishining yordami, u kishining g'amxo'rligi yetib bormagan birorta ham xodim, birorta ham talabi bo'lgan emas aslida. Yo'q. Bu narsa ham bu insonning ulkan qalbidan, ulkan salohiyatidan, ulkan bir insonparvarlik tuyg'ularidan darak berib turibdi. Albatta bu kitoblarimiz hali boshlanishi, bu hali yana ham davom ettiramiz degan umiddamiz. Chunki hali biz buni bir tajriba tariqasida ko'rdik. Men bunda albatta imkon qadar shu O'ktam Pardayevichning jamiki xislatlarini, fazilatlarini, ishdagi xodimlarga munosabat va shuningdek oilaga bo'lgan munosabatini har xil rakurslardan ochib berishga harakat qildim o'zimcha. Albatta buning xolis bahosini muhtaram o'quvchilarimiz beradi. Shu bitta narsani ta'kidlamoqchimanki, O'ktam Pardayevich Umurzoqovning hayoti faqatgina ibrat va namunadan iborat. Ya'ni u kishi bir narsani talab qilishdan oldin o'zi o'sha narsani o'rnak bo'lib ko'rsatishga harakat qilganlar, o'zi namuna bo'lishga harakat qilganlar. Qaysidir ma'noda u kishining butun hayoti, faoliyati shu muqaddas bitiklardagi shu hikmatlar bilan bog'liqqa o'xshab tuyuladi. Masalan, o'zingga yoqmagan narsani boshqaga ravo ko'rma, o'zing o'rnak bo'lib keyin talab qilgin yoki o'ng qo'ling berganni chap qo'ling bilmasin. Mana hozir domla Bahodir shuni ta'kidladi, biz o'sha qilingan yaxshiliklarni u kishi hatto matbuotdan ham yashirganlarda. Chunki bu narsani u kishi ovoza qilishni, bu bilan maqtanishni xush ko'rmaganlar va bu narsani lekin faqatgina mana shu shogirdlarning yuragiga quyilib qolgan deb o'ylayman. Albatta o'ylaymanki, mana bizning Baholi Qudrat yozgan asarimizni o'qib, uni xolis bahosini berasiz degan umiddaman. Agar mumkin bo'lsa, Bahodir Suyunchda bitta men tahlilni aytib ketmoqchi edim, agar endi sizlarga havola. Mana o'zining butun salohiyatini, ilmini, tafakkurini mana shu Toshkent irrigatsiya va qishloq xo'jaligi mexanizatsiyalash muhandislar instituti Milliy tadqiqotlar universitetiga bag'ishlangan ekan nomda shu Milliy tadqiqotlar universitetini u kishi nomini atasa maqsadga muvofiq bo'lardi deb o'ylayman. Rahmat.
Yana bir bor rahmat hammaga, hurmatli anjuman ishtirokchilari. Biz anjumanimizda asosiy qismiga o'tsak-da, hech kimga sir emaski, maktab ta'lim muassasasi bu muqaddas dargoh hisoblanadi. Mana shunday muqaddas dargohlarning orasida ulug'lari ham bor. Albatta, ushbu ta'lim muassasalarini ulug' atashga uni insonlar qiladi. Mana shunday hozir bugungi kunda Milliy tadqiqot universitetida o'tiribmiz. Aytib o'tish kerakki, ushbu Milliy tadqiqot universitetida Prezidentimiz Shavkat Miromonovich ham tahsil olganlar va faoliyat yuritganlar. Mana shunday insonlardan biri ustozimiz, hammamizga taniqli akademik Oqil Mirzo Salimov o'tiribdilar. Ruxsatlaringiz bilan u kishiga so'z bersak.
Katta rahmat. Mana bugun juda bir katta ko'p odamlarni o'qitib, ko'p odamlarni yaxshi mutaxassis qilib institutda yubiley bo'lyapti. Bu shu yerda o'qitgan pardaychilar ishlari katta bo'lgan o'zlari. Bu yerda ilgari umuman laboratoriyalarda boshqa joylardan olib kelib, boshqa joylardan o'rgatib, shu ko'rsatgan mana shu suratda shunaqa laboratoriyani tashkil qilganlar. Ancha odamlar bilan mana shu gapirishib, ilmga taklif qilib, shu bilan katta xizmat qilganlar. Shuning uchun mana shu davlatimiz bugun u kishini ko'rsatib, ishlarini ko'rsatib, dastoyda mana shu sizlar shuncha odamlar o'tib, institut qanaqaligini, nimaligini bilib, sizlarga katta rahmat, salomat bo'ling.
Rahmat ustoz. Ilk so'zlaringiz uchun, ruxsatlaringiz bilan hammalarimizga ma'lumki, Milliy tadqiqot universiteti maqomi berilgan dargohdamiz. Albatta bu o'z bilan bo'lmaydi. Bunda ilmiy innovatsion faoliyat juda chuqur olib borilganidan, umuman olganda tadqiqotlar va izlanuvchilar soni bilan alohida ajralib turganini inobatga olib, ushbu dargohga mana shunday maqom berildi. Va shu nuqtai nazardan anjumanimizda ishtirok etayotgan O'zbekiston Respublikasi Fanlar akademiyasining prezidenti akademik Bekzod Sadiqovich Yo'ldashevga bersak. Marhamat.
Assalomu alaykum. Assalomu alaykum muhtaram.
Mana shu institutda endi men bir kishi institutida har xil specialistlarni, injenerlarni boshqa joylarga taraqqiyot qildi. Laboratoriyasi juda katta edi. Unchalik ham mutaxassislar yo'q, specialistlar kam edi. Shuncha men kelganimdan keyin mana shu institutga bir yosh odamlar kelib, yosh yigitlar kelib, endi bugun u kishini gapirib bo'lmaydi. Gapirish mumkin emas. Shuncha qilgan ishlarini o'zlari biladilar, lekin unchalar yoqmaydi. Kamroq gapiringlar mana deydilar. Mana shu prezidentimiz juda katta ishlarni qilib, mana shu institutni ko'parib berdilar. Ochig'i. Mana shu institutda dunyoda tanishdilar. Mana shu institutda shuncha yangi ishlar bo'lyapti, laboratoriyalar bo'lyapti. Chet elda katta ma'lum bo'lib, hamma ishlar qilyapti. Shuni ham unutish kerak emas. Assalomu alaykum.
Assalomu alaykum muhtaram Sultan Pardayev. Oilasini a'zolari, domlalar, aziz anjumanning uchrashuv qatnashdilar. Hayot shunaqa narsaki, bu Xudo umr bergandan keyin ko'p narsa o'zining shaxsiy insoniga bog'liq. Uni o'qishiga, tarbiya qilganiga, qanaqa maqsad o'zini hayotida qo'yadi, qanaqa g'oyalarga harakat qiladi. Men o'ylaymanki, O'ktam Pardayevich mana shunaqa bitta klassik desa misol. Butun umr bitta tashkilotda ishlab, shu yerda olim bo'ldi. Shu yerda ikkita unvonga ega bo'ldi. Ham texnika, ham iqtisod. Bu haqiqiy bir bizni ziyolilarimizni eng yorug' bitta elchisi desa bo'ladi. Men nima xafa bo'lib qolganman shu xushxabarlarni eshitib o'tgan yili, chunki bir oy ilgari soqqa-soq yuribdi, biz uchrashgandik, bir qator loyihalarni muhokama qildik. Hozir o'zinglar bilasizlar, oliy yurt bilan Fanlar akademiyasining tashkilotlarida hamkorlik juda ham yuqori darajaga ko'tariladi. Mana shu yerda O'ktam Pardayevich bilan biz birlikda qo'shma loyihalarni muhokama qildik. Afsuski ulguramadik oxirigacha yetkazishga, lekin olim uchun, pedagog uchun eng katta esdalik bu uni shogirdlari. Bu qurgan inshootlari, binolari. Mana hozir men eslayapman, 5 yilda ichida qanaqa o'zgarishlar faqat shu muassasada bo'ldi. Hammasiga shunga sababchi hurmatli prezidentimiz albatta O'ktam Pardayevich. Yangi loyihalar, yangi xalqaro dasturlar, men xabarim bor. Yangi apparatura, yangi asbob-uskunalar, jihozlar, yangi laboratoriyalar. O'sha yerda studentlar chuqur fanni, bilimni o'rganishadi. Men o'ylayman, O'ktam Pardayevich juda ham katta hissa, shaxsiy hissalarni qo'shdilar. Shu institutda Teams deb yuramiz. Men uchun juda qiyin gap o'shanda. Shu ko'p yoshligimizdan Teams deymiz. Shu Teams haqiqatni eng katta darajaga ko'tarib, ko'p unvonlarga ega bo'ldi.
Dunyo taniydi bu institut. İnstitutida ilgari kim chiqarardi? Mana hozir har joyda butun davlatlar bu Irgiziiston instituti gapirishyapti. Chunki vaqtida yaxshi katta e'tibor bo'ldi. Mustaqilliklar paytida ish qilib, hozir to'g'ri aytish kerakki, Shavkat Mirziyoyev juda xizmatlari katta. Bu institutga emas, bu institutda boshqa. Butun davlatda qarab turing, nechta institut bo'lib ketdi hozir. Nechta laboratoriya bo'lib ketdi hozir. Qancha olimlar bo'lib ketdi hozir. Hammasi shu vaqtda bo'lgan narsa. Shuning uchun kechasi aytaman, men endi gapirib beryapman shuni.
Rahmat domla. Men yana bitta narsani qo'shmoqchi edim. Fanlar akademiyasini bir qator ilmiy tadqiqot, bir qator ilmiy muassasalari bevosita Teams kafedralarman, professorlarman qo'shma loyiha qilishyapti. Men o'ylayman, shu eng katta esdalik bo'ladi O'ktam Pardayevichga. Hamma niyatlari shu amalga oshirsa biz uchun ham katta esdalik bo'ladi. Rahmat.
İjozatlaringiz bilan so'z navbatini O'zbekiston Respublikasi Suv xo'jaligi vaziri Hamroyev Shavkat Rahimovichga bersak.
Assalomu alaykum, hurmatli ustozlar. hurmatli hamkasbalar, hurmatli anjuman ishtirokchilari. Men shunday baxtiyor insonmanki, aynan mana shu institutda, mana shu dargohda 5 yil ta'lim olib, voyaga yetishganmiz. Shunday hurmatli ustozlardan ta'lim olib, mana shunday shakllanganmiz va o'sha vaqtdan beri biz umuman mana shu institut bilan aloqamizni uzolmay, yana ta'lim olishda davom etyapmiz. Albatta, mana shu suv xo'jaligi sohasini bu dargohsiz, bu ilm maskanisiz tasavvur qilib bo'lmaydi. Bugungi kunda mana shu institutni bitirgan ko'plab, minglab talabalar, mana hozir ustozimiz Murzoqish aytganlaridek, butun dunyoda faoliyat ko'rsatyapti. Katta lavozimlarda, katta bir ilmiy mansablarda xizmat ko'rsatyapti. Biz ular bilan ko'plari bilan bog'lanyapmiz va aynan O'ktam Pardayevichni mana shu masalalarda juda katta hissalari bor. Biz O'ktam Pardayevich bilan mana shu suv xo'jaligi vazirligi tashkil qilgan kundan boshlab juda ko'p tadbirlarni mana prezident qarorlarida, vazirlar mahkamasi qarorlariga kiritib, shu dargohning talabalarini yana bilimlarini oshirish, amaliyotga o'tishlarida yangi bosqichga ko'tardik. Biz O'ktam Pardayevich bilan mana shu institutga kirib ta'lim olgan yillarimizdan beri yaqin do'st edik, hamkor edik. Ko'p masalalarda biz fikr almashganmiz. Bunday insonlarni men hayotda juda kam uchratganman. Mana kecha yana bir ustozimiz Ismoil Hakimovich Jo'rabekov bilan biz muloqot qilgandik. Bugun kelaman degandilar. Yurtboshimiz bilan bugun Samarqand viloyatida u kishi juda kecha nima qilib ko'rsinib aytdilar, afsus men bu tadbirga bora olmayman, lekin aziz ustozlarga, talabalarga, mana shu anjuman qatnashchilariga meni katta salomimni yetkazing deb men shu qarzimni ado etmoqchiman. U kishi ham butun hayotlari mana shu irrigatsiya instituti bilan bog'liq bo'lgan, aynan shu institutni bitirganlar va ko'p esladilar mana oldin o'tgan 14 ta rektorlarni har bittasini qo'shgan hissalarini mana Murzoqish bugun o'zlarini vaqtda ishlagan paytlarini aytib berdilar. Shu yillarda institut og'ir ahvolda edi. Mana bosqichma-bosqich men hisoblayman, aynan hurmatli O'ktam Pardayevich rahbarlik qilganda bu yangi cho'qqilarga chiqdi va bevosita hurmatli yurtboshimiz Shavkat Mirziyoyevni tashabbuslari, bevosita yordamlari bilan bo'ldi. Men esimda bor, mana shu korpuslardagi auditoriyalarga kirib, endi qo'pol bo'lsa ham aytishim kerak, oyoqlar bilan bir-ikki tabretkalarni tepib, bir-ikki shu osib qo'yilgan plakatlarni olib yerga tashladilar, chang bosgan. Bu qanaqa bu? Eski zamonda narsalar haligacha yuribdi. Sen shu suv xo'jaligini boshqaryapsan, nimaga bu kelib institut bilan birgalikda shu ishlarni tugatmayapsizlar deb juda qattiq kirishib ketganlar. Mana yotoqxonalarga kirib, baribda studentlar yotadigan joylarda va mana shuni kunma-kun, soatma-soat uni rivojlantirib, mana bugun ma'lum bir darajaga chiqdiki, bu rivojlanishni endi to'xtatib bo'lmaydi. Mana bugun faxr bilan, g'urur bilan institut rahbarlari, olimlar, ustozlar boshqacha bir kayfiyat bilan shu ishni davom ettiryaptilar. Mana talabalarni, magistrantlarni, yosh olimlarni gapini eshitsangiz agar zavqlanib ketasizki, demak, suv xo'jaligida kelajagi barqaror, suv xo'jaligi katta shaxtam qadamlar bilan rivojlanadi deb. Albatta, bugungi kunda institutni erishgan yutuqlarni hammamiz ko'rib turibmiz. Mana respublikamizda institutlar orasida, oliy o'quv yurtlari orasida reytingda birinchi o'ringa chiqdi. Mana xalqaro darajadagi reytinglarda kuchli mana shu 200-300 o'rinlarga chiqib oldi. Men o'ylaymanki, bu hammasi mana shu katta bir yo'lga, katta bir qadam tashlanadi va o'ylaymizki, hali katta yutuqlar, katta muvaffaqiyatlar oldinda. Suv xo'jaligini bu institutsiz tasavvur qilib bo'lmaydi dedim. Nima uchun? Chunki bugun har bir inshoot, har bir katta bir sug'orish tarmog'i bo'ladimi, suv ombori bo'ladimi, nasos stansiyalar bo'ladimi, albatta u ilmni talab qiladi. Bugun mana shu institutda olingan bilimlar, yangi qirralarni ochishga talabalarimiz, ustozlarimiz qattiq bel borib bog'lab kirishyaptilar. O'ylaymizki, bu masalalarda biz yurtboshimiz tomonidan qo'yilgan vazifalarni chiroyli qilib uddalaymiz. Xalqimizni duosini olib, kelajakka mana shu eng hayotda muhim bo'lgan suv, Alloh bergan ne'matni yetkazib berishda, uzluksiz mana shu inshootlarni xavfsiz barqaror ishlashda institutning katta o'rni bo'ladi. Men fursatdan foydalanib mana shu ustozlarimizga, talabalarga bu ishlarda ulkan muvaffaqiyatlar tilayman va mana shu hurmatli, hammamiz uchun aziz bo'lgan O'ktam Pardayevichning ishlarini davom ettirib, u kishini xotiralarini doim abadiylashtirib, eslab, mana hozir juda yaxshi taklif bo'ldi. Universitetni ham bu kishini nomlariga qo'ysak degan va boshqa umuman bu kishini nomlarini biz qachon abadiylashtiramiz? Qachonki bu kishini ko'ngilda bo'lgan orzu-havaslari amalga oshsa, qachonki biz mana shu kishini nomini yana ulug'lantirish uchun mana shu institutni ham yana yuksak darajalarga ko'tarib, zo'r eng dunyoda tanilgan institutdagi shu studentlar chiqarsak, albatta biz o'zimizning oldimizda qo'ygan vazifamizni, burchimizni ado etgan bo'lamiz. Hammangizga sog'lik, salomatlik tilayman. Sog' bo'ling. Rahmat.
Rahmat. Ijozatingiz bilan so'z navbatini O'zbekiston Respublikasi Oliy va o'rta maxsus ta'lim vaziri Toshqulov Abduqodir Hamidovichga bersangiz.
Assalomu alaykum, qadrli bugungi anjuman ishtirokchilari. Assalomu alaykum, hurmatli O'ktam Pardayevning oila a'zolari, kelinoyimiz, farzandlari. Bugungi anjumanning eng qadrli mehmonlari ular hisoblanadi. Aziz hamkasblar, bugun shu muhtasham zalda buncha ilm ahlini yig'ilishini o'zida bir katta hikmat bor. Qancha akademiklarni ko'ryapmiz. Bugun bu insonga bo'lgan hurmatlarini izhor qilish uchun O'zbekistondagi barcha oliy ta'lim muassasalarining rektorlari tashrif buyurib turibdilar. Barcha viloyatdan rektorlar kelishgan hozir. Nima uchun? Anjuman ham, ilm anjumani ham o'z yo'liga, lekin ehtirom bu kishining ruhiga, bu kishining oilalariga, bu kishining qilgan ishlariga, shogirdlariga. Azizlar, hozir men aminman. Men o'rta yoshdaman, lekin har birimiz hozirgi filmni ko'rib, o'zimizni hayotimizni parallel solishtirib chiqdik. Lekin ustozning qilgan ishlari, ustozning davlat va jamiyatga berganlari bir necha bor ustunligini ham angladik. Bu nega? Ustozimiz Inomjon Urushevich bir gapni aytdilar. Hayotlari ikki narsa edi, institut va oila edi dedilar. Uning isboti bugungi anjumanda shunday ajoyib o'tishiga sabab rahmatli ustozimiz ham davlatchiligimizga, xalqimizga ajoyib farzandlarni tarbiyalab bildilar va ham ko'plab shogirdlar tarbiyaladilar. Bugun bu anjumanni bu fayzli o'tishiga shu ham sabab. Buni hammamiz bilib o'tiribmiz. Ko'pchiligimiz ko'p shogird chiqarishimiz mumkin. Lekin farzandlarimiz ko'nglimizdek bo'lmasligidan qo'rqamiz. Kimdadir farzand zo'r bo'lishi mumkin, lekin zabardast shogirdlar bo'lmasligi mumkin. Rahmatli ustozlar har ikkalasi sodir bo'ldi. Shuning uchun ham bugun juda iliq so'zlar bo'ldi. Hujjatli filmda hech kim bir hayajonsiz ko'rmadi, lekin hayotlarini bir qismigini ko'rsatildi menimcha, xolos. Azizlar, hozir so'z olganlar juda ko'p vaqt O'ktam Pardayevich bilan yelkama-yelka ishlaganlar. Maslakdosh bo'lganlar. Men qisqa vaqt, aniqrog'i rektorlik faoliyatim davomida o'sha onlayn Zoom yig'ilishlarida qatnashganda u kishini biz o'ylab turgan gapni aytishlari, e'tirozlari, takliflari, "Oq shunday ustozing bo'lsa-da, biror kun bo'lmasa-ki u kishidan ayrilmasangda" degan xayolda ishlardik. O'sha hududda rektor bo'lganimizda. Vazir sifatida lavozimga tayinlanib, muhtaram prezidentimiz ishonch bildirgan ishni boshlab dastlabki kunlarida birozgina talmovsirab qoldim men. Chunki har bir rektor bir arbob, jamoatchilik arbobi. Ularga topshiriq berish, ular bilan ishlash bu boshqa vazirliklarga nisbatan menimcha og'irroq. Shunday kunlarda telefon qilib, men bormoqchiman dedilar. Men aytdim, yo'q, men borishim kerak. Tartib taomil bo'yicha ustozning huzuriga boradilar, kengash raisilar. Yo'q, tartib boshqacha. Kelib, ko'ngilni ko'tarib, maslahatlar berib, eng qizig'i, eng yuragimni to'rida qolgan Abduqodir, uy joyda muammo yo'qmi dedilar. Oilani ko'chirib keldingizmi dedilar. Nafaqat ta'lim bo'yicha maslahatlar, balki hatto meni oilam, yashash tarzim muammo yo'qmi, shungacha bir to'g'risini aytish kerak. Otalarcha, ustozlarcha mehribonlik ko'rsatib, shu xonadan chiqqan damlaridan e'tiboran menga bir quvvat keldi. Ilohiy quvvat keldi boshqaruvda. Shundan keyin ancha maslahat ishlariga erishdik va har bir ishni maslahat ishladik. Ming afsus, qisqa ishladik. Bu yo'qotish men uchun, oliy ta'lim tizimi uchun, kengashi uchun juda katta yo'qotish. Buni so'z bilan ifodalab bo'lmaydi, lekin qilingan ishlar tahsinga loyiq. Mana shu universitetda qilingan ishlar ko'pgina oliy ta'lim muassasalari uchun andoza. Bir yig'ilishda ochig'ini muhtaram prezidentimiz aytdilar. Rektorlar orasida men maslahatlashib turadigan rektorlar bor dedilar. Biz hammamizni ko'z o'ngimizda O'ktam Pardayevich keldilar. Nimaga? Oxirgi 5 yilda 77 ta oliy ta'lim muassasasining 177 ta bo'lishida rahmatli ustozning hissalari katta. Shunday ekan, bugun bu zalda bu anjumanni u kishisiz o'tkazishni o'zi hammamizni mahzun qilib turibdi. Nima bo'lganda ham kayfiyatsizlik bo'lib turibdi, lekin hayot davom etadi. Olimning o'limi olamning o'limi deydilar. Bugun shogirdlar uni davom etkazadi. Atrofdagilar, hatto talabalarning fikrlarini ko'ryapmiz, qanchalik mehr muhabbat. Hammamiz ham agar davlatchiligimizga shunday hissa qo'ysak, bundan-da katta muvaffaqiyatlarga erishishimiz muqarrar. Men chiqishda nima uchun kitoblarni olib chiqdim? Men aspirant edim. Yolqin To'raqulov haqida xuddi shunday rus tilidagi kitobni o'qib chiqdim. U kishini hayotlariga ibrat bilan qaradim. Va bugun mana bu minbardan so'zlab turibman. Men aminman. Bu kitobni o'qigan yoshlar, talabalar, doktorantlar u kishining yo'llaridan yurib, hali ilm uchun, fan uchun, davlatchilik uchun katta xizmat qiladilar. Bu mualliflarga, hujjatli filmni yaratgan mualliflarga, bugun bel bog'lab xizmat qilib turgan shogirdlarga, universitet rektori va jamoasiga men minnatdorchilik bildiraman va bu xalqaro konferensiya an'anaviy tarzda bo'lib, har konferensiyada u kishining nomlarini yod qilib, haqlariga duolar qilib, mana shu ishlar davomli bo'lishini tilab qolaman. Hammalaringizga rahmat, salomat bo'linglar.
Haqiqatan ham ta'lim ham tarbiya ham zamon o'rtaga qo'yadigan yangi talablarga ko'ra o'zgarib boraveradi. Kompartiya tomonidan ham bildirilgan fikr va ko'rsatmalar kelajak sari qat'iyat bilan borishimizda doimo tayanch va suyanch bo'ladi deb o'ylayman. Ruxsatlaringiz bilan so'z navbatini Moskva davlat qurilish milliy tadqiqot universiteti professori Kozlov Dmitriy Vячеславовичga berdim.
Дорогие друзья, уважаемые коллеги, уважаемые учителя, молодежь счастливая, потрясающе современная, которая учится сегодня в Ташкентском институте ирригации и механизации сельского хозяйства. Мне очень приятно приветствовать от лица Московского государственного строительного университета и от тех, кто лично знал Уктам Пардовича. Мы с ним познакомились почти 20 лет назад. Работая в одинаковых должностях, я был проректором в учебной работе Московского государственного университета природоустройства. А он в то время возглавил науку и инновации здесь, в ТИМСХА. Это был потрясающий человек, потому что жил по справедливости. По справедливости в своей судьбе. Мы в разговорах, ощущая комплекс отличника, он, как и я, закончил школу с золотой медалью, всегда пытался отдать все, что ему дали учителя, своим ученикам. Я очень хорошо помню, как, будучи на встречах с ним в кругу механиков, механизаторов, он в большей степени отдавал приоритет им, а я все-таки гидротехник и водник. Связующим звеном между нами были выпускники, в том числе ТИМСХА. Это покойный Борис Михайлович Кизяев, академик РАН, который, к сожалению, также неожиданно ушел из жизни в прошлом году вслед за Уктамом. Очень печально, что в таком молодом возрасте такие энергичные руководители покидают нас. Наверное, в этом точно несправедливость. Но справедливость в том, что после него остается дело, которому он посвятил жизнь. И поверьте, я своими глазами видел, как развивался этот вуз в постсоветское время. Это был период угасания, как и у каждого из нас, в 90-е годы. А затем период неимоверного расцвета. И то, что мы сегодня наблюдаем в этом белоснежном зале, это мечта, которая реализовалась именно усилиями и благодаря профессору Мурзакову. Лабораторные корпуса, современная аудитория, вхождение в мировое образовательное пространство, многоязычность. Это все, о чем он мечтал на этой площадке Ташкентского института механизации и ирригации. И когда несколько лет назад к нему, как и еще к нескольким его коллегам, в первую очередь это, конечно, Дильшот Раимович Базаров, пришла интересная идея организовать на базе ТИМСХА постоянно действующую международную конференцию, посвященную самым важным проблемам Центральной Азии. Проблеме воды, проблеме ее использования, проблеме гидротехники, механизации, гидротехнических работ и, самое главное, проблеме экологии. Экологии водного хозяйства, экологии окружающей среды в сочетании с использованием воды. И, естественно, мы, как водники, как патриоты своей профессии, поддержали эту идею и включились в ту многоликую и интересную работу, которая сегодня вылилась уже в традицию, как мы видим, в 4-ю конференцию по CONMECHYDRO. Я думаю, что то мероприятие, на котором мы сегодня все собрались, благодаря справедливому решению Уктама Пардаевича, будет ему лучшей памятью, потому что профессиональный разговор на этой площадке, он будет бесконечен. Не будет нас, будут наши ученики, будет жить его дело, и будут жить идеи, которые рождались здесь, в ТИМСХА, на протяжении многих десятилетий. Я кланяюсь его памяти, и спасибо, что вы с такой добротой отнеслись при организации этой конференции, вспоминая в первую очередь профессора Мурзакова. Спасибо.
Нет сомнений. Ijozatlaringiz bilan so'z navbatini Budapesht Texnologiya va iqtisodiyot universiteti professori Loren Holdberg janoblariga bersak.
Dear guests, dear friends, dear colleagues, dear director and distinguished guests. In the summer of 2021, the sad news of Professor Uktam Bardayevich Umuzakov's passing reached those who had the honor of knowing him. Sadness, but also a gratitude were immediate reactions. Gratitude for the many ways how he directed and stimulated the lives of Uzbek people into a satisfying and prosperous direction. And now it is hard to remember to Professor Umuzakov without being emotionally moved. It is his insight, his understanding of the world beyond his field of specialization that set him apart from his peers of his generation and enabled him to serve the development of Uzbekistan as a rector of TIAME on one hand, and as the chairman of the Republican Council of Higher Education on the other hand. No matter during his life what position he has occupied, he had always worked with high dedication and devoted his whole conscious life to the noble cause of developing the higher education of Uzbekistan, training highly qualified specialists, educating the youth to be fundamental reforms in the national system of higher education, and work diligently to introduce modern requirements and criteria, advanced foreign experiences in the field. For the purpose, he has initiated and supported numerous international projects in the field of higher education. Personally, I had the opportunity to meet him in the context of the Genghis project and within the frame of this Erasmus Plus capacity building in the field of higher education project. I had the opportunity to work with him, and in this project, he did a lot to ensure that despite the cultural differences of Europe and Uzbekistan, we could work together efficiently, resulting in a fruitful joint work, which has actually established, in the end, a doctoral school in the field of geoinformatics in Uzbekistan. He had an excellent understanding of people. He was excellent in dealing with conflicts between people. His personal charisma was engaging, and his character in general was very human, I would say. Nevertheless, when chaotic, indecisive situations arose during the project, which always might happen when someone is doing a work, and it resulted in a stuck at work, his firm and instinctive opinion proved decisive. His excellent management skills enabled him to bring the Uzbek partners, the project partners, together on the same platform. It was a very pleasant and efficient way to work with him in a project team. As a private person, I knew him as a warm-hearted and open-minded man. He was quite open to tell me stories about his childhood. Actually, his love of nature is also originated from his childhood spent in Zomin, and he brought him from Jizak province the love of nature and water to the capital. And with his progressive spirit, his willingness of action, it has become a benefit for the whole country. All in all, he was a man of vision on one hand, and he was a man of passion on the other hand. His work, attitude, dedication, endurance, and generosity should be a model for us, for the young generation, for everyone, a guide for all who are working for higher education. His memory remains in our hearts. Thank you.
Hurmatli anjuman ishtirokchilari, bilasizlar, onlayn ham konferensiyamiz bo'lmoqda va ijozatlaringiz bilan iltimos qilindi. Vengriya Rektorlar Kengashi bosh kotibi janob Zlotan Dubishchi janoblari onlayn tarzda ham so'z olmoqchilar. Marhamat. Mr. Dubish, please, the speech.
Thank you for the opportunity. Dear ministers, dear professors, dear guests, it's an honor for me to be invited and to be here, even online, in this conference, which was organized to the memory of Professor Rector Umurzakov, our friend of Hungary and a friend of Hungarian Rectors Conference and the Hungarian universities. I will be very, very brief because online appearance is always a little bit boring, more boring than the on-spot appearance. My memory goes back to last year with Professor Umurzakov. We organized together a very, very successful event. Last June, on the 21st of June, we organized the first Hungarian Uzbek Rectors Forum in the University of Tiamen, the National Research University. And after it, we organized together two more events, two more forums. The next day in Samarkand and after in Bukhara. This forum and this event was a very, very successful event between the two countries. And Professor Umurzakov played a very, very important role in order to organize this successful forum. A lot of Hungarian participants, a lot of universities took part in the forum. Almost 20 universities arrived, and there have been the president of the Hungarian Rectors Conference, also the co-president and vice minister from the Ministry of Foreign Affairs. And during the forums, we signed altogether 28 memorandum of understanding between our universities, between the universities of Hungary and the universities of Uzbekistan. And I have a very, very special small memory with Professor Rector Umurzakov. After the first forum, we had a gala dinner together with the participation of the two delegations, and we brought a very special present for Professor Umurzakov, a Hungarian national football team shirt entitled and is inscripted Umurzakov on the back of the shirt. And I remember that he immediately tried it and absolutely fitted to him. So our memories are very, very good, and it's a great honor it was a great honor to work together with Professor Rector Umurzakov to organize this event and to develop the Hungarian-Uzbek higher education relationship between the two universities and between the two higher education system. He was always very, very helpful, and with the help of him and his staff, our events and our meetings, and later on our relations developed a lot. He will be always in our memory, and I hope that the Hungarian and the Uzbek universities will meet together in Budapest. We agreed last year that in the near future, probably in this year, we will meet together to organize the second Hungarian Uzbek Rectors Forum. So thank you for the opportunity, and I wish you a very successful conference, and we always remember Rector Umurzakov, of course. Thank you for the opportunity.
Thank you, Mr. Volkan. Ijozatlaringiz bilan so'z navbatini Moskva davlat qurilish milliy tadqiqot universiteti rektori professor Akimov Павел Алексеевичga bersin. Павел Алексеевич, на связи, пожалуйста.
Добрый день, уважаемые коллеги, дорогие друзья. Ну, прежде всего, я хотел бы сказать, что взаимодействие с Национальным исследовательским университетом, Ташкентским институтом инженеров ирригации и механизации сельского хозяйства для нашего университета, Национального исследовательского, Московского государственного строительного университета всегда имело и имеет особое значение. Я могу сказать, что коллектив университета помнит, что 4 года назад, в июле 2018 года, Уктам Пардаевич Омурзаков посетил НИУ МГСУ, и как раз состоялись очень хорошие такие содержательные переговоры о сотрудничестве наших вузов, о взаимодействии в образовательных, научных сферах. И могу сказать, что сейчас очень приятно присутствовать на такой конференции, когда перед Республику Узбекистан, перед нашей страной стоят большие задачи, связанные с повышением мощностей объектов гидроэнергетического строительства. Это и строительство новых объектов, новых ГЭС, а также реконструкция существующих. Это такая для меня, может быть, далекая сфера, с одной стороны, в профессиональном плане, с другой стороны, содержательно мне очень близко в названии конференции слова, связанные со строительной механикой, потому что это как раз сфера моей профессиональной деятельности. И я в этом смысле с большим интересом принимаю участие в конференции и уверен, что все участники этой конференции будут иметь возможность послушать большое количество содержательных докладов. Я могу сказать, что наш вуз готов, безусловно, к дальнейшему развитию сотрудничества с коллегами из Республики Узбекистан. Это тем более, что сейчас у нас в последние 2 года ряд направлений научных получил серьезное развитие. Это вопросы, связанные с численным моделированием, с физическим моделированием, с научно-техническим сопровождением проектирования строительства уникальных строительных объектов. Это вопросы, связанные с механикой грунтов, основаниями, фундаментами, гидроэнергетическим строительством. И сегодня я могу сказать, что на конференции наш университет представляет, ну, наверное, главный специалист в области гидроэнергетического строительства Дмитрий Вячеславович Козлов, который выступал несколько минут тому назад. И, кроме того, я хотел бы сказать, что мы также открыты для взаимодействия, развития нашего сотрудничества в сферах, в том числе и совместных образовательных программ. Со своей стороны также приглашаю коллег посетить наш университет и, ну, что называется, ознакомиться с теми инновациями, которые у нас сейчас есть в части образовательной, научной, международной деятельности. Желаю всем участникам сегодняшней конференции интересных выступлений, самое главное, крепкого здоровья и таких хороших, содержательных профессиональных дискуссий. Огромное вам спасибо за сегодняшнюю конференцию. Убежден, что это очень важное событие в жизни как Республики Узбекистан, так и многих зарубежных государств, учитывая огромный масштаб личности профессора Уктам Пардаевича Омурзакова. Спасибо большое.
Hurmatli anjuman ishtirokchilari, ruxsatlaringiz bilan so'z navbatini Erasmus Plus milliy ofisi koordinatori Abdurahmonova Aziza Karimova.
Assalomu alaykum, hurmatli bugungi konferensiya qatnashchilari, hurmatli президиум. Для меня очень волнительно стоять на этой сцене, в этом зале. Светлая память Уктама Пардаевича. В этом зале под его руководством прошло немало международных конференций, и большинство из них в рамках программ Tempus и Erasmus Plus Европейского Союза. Но особенно значительный факт для всей большой семьи Erasmus, участников проектов Европейского Союза, то, что он возглавил запуск программы Erasmus+ в мае 2014 года в этом зале для всех стран Центральной Азии. То есть все центральноазиатские республики были приглашены сюда для того, чтобы под руководством Европейской комиссии был открыт новый этап новой программы Erasmus+. И Октам Пардаевич внес личный огромный вклад в то, чтобы каждый проект под его руководством всегда вырастал в его руках в крепкие партнерские дружеские связи, устойчивые связи. И для меня Октам Пардаевич является тоже учителем, как относиться к проектам, как относиться к партнерам, как относиться к своему делу. И так как сказал Абдулкадыр Хамидович, я на себе тоже лично чувствовала его отношение ко мне, может быть, как к младшей сестренке. Он всегда спрашивал и о моих детях, и о моих внуках, всегда интересовался тем, что является крепким тылом для всех, для каждого из нас. Светлая память ему и уверенность в том, что благодаря ему, его принципам, его отношению к делу создана сильная команда тех, кто на равной может с партнерами из всех стран Европы, из других стран разговаривать и работать в проектах, реализовывать проекты. Это его команда, это его ученики, это его последователи. И для нас, для всех всегда Национальный научно-исследовательский институт, университет будет связан с именем Октам Пардаевича Амурзакова.
So'z navbatini Markaziy Osiyo hududiy iqtisodiy hamkorlik instituti direktori o'rinbosari Abdullayev Iskandar Hikmatovich.
Assalomu alaykum, muhtaram ishtirokchilar. Avvalambor ustozimiz, iqtisod fanlari doktori, professor Oktam Pardayevichning 70 yoshi va yorqin xotirasiga bag'ishlangan anjuman tashkilotchilariga, jumladan Toshkent irrigatsiya qishloq xo'jaligi mexanizatsiyalash muhandislari instituti Milliy tadqiqot universiteti rahbariyatiga taklif uchun minnatdorchilik bildirmoqchiman. Hamma o'z so'z boshida albatta Oktam Pardayevich bilan bog'liq hodisalarni, voqealarni eslayapti. Men Oktam Pardayevich bilan 1995-yilda Amerika Qo'shma Shtatlariga universitetlar almashuv dasturi asosida birinchi marta borganda tanishganman. U kishi men Alimsalim Po'latov, shu universitet professor, birga borganimizda delegatsiya rahbari bo'lgan. Meni eng hayron qoldirgan joyi shu bo'lganki, u kishi men endi aspirant bo'lgan mahal, endi ikkinchi kursda o'qiyotgan, u kishi rahbar sifatida ham munosabat qilib, Oktam Pardayevich deganida domla aytganlarki, Iskandarbek, men sizni Iskandar Hikmatovich deb aytaman endi. Shuning uchun Oktam aka deb chaqiring deb birinchi shu oramizdagi muzni buzib yuborgan. Shundan men xursand bo'lganman. Ikkinchi tomondan birinchi marta u paytda hozir mana minglab yoshlarimiz chet elga o'qishga boryapti, chet elda ilm olib kelyapti. To'g'risi u paytda hali juda kam odam borardi. Borganda ham meni qo'rqitgan narsa 9 oy, 10 oy boshqa davlatda bo'lish. Shu Oktam Pardayevich ko'p bo'lmaganlar, bir oy biz bilan birga bo'lgan paytlarda ko'p narsalarga maslahat berganlar. Vaqt juda qisqa, 9 oy, 10 tez o'tib ketadi. Iloji boricha bilim olishga, qaytib institutga kelganda shuni ishlatishga harakat qiling deb juda ko'p maslahatlar bergan. To'g'risi, o'shandan keyin aka-ukadek bo'lib ketganmiz. Keyingi meni ishlashimda, keyinchalik xalqaro tashkilotlar bilan hamkorlikda juda ko'p maslahat olganman. 97-yillarda shekilli Amerikadan kelgandan keyin ancha shishib keladi odam chetdan, bilimimiz ko'p narsa o'zgartiramiz deb. Lekin tarvuz qo'ltiqdan tushib ketadigan paytlar ham bo'ladi odam, ayniqsa ilm bilan shug'ullangan, o'qishga o'zini sarflamoqchi bo'lgan odamga qiyinchilik ham mavjudda. O'sha institutga ketmoqchi bo'lganman 97-yilda. qiynalganman, boshqa sohaga ketaman. Oldilariga kirganimda bir narsani aytganlarki, 95-yilda shuncha vaqtgacha bordingiz, chet elda ko'rib keldingiz. Endi nima qilmoqchisiz deganlar. Men aytganman, balkim ilmiy ish qila olmasam kerak domla, tadbirkorlik bilan qilaman desam, bir narsani juda qiziq narsani aytganlarki, "Ha, endi siz Amerikada o'qib kelgan tadbirkor bo'lar ekansizda" deganlar. Shunda ketmaganman, institutda qolganman va nomzodlik dissertatsiyasini yo'qlash paytida ham qiynalgan paytlarimda ancha maslahatlar berganlar. Endi to'g'risini aytish kerak, domlani o'zbek intelligensiyani etalonini deb aytishim kerak. Endi juda katta so'z bo'lib ketmasin, balandparvoz, chunki birinchidan so'zlashish madaniyatini juda ham qoyilqilarda ko'proq eshitardi. Ikkinchidan o'sha birovni fikrini o'qish, birovni fikrini ustini chizib tashlamaslikni juda ham bilardilar. Endi xalqaro tashkilotlarga kelganimizda birinchi marta Xalqaro suv resurslari institutini boshqarish institutiga mutaxassis bo'lib o'tgan paytlarida domlaning oldiga kelganimda aytganlarki, "Tabriklayman, juda to'g'ri ish qildingiz. O'zingiz sohangizdan ketyapsiz. Lekin sizga bitta savol. O'zingizni yurtingiz uchun, mana shu institut uchun nima qilib bilasiz?" degan savolni bergan. Men javob bera olmaganman, chunki xalqaro institut, men bilmayman hali imkoniyati bormi, yo'qmi. Lekin bir 2 yildan keyin bir programmaga kelishib olganmizki, mayli, mablag'laringiz yetmasa, qurilish qilmasangizlar, hech bo'lmasa shu institut talabalariga stipendiya beringlar, shu sizlar bilan birga ishlasin. Chunki sizlar xalqaro institut, har qalay talabalar ham sizlardan ko'radi, xalqaro tajriba almashadi. O'sha hozir ham menimcha agar institut vakillari shu yerda bo'lsa, shu programma davom qilyapti. Timsixon talabalari, o'sha ilmiy mutaxassislar bilan birga ishlab, birga tajriba orttirib, anchalari dissertatsiya yo'qladi shu soha bo'yicha. Keyinchalik 2010-yilda mintaqaviy ekologiya markaziga rahbar bo'lganimda, meni eng qiynagan narsa kim maslahat beradi? Bu tashkilot katta tashkilot, Olmaotada joylashgan. Kim bilan maslahat qilaman deganda, biz O'ktam Pardashni maslahat kengashi a'zosi qilganmiz. Domla maslahat kengashi a'zosi bo'lgan paytda chin yurakdan shu tashkilotni o'zgartirish, rivojlantirish uchun ancha katta maslahatlar bergan. Undan tashqari mana hozir hammalaringiz bilasizlar, balkim shu zaldan chiqqandan keyin o'tsa ham bo'ladi. Markaziy Osiyoda birinchi o'sha innovatsiya markazi, suv xo'jaligi innovatsiya markazi, mana Shavkat Rahimovich ham bordilar, ochilishida qatnashganmiz. Shu narsani biz 2 yil maslahat qilganmiz domla. Nimaga kerak bu? O'sha paytda men tushunmaganman. Domla innovatsiya markazi deyapsiz. Buni o'tkazib bo'larmikan loyihasi deganida, siz buni qiling, bu kelajak uchun kerak deganlar. Mana shu innovatsiya markazini 2018-yil avgust oyida ochganmiz. Hozir qilayotgan ishlardan bittasi o'sha yoshlar bilan innovatsiyaga yo'naltirishyapti. Oxirgisi mana hozirgi nimada Markaziy Osiyo iqtisodiy hamkorlik institutining ham maslahat kengashining a'zosi edilar. Oxirgi kungacha men esimda bor, 1 oy oldin men ham o'sha paytda kasal bo'lib qoldim, domla nazar qo'shishdan oldin biz gaplashganmizki, Toshkentda shu institutni eng katta birinchi konferensiyasini ochish, ilmiy konferensiyasini o'tkazish to'g'risida kelishib olganmiz. Afsuski, shu payt amalga oshmadi. Mana yangi rahbariyat bilan qolaversa, shu bizning institutimiz taklif bilan chiqyapti. Kelgusi yil shu payt konferensiya bilan birga bizning ilmiy konferensiyamizni ikkinchisini shu yerda Toshkentda Timsixada o'tkazishni. Qolaversa, yana bitta narsasi bor edi. Domlaning oxirgi so'zimni aytmoqchimanki, talabalarga yordam berishga, ularga ilmiy izlanish uchun albatta qandaydir mablag', hech bo'lmasa metodika berishga harakat qilardilar. Bizda institutimizda dasturi bor, granti bor. O'sha eng yaxshi ilmiy xodimlar uchun, yaxshi izlanuvchilar uchun shu grantni keyingi yil mana shu ikkinchi konferensiyaning eng yaxshi maqolasi uchun yoki eng yaxshi izlanuvchi uchun Timsixon bilan birgalikda shuni joriy qilsak, ham domlaning xotiralariga va qolaversa o'sha hozirgina aytgandek domlaning eslashning eng yaxshi yo'li o'sha kishini qilgan ishini davom ettirish va qo'llab-quvvatlash. Shuni bir taklif qilmoqchiman. Qolaversa yana bir marta birinchidan shu tashkilotchilarga shu anjumanni tashkil qilgani uchun, shu yerdagi barcha olimlarga, o'qituvchilarga, institutga rivojlantirish uchun qilayotgan ishlariga omad tilayman. Va albatta biz o'sha domla aytgandek, siz institut uchun, yurtingiz uchun nima qilasiz degan savolni ham biz o'zimizga berishda davom qilamiz, harakat qilamiz. Albatta qo'llab-quvvatlashga va qolaversa shu xotirasi ham yodimizda. Salomat bo'linglar, rahmat.
Hurmatli anjuman ishtirokchilari, O'ktam Pardayev oliy ta'lim tizimining 2030-yilgacha rivojlantirish konsepsiyasini yaratish, soha mutaxassislarini ijtimoiy-iqtisodiy, diplomatik, huquqiy va ma'naviy ma'rifiy jihatdan rivojlantirishning pishib yetilgan muammolarini hal qilishda iste'dodli yetakchi sifatida barchamizga namoyon bo'lgan shuningdek davlatimiz rahbari Shavkat Miromonovning yuksak ishonchini qozonib, uning yaqin savdoshi va maslakdoshi sifatida Respublika Oliy ta'lim kengashining birinchi raisi sifatida jahonda o'z o'rni va g'oyasiga ega O'zbek universitet hamda institutlarini aylantirish uchun yuksak fidoyilik ko'rsatib mehnat qildi. Bugun men ustoz ruh oldida chuqur ta'zim keltirar ekanman. O'ktam Pardayevichga bag'ishlangan tantanalar yurtimizning intellektual taraqqiyotiga ehtirom hamda ezgu maqsadlarimizni anglash yo'lida yana bir muhim vosita sifatida ko'rishni xohlar edim. O'ktam Pardayevichning ruhi shod, oxirati obod bo'lsin degan so'zlar bilan O'ktam Pardayevich Umurzoqovning tavalludining 70 yilligi va yorqin xotirasiga bag'ishlangan xalqaro anjumanning asosiy ma'ruzalariga o'tar ekanmiz va birinchi so'z navbatini Nobel mukofoti sovrindori, atrof muhiti tizimlari tahlil qilish guruhi rahbari professor Liklimans janoblariga beramiz. Rahmat. Texnik uzilish nuqtai nazaridan agar ruxsat bersangiz, so'zni Howetech Investment Toshkent kompaniyasi bosh direktori Chen Zakay janoblariga berib tursak.
Dear ladies and gentlemen, dear rector, distinguished guests, good morning. So on behalf of Huawei Company, let me express my deep gratitude to be invited today to attend this event, the International Science Conference. I joined Huawei Uzbekistan this March as a general manager, but I'm well acknowledged about the long-term cooperation between Huawei and Tianmi University. Our previous director, when he introduced the past projects with Tianmi University, always shared his deepest respect to the management of the university, especially Mr. Umasakov. He was very excited by introducing the innovation in the agriculture and irrigation sphere, and by digitalization of education sphere, which makes great contribution to digital transformation of all electronic economic sectors. So I have the operation here, sorry. Operation for more than 23 years here in Uzbekistan. Huawei built long-term cooperation with Tianmi since the first time we opened this smart class in International House Lyceum in 2017. That was one of the first projects realized on the basis of smart classroom concept, which allows to use distant education and electronic platform for smart education. In 2020, when pandemic hit Uzbekistan, the solution realized in inter-house Lyceum helps the student not only in this Lyceum, but it becomes efficient platform of sharing classes with all Uzbekistan pupils. Using the cloud platform and in cooperation with Uz Report TV channel, Tianmi broadcasted online classes as an in-time solution and response in fight with COVID-19. In 2020, when Inter-House Lyceum opened its Center for Talent Identification in cooperation with the Higher School of Economics, we also supported it with Digital Solution Idea Hub to allow the students and teachers to hold online classes. So in today's world, the digitalization touched every sphere of economy and social life. And the most important thing is to build strong infrastructure and reliable platform for further development of digital projects. Thus, in the end of 2020, we implemented project on installation and launch of modular data center in Tiami, which become the foundation for future project on a smart agriculture. From Huawei side, we are not only focused on provision of innovation technologies, but also on training of human resources. Our expert conducted a series of trainings of specialists and professors of the university to get them ready for the ongoing digitalization. In March 2021, Huawei and Tiami signed MOU for cooperation expansion and realization of key pilot projects in agriculture and water resources management sectors. In the research field in Kipuri district, the joint team of Huawei and the university made site survey and defined key directions for the launch of smart agriculture projects. The project was finalized and presented to the relevant authorities and publics in September 2021 by opening joint showrooms in Tiami. That was a demonstration of effort and contribution of various partners to the project, including national operators Woods Telecom, Geo Innovation Center, Ministry of Water Resources, Ministry of Agriculture, Ministry of Higher Education. Building such ecosystem, we achieved the target to show how technologies may help us in saving resources and improve efficiency in agriculture. So smart agriculture project was conducted with implementation of remote control and monitoring system on the basis of Internet of Things and 5G network with the use of special agriculture drones, intellectual sensors and platform for big data analytics. The use of digital technology in the sphere of agriculture and water resources management allows to carry out more efficient crop planting and virtual management of agriculture fields. Economical sparings of pesticides and fertilizers, monitoring water consumptions, which will significantly reduce resource costs and improve sustainable development of Uzbekistan. So next page, please. As the world keeps developing the sphere of digitalization, friendly relationship and strong partnership of the university and our company allows us to reach more as in the sphere of education. So in building sustainable Uzbekistan, taking position number 2 in R&D for 2021 in the world, Huawei has a lot more to propose to the university for further development. As it is seen in the recent roadmaps released by various countries, digital economy and green development have become the main area where all economic plans to be committed to. One of the key focus of global community as well as Uzbekistan is to achieve carbon neutrality, to achieve green power generation, including industry, civil energy field, transportation, etc. To focus on those key scenarios, Huawei is open to cooperate in launching of smart solutions of compass, smart PV, green ICT infrastructure, and comprehensive smart energy solutions for government organizations, education establishments, and large solar factories to help Uzbekistan to build ecologic, intelligent, and sustainable environments. And we would be eager to continue productive and effective cooperation with Tiami in these directions based on our long-term trust and friendship. Thank you.
Thank you, Mr. Aloqaga chiqqan bo'lsa, agar ruxsatlaringizdan Mansi janoblariga. Mr. Libans. Mr. Libans is speaking. You're welcome.
Good morning.
Morning.
Are my slides on the screen as well?
floor is yours. Can you hear us? Professor Clemens, can you hear us?
Yes, I can hear you loud and clear.
Okay, the floor is yours. Thank you.
Thank you. Are my slides on the screen as well? Or should I share my screen?
Yes, you are organizer. You can share your screen.
Okay.
We cannot see your screen yet.
Can you now?
No, unfortunately. Maybe for full screen you can try. Yes, so now we can see your screen. Thank you.
Perfect. Okay, it's an honor for me to speak at the conference today. We have been working together with the Institute for about a decade, and with the different Erasmus programs, we had a lot of exchange of bachelor, master, and PhD students. And they worked in Wageningen. They did a lot of thesis topics in Uzbekistan and Central Asia. And I'm very, very thankful of that collaboration, because it also taught me an enormous amount of knowledge about the ecology of the region, about the climatology of the region and the hydrology of the region. So that's a scientific stimulus which is very, very valuable. And the other thing, of course, is meeting new people, meeting young, inspiring people, and help them to educate. And I think the collaboration with TIAM has been very, very successful. And that can be seen with one of the projects which we actually did, and several master students worked in it on the thesis, where we start looking at the impacts of climate change on land use, on biodiversity in Central Asia. So it's not only Uzbekistan, but also Kazakhstan, Turkmenistan, Kyrgyzstan, so the whole region. And our approach was very much a scenario-driven approach, looking at land use scenarios, which include population, demography, economics, etc., looking at a spatial analysis by taking the different climate, soil, topographic maps, and then link that to simulation models for biodiversity and ecosystem services. And you can actually see in the different maps with the different scenarios. We use the most recent IPCC scenarios at the SSP 1 to SSP 5. These are socioeconomic scenarios to actually show the differences in the impacts of land use on biodiversity. And where the areas are red, there's actually a very, very big change in biodiversity. If it's green, it's less. The index we used was the mean species abundance, and that's the biodiversity measure that indicates biodiversity inactness, and it compares populations between disturbed habitats and undisturbed natural habitats. But when you add climate into the picture, so based on a series of climate scenarios, actually the picture is getting worse. And from that, we very much concluded that all grasslands in the world, and we did some global studies as well, are vulnerable to climate change, but the Central Asian grasslands seem more vulnerable than the other grasslands in the world. And it's also a methodological study, and our results translate the information of socioeconomic and climate change drivers, but it also shows it's an exploratory study that more research is needed to translate these findings into better management strategies for Central Asia's grasslands. So it shows that under these changes, socioeconomic changes, land use changes, and climate changes, we definitely need a much better land use planning, but also a much better conservation planning. So these kinds of studies on ecosystem services, on climate change impacts, we have been doing in collaboration with the Institute. If I look at my talk, I wanted to talk very much on some of the recent developments of the IPCC. And the IPCC last year published its last report. And here you see the different diagrams, puppets, which indicate the level of uncertainty over the years. And when the first report was published in 1990, it did not contribute the human contribution to climate change. The second report in 1995, that is wonderful sentence, the balance of evidence suggests discernible human influence on climate. Now the balance of evidence, that's a lot of uncertainty. The word suggest indicates a lot of uncertainty. Discernible, yes, it's there, but also some uncertainty. And then in the subsequent years of the next report, it's very much likely, very likely, extremely likely. And in the last report, it's unequivocal that human influence has warmed the atmosphere. And that unequivocal means clear and unambiguous, indisputable. So the science of climate change through observation, through modeling, is actually very robust at the moment. And that's also seen in the observations. We've seen the warming over the continents, over the oceans, over the last 150 years. And every decade of the last 5-6 decades has been warmer than the decade before. There's also a very clear pattern of warming. The polar areas warm faster than the tropical areas. Land areas warm faster than the ocean areas, although the ocean take up about 90% of all the heat generated by the greenhouse effect. And some areas which are dry at the moment will be drier in the future. Areas that are wet at the moment will be wetter. If there's warming, that means more evaporation, more moisture can be held in the atmosphere, but that will also result in precipitation. So the current precipitation patterns in the world will actually intensify. And one of my pieces of work, and that goes back already 20 years now, is the IPCC reason for concern diagram. At the end of the 90s, I was asked as an author of the IPCC report to actually try to define what is dangerous climate change. And the group I was working in came up with this diagram, the reason for concern diagram. And it's very much linked to the scenarios of climate change. And we were looking, is there a threshold? And that was actually very, very difficult because there's a lot of gradual change. And we could not, from the literature, define the risks very, very carefully. And we also saw that there are very many different systems that have different risks. So we actually defined 5 different columns for risks and put that into some kind of a traffic light: green, orange, red. Red would be dangerous climate change, green would be safe. That's what the traffic lights indicates. If it's green, it's safe. But we meant actually little risk. So we removed the color green, changed it into white, and then had gradual changes from one to the other. And the first reason for concern is very much the ecosystems, unique systems all around the world. Coastal systems will be affected by sea level rise, will be affected by other changes. Mountainous system will be strongly affected because of the zonal vegetations. Crops will be affected. One of the ecosystems which will be affected most are the coral reefs. Coral reefs are affected in two ways. One is the warming of the oceans, which could lead to bleaching. And the second one is very much the uptake of CO2 in ocean water. CO2 plus water becomes carbonic acid and acidifies the ocean. So there's two stressors very much on these calcareous corals. And again, if we have most of the climate change in high latitudes, the tundra ecosystems are very, very vulnerable. And if you look at crops, it's very much some coffee crops, vineyards, and some other crops. So we have to try to adapt. And one of the pictures in here is, of course, the polar bear, who's actually losing its current habitat. So the ecosystems are vulnerable. And we estimated that the risk started to increase with 1.5 to 2 degrees and become very, very dangerous above 2 degrees. And with dangerous, we mean that the systems cannot adapt. The second bar is very much the extreme events. And the extreme events occur, they are forests, they are floods, droughts, etc. There's a picture in the right bottom corner of the heat wave in Europe in 2003, which actually caused about 30,000 additional deaths in the months of July and August, especially in France, but also in the Netherlands and Belgium. And that was caused by two factors. One is the heat wave, and the heat wave caused that the nights didn't cool down. So people with respiratory problems really got health problems. At the same time, everybody was on vacation, including the nurses. So that was a big event, but we see extreme events all over the world at the moment. And again there, 1.5, 2 degrees is the threshold in which the extreme events could not be adapted to. The third one is very much regional impact. And there what we see is that the regions that produce most emissions are actually lesser impacted than the regions that do not produce the emissions. So Africa, Latin America, Southeast Asia, Central Asia are impacted much more relative to the level of emissions. And that has to be taken up in the climate negotiation of the United Nations framework on climate change. The global emissions is very much the impacts of sea level rise. And that's also not equally distributed across the world. And it seems that sea level rise is accelerating at the moment, mainly because Greenland and Antarctica are melting quicker than expected. And the last one is very much the very big unexpected events, the so-called tipping points, like changes in the ocean circulations, the melting of the West Antarctic ice sheet, the collapse of the Brazilian rainforest because of drought, etc. So all these impacts show a certain risk, and it looks like at that time that 2 degrees was one of these critical thresholds. Remember, this diagram was published in 2001, but since a lot has happened. We have seen a lot of observed impacts of climate change, and they have been attributed to local and regional climate change. And in 2015, the figure was actually updated, and they added a color. Red is still dangerous, high risks, but they added the color purple, very high risk. And that's especially in the ecosystems. And you also see 15 years later, when people looked at the literature, when people evaluated all the observed impacts, the red has come down from over the 2 degrees to actually lower. And scientists believe now that tipping points will actually be more likely than we thought 15 years ago. Same with the global impacts and the regional impacts. And also the observed changes, and this is also work of one of my PhD students, Gerrit Hansen, who created this map. The observed impacts of climate change are observed everywhere in the world. They relate to hydrology, they relate to agriculture, they relate to forestry, they relate to forest fires, but also to different economic events. And they can also be attributed, and that's very much the little histogram after each drawing. This figure is documented very well in the literature and in the IPCC report. And because of all these reports and scientific articles, the policy community actually reacted. Now, maybe it's reacted already earlier than the science was established, because in the 1992, at the big Earth Summit in Rio de Janeiro, they set the UNFCCC, the United Nations Framework Convention on Climate Change. And they state the very clear objective that the greenhouse gas concentrations in the atmosphere should be stabilized at a level that would prevent dangerous anthropogenic interference with the climate system. So that's a very insightful statement at that time. But then the discussion started. In Berlin, 1 year later, the UNFCCC was accepted by many countries. It was very clearly said that the industrialized countries should take the first step and developing countries should follow. 1997, for the industrialized country, there was a Kyoto Protocol, but then a lot of things stalled until 2015, when there was finally the Paris Agreement, which is a legally binding climate change treaty adopted already by 196 countries, which aims to limit global warming to well below 2 degrees, preferable 1.5 degrees compared to 1880. And countries should aim to achieve a climate neutral world by the mid-century and submit ambitious national determined contributions. And that was already discussed in Glasgow. And there, most countries learned that their ambitious contributions were not enough to actually stay below the 2 degrees. But the 2 degrees and also the 1.5 degrees very much comes from these IPCC reports and the reason for concern diagrams. And therefore, in the latest reports, and the climate change report was published in 2021, last year, but the impact report was published earlier this year. And there you see a lot of additional reason for concern diagrams. They're linked to the 5 original bars, but they're also regional bars. There are also sectoral bars. In total, there's 3 or 4 pages with these kinds of diagrams to actually show the risks in different regions. And I think it's quite a big advancement. What they also did in these diagrams is actually the transition between the color from low risk to higher risk to unacceptable risks is actually estimated with a value. Are we very, very sure about this threshold, or are there still a lot of uncertainties? So there's an additional assessment into that part. So I'm personally very, very happy that a figure that I started in now 20 years ago is actually become some of the mainstream communication between the scientists and the policymakers to communicate the risks. Also, one of our projects, which was called the A-Team project, these are not a group of strong men and one woman in a black van, but the A-Team stands for Advanced Terrestrial Ecosystem Analysis and Modeling. And this was a very big European project which went from 1998 to 2005. And the synthesis paper was published in 2005, in late 2005 in Science. And the advantage of A-Team was that it used unified scenarios for climate, demography, land use, and bioenergy. These scenarios were discussed with stakeholders from various sectors to actually enhance their reliability. And that helps also to identify the vulnerabilities for certain developments. And one of the innovations of this project, the earlier climate change impact studies were always focusing either on agriculture, on water supply, on hydrology, on tourism, etc. Here, we brought all those sectors and regions together and used comparable scenarios. So we could compare the impacts of the different sectors together because the starting point was the same. And also biodiversity was included in carbon sequestration. Now, what we did here was running these scenarios up to the end of the century by using regionalized transient climate change scenarios. And it's one of the first scenarios, first studies that really took such a comprehensive approach, and therefore it's probably also highly cited. I will give one example, and that's changes in water stress for Europe. And you see the water stress increases in the different scenarios. There are differences between the scenarios, the difference between the different climate scenarios. You see that especially in the Mediterranean, there is enhanced water stress. Now, I was watching the news yesterday evening, and there was a small little documentary about water stress in France. There are already 60 municipals which actually do not have drinking water from the taps. Should be tankers bringing it to them. So the water stress is actually real. And the other impacts include forest fires, very much driven by land use change, but also climate, flooding, droughts, decline of biodiversity, agriculture production, soil carbon, and one of the aspects we looked is also the winter tourism, and that's less. And the impacts we calculated in this study, we actually all see happening. But there is one very, very big but. We see these impacts happening, but the impacts by A-Team were projected for the end of this century and not for the beginning of this century, because 2020, 2022 is still in the beginning of this century. So things are happening much earlier than we were actually thinking before. And they're happening on a larger scale. And why is that? Now, if I look at our analysis in A-Team, we used a gradual climate change. We ignored the extremes. If we look at the impacts which you see at the moment, they are all induced by extremes. And that's why they move much earlier. And so the extremes we see at the moment will be common weather towards the end of this century. But in the reason for concern diagram, extreme climate change is one of the bars, but in the impacts, it's actually not very well established. So we have to look much stronger at the consequences of extremes and try to find a way to put the extremes into the scenarios as well. And then we get much more realistic scenarios. Last year, I was also involved in a unique report by the IPCC, but combined with IPBES, the intergovernmental platform on biodiversity and ecosystem services. It's also an assessment body looking at ecosystems and ecosystem services and trying to support the Convention on Biological Diversity. And this report actually looked at the beneficial or the synergies between climate change and biodiversity, but also the trade-offs between them. They looked at the impacts of the different land use change, of the different scenarios, but one of the last chapter, which I was involved in, looked very much on the mitigation activities for climate change and how these mitigation activities would actually affect biodiversity. And one of the conclusions of this report is that climate change mitigation, for example, by planting single species forests to sequester quick carbon or increase bioenergy crop production, is generally negative for biodiversity. However, most biodiversity measures are beneficial for climate protection. So if we really, or if policymakers really focus on solving the climate crisis and forget biodiversity, then the solutions to the climate crisis will actually worsen the biodiversity crisis. So you really have to bring those things together. But there's very, very little literature in the studies in the scientific literature who actually study that and draw conclusions. So the IPCC report on biodiversity and climate change is a little bit inconclusive. And therefore we wrote this spring the paper Governing for Transformative Change Across the Biodiversity Climate Society Nexus, where we try to integrate the policies needed for climate, for biodiversity, and also for sustainability. And by really looking at the co-benefits and the detrimental impacts of the different policies and bringing them together and optimize the whole system. And this is a new field of science which links the natural science, what are the processes, what's possible there, with a lot of social science, political science, economics, and governance science. And I'm close to retirement at the moment, but I hope that in the coming 3 decades, this field will prosper and actually produce results. Now, in the paper, we actually gave some principles that actually help to set such a transformative governance system that looks and integrates several problems at the same time. You should look at multifunctional interventions. You should strongly integrate and innovate across scales, not only local, but also regional and global and international. You should create coalitions of support, very much bring the solutions to the people, but also involve them in developing the solutions. And you have to ensure equitable approaches. That's very much also in the climate discussion going on, etc. And you have to build the social tipping points where you actually make that transition. So here I come to my conclusions. We had a wonderful, still have of course, student and research collaboration with TM and Wageningen University, and it has led to a whole set of interesting theses and insights on climate change impact, ecosystem services, and ecosystem management. The other conclusion is that the science on climate change impact is robust. It's still incomplete, but more regions have to be studied. Observed impacts are significantly attributed to local changes in climate and extreme weather events, and impacts projects that prove to be very, very conservative. So we actually have to become more realistic. The Paris Climate Agreement and its targets is scientifically very well motivated, but keeping to those ambitious targets is not without risks. There will be impacts, and we have to adapt. If the targets are not reached, suffering will be widespread. And finally, much more attention must be given to trade-offs and co-benefits between climate change and biodiversity. The international policies at the moment are very poorly adjusted and integrated, and they should be reported by more science, but also by more people. Thank you very much for your attention.
Thank you, Mr. Manas, for your presentation and conclusions. İcazatlarınız bilen asosiy mavzularning birinchi qismi yakuniy asosiy mavzulardan biri, ya'ni QS tashkilotining regional direktori Xristolyubov Sergey Vladimirovичga bersin. Сергей Владимирович, у нас связи.
Здравствуйте, уважаемый Бахадир Суюнович. Здравствуйте, уважаемые участники конференции по случаю 70-летия Уктама Пардаевича Мурзакова. Скажите, пожалуйста, хорошо ли меня слышно и видно ли экран? И мне, наверное, следует отключить перевод, потому что все будут его слышать два раза, но я не знаю, как это сделать. Так, вот, нашел, все, сделал. Так, спасибо еще раз большое за возможность выступить на такой представительной конференции по такому выдающемуся случаю, как юбилей Уктама Пардаевича Мурзакова, ректора Ташкентского института инженеров ирригации и механизации сельского хозяйства, с которым в этом качестве международному рейтинговому агентству QS, всей нашей команде, довелось поработать активно на протяжении нескольких лет. И мы очень ценили возможность работать именно с Уктамом Пардаевичем, с его очень высокопрофессиональной командой. Поэтому спасибо большое за возможность поделиться некоторыми мыслями о том, что нам удалось вместе сделать и каковы перспективы этой работы на несколько лет вперед. Можно сказать, прежде чем я начну показывать материал, у меня буквально 10 минут есть, как мне сказали, что Ташкентский институт инженеров ирригации и механизации сельского хозяйства под руководством Уктама Пардаевича стал первым узбекским вузом, который вошел в рейтинги, международные рейтинги. И здесь мы говорим про рейтинг лучших университетов развивающихся стран Европы и Средней Азии 2020 года, который был опубликован в декабре 2019 года. Таким образом, Узбекистан, вся система высшего образования Республики Узбекистан появилась на международной карте благодаря именно Уктаму Пардаевичу и его высокопрофессиональной команде, которую он сплотил и собрал для достижения очень амбициозных целей по повышению глобальной конкурентоспособности узбекских вузов, о чем мы сегодня с вами переговорим. С 2019 года, с момента вхождения института в наш региональный рейтинг, количество узбекских вузов в нашем рейтинге выросло, их результаты с каждым годом улучшаются. В этом году было подписано очередное соглашение между Министерством высшего и среднего специального образования Республики Узбекистан и QS о работе по достижению новых результатов в различных рейтингах, о чем мы сегодня с вами очень коротко поговорим с учетом времени. Эта работа, она носит государственный характер и отражение свое нашла в стратегии развития нового Узбекистана на 2022-2026 год, в которой зафиксирована президентом Республики Узбекистан Шавкатом Мирамовичем Мирзиёевым цель о вхождении 10 потенциальных высших учебных образовательных учреждений для появления их в рейтингах QS и Times Higher Education, что буквально уже через 4 года нужно сделать. Согласно этой цели, этой задаче, нужно отобрать эти 10 потенциальных высших образовательных учреждений и наращивать их показатели для вхождения в соответствующие рейтинги. Наша миссия, о которой мы говорим в нашей презентации, она заключается прежде всего в том, чтобы оказывать содействие мотивированным людям во всем мире в реализации собственного потенциала через поддержку международной мобильности, образовательных достижений, карьерного развития. То есть все те рейтинги, которые мы публикуем, они призваны помочь абитуриентам, студентам и их родителям сделать правильный выбор университета, образовательной программы, который позволит раскрыть молодым талантливым специалистам свой потенциал. Если говорить в целом про регион Центральной Азии, то можно заметить, что 16 вузов у нас пока что входит в наш лучший рейтинг лучших университетов мира, QS World University Rankings, 40 вузов из региона, в том числе 4 вуза из Узбекистана входят в региональный рейтинг, 7 вузов входят в предметные рейтинги лучших университетов, в том числе 1 вуз из Узбекистана, это Национальный университет Узбекистана имени Мирзо Улугбека. 3 вуза из Казахстана у нас участвуют в рейтинге лучших молодых университетов мира, пока в этом рейтинге нет узбекских вузов. 4 вуза из Центральной Азии участвуют в программе QS Stars, и нам очень приятно сказать, что в число этих вузов теперь входит Ташкентский государственный юридический университет, и 1 вуз из Казахстана у нас входит в рейтинге MBA. Вот такая картинка по Центральной Азии на текущий момент у нас сейчас. Важной новостью, о которой было объявлено на прошлой неделе, является перемещение вузов Центральной Азии из рейтинга лучших университетов развивающихся стран Европы и Средней Азии в рейтинг лучших университетов Азии. То есть теперь вузы из Узбекистана будут входить в рейтинг с такими университетами, как Университет Токио, Университет Квинсленд Австралии, Национальный университет Сингапура, Университет Пекина. И в такой компании, конечно, быть очень престижно и почетно. Вместе с тем, конкуренция с такими университетами предлагает наращивание ряда индикаторов, которые отражены в методологии этого рейтинга лучших университетов Азии. И речь здесь, конечно, идет прежде всего о наращивании репутационных показателей, о том, чтобы узбекские вузы больше узнавали на международной арене, а также наращивание показателей научной производительности и интернационализации. Впервые у нас узбекские вузы будут оцениваться в наших региональных рейтингах по 2 новым индикаторам. Это доля приезжающих на учебу студентов и доля уезжающих на учебу студентов. Таким образом, в нашем рейтинге лучших университетов мира показатели интернационализации, показатели академической мобильности будут впервые играть очень важную роль. Это сильно отличается от той методологии рейтинга лучших университетов развивающихся стран Европы и Средней Азии, в которой этих 2 показателей не было, но был показатель по веб-импакт, по присутствию в онлайн-среде и по качеству веб-сайтов вуза. Кроме того, мы с радостью отмечаем, что вот тот путь в рейтинге, который под руководством Уктама Пардавича был начат в 2020 году, получил свой успех в рейтингах лучших университетов мира по отдельным предметам и предметным категориям. У нас впервые в этом году в наши предметные рейтинги, вот здесь, может быть, не очень хорошо видно, но вот та зелененькая точечка, которая вот здесь вот есть по математике, это вот то самое 401 место, на которое у нас вошел, 451 место, на которое у нас вошел Национальный университет Узбекистана в этом году. Это первое появление узбекского вуза в предметных рейтингах лучших университетов мира, чему мы, конечно, очень рады и уверены. Вот все красные точки, которые вы видите на этом графике, это позиции узбекских университетов за пределами публикуемой части списков предметных рейтингов по довольно широкому спектру предметов. И здесь можно видеть просто огромный потенциал для участия узбекских вузов в предметных рейтингах в части по таким предметам, как искусство и дизайн, современные языки, управление гостеприимством и отдыхом, социальная политика и управление и инженерные специальности в области нефти и газа. Здесь можно только порадоваться, что вот такое большое количество красных точек на этом графике говорит о потенциале дальнейшего повышения узнаваемости узбекских вузов в международных рейтингах и на международной арене. Коротко поговорим об источниках репутации. Как узнают узбекские вузы на международной арене? И здесь вот мы видим 4 столбика данных. С левой стороны 2 столбика говорят нам о том, с какими странами узбекские университеты работают активнее всего с точки зрения публикации научных трудов. А с правой стороны мы видим, как узбекские вузы оценивают, как узбекские эксперты оценивают зарубежные вузы и как зарубежные эксперты оценивают узбекские вузы. Откуда приходят номинации, голоса в тех опросах репутации, которые мы проводим ежегодно в первом квартале каждого года для того, чтобы оценить показатели академической репутации и репутации среди работодателей для всех тех вузов, которые входят в наши рейтинги. И здесь можно видеть, что в 5 стран, с которыми у узбекских вузов наибольшее количество публикаций, входят Россия, Китай, Германия, США и Казахстан. Наибольшее количество цитирований приходится на научные труды, которые узбекские ученые публикуют с авторами из Соединенных Штатов Америки, России, Китая, Индии, Германии. Вместе с тем, по мнению узбекских экспертов, которые принимают участие в нашем опросе, лучшие вузы находятся, большинство лучших вузов находятся в Казахстане, в Италии, Великобритании, США, Южная Корея. И самое интересное, кто же голосует за узбекские вузы в нашем опросе, откуда берется репутация узбекского высшего образования, а берется она из таких стран, как Казахстан, Россия, Кыргызстан, Южная Корея и Украина. Вот эксперты этих стран голосуют за узбекские вузы в наших опросах чаще всего. Очень важный момент, и я постараюсь завершить быстрее, это наукометрические показатели. Эту картинку, я уверен, много видели на разных конференциях и много о ней говорили. Если посмотреть на абсолютное количество публикаций, которые есть в Узбекистане, мы с вами знаем, что до 2011 года Узбекистан занимал уверенно 1-е место по количеству публикаций среди стран Центральной Азии. Вместе с тем Казахстан предпринял ряд, ваши соседи в Казахстане предприняли ряд усилий по наращиванию публикационной активности. И начиная с 2018 года Узбекистан начал опять догонять Казахстан. И рост публикаций с 2018 года, он просто виден на этом графике, вот 2-я линия голубым цветом, просто невооруженным взглядом. Вместе с тем, очень важно при наращивании показателей, связанных с количеством публикаций, не забывать про качество, потому что если мы посмотрим, что обеспечило такой взрывной рост публикационной активности в Узбекистане, то можно будет очень легко заметить на следующем графике, что этот рост возник в журналах низших квартилей, 3-го и 4-го квартиля, то есть низко цитируемых журналах. И поэтому показатели Узбекистана имеют существенные возможности для наращивания присутствия в влиятельных научных изданиях, которые читают большее количество ученых и цитируют большее количество исследователей. Если коротко, то наши основные рекомендации по дальнейшему участию и продвижению в рейтингах сводятся к тому, чтобы, первое, обеспечить существенный кадровый фундамент для этой работы, это привлечь новых ученых и преподавателей, сотрудников, научные исследования, задействовать молодых специалистов в науке, подготовить специалистов по работе с рейтингами и наукометрическими решениями в различных высших учебных заведениях страны. Второе – это, конечно, наука, потому что то, как мы присутствуем в международном научном ландшафте, в международной научной повестке дня, сказывается самым существенным образом на нашей академической репутации, которая имеет существенное влияние и значение в методологиях разных рейтингов, не только QS. Кроме того, отдельное внимание мы предлагаем уделять текущим перспективам международных исследовательских коллабораций, создание совместных лабораторий с зарубежными вузами, запуск программ академической мобильности, приглашение на работу хотя бы на семестр, может быть, на год или на несколько лет талантливых преподавателей, которые могли бы существенно усилить международный аспект в работе высших учебных заведений страны. Ну и, конечно, веб-сайты, присутствие в социальных сетях, желательно на английском языке, оно, конечно, позволит обеспечить нам еще большую узнаваемость в самых разных странах и уголках мира, узбекских университетах, узбекских высших учебных заведений. Коротко уложился. Большое спасибо за внимание. Было очень приятно выступить на такой представительной конференции. Желаю вам успехов в работе мероприятия. Большое спасибо организаторам за приглашение.
Большое спасибо. Anjuman ishtirokchilari O'ktam Pardayev Umurzoqov xotirasiga bag'ishlangan xalqaro ilmiy anjumanning ochilish marosimidagi barcha ma'ruzalarimiz tugadi. Hammalaringizni universitet oldi qismiga fotosessiyaga taklif qilamiz va dastur bo'yicha soat 1 dan 2 gacha tushlik e'lon qilinadi mana shu yerda o'zida va 14:00 dan anjumanimiz yana davom etadi. Manzil tushlikni manzili oshxonada shu.
अगर ध्यान दीजिए बहुत से नारी होने के
slaydini almashtiraman. O'sha prezentatsiya.
Да, через 5 минут. Да, мы будем просто. Keling, bo'lmasa o'rtadan qolib ketmasin. Az kelsa aytaman.
Hello, can you hear me? Hello to the organizer of the conference. Can you hear me, organizer of the conference? I wonder what time, when will the conference start? Hello, can you hear me? Hello. I think now 2 p.m. in Uzbekistan. No? Can you hear me? Hello? Can you hear me? No? Can you hear me? Hello? Hello?
Так, разрешите поприветствовать всех участников конференции. У нас уже время вышло, поэтому давайте начнем. Я думаю.
So,
уважаемые коллеги, мы продолжаем с вами вторую половину пленарного заседания. У нас, значит, согласно программе конференции, запланировано сегодня прослушать 19 докладов. Поэтому, значит, я бы всем предложил придерживаться регламента. На доклад отводится 15 минут. Значит, мы каждый доклад не будем обсуждать. Значит, сначала все докладчики доложатся, потом уже в конце, значит, мы устроим с вами процедуру вопрос-ответ. Поэтому 15 минут? 10 минут? Хорошо. Так, здесь поступило предложение, значит, каждому докладчику отводится 10 минут для доклада. Так, и хотелось бы попросить всех участников поближе располагаться, потому что у нас такое ощущение, что половины зала нет. Ladies and gentlemen, dear guests and colleagues, welcome to the second part of this plenary session of the conference. I would like to remind you once again the procedure rules for the plenary session of the conference. 10 minutes are allotted for reports. I ask all speakers to comply with the time limit. So let's begin our session. The first floor for the report is given to the first keynote speaker of the conference, Professor of Massachusetts Institute of Technologies, USA, Akfa University, Uzbekistan, Dr. Nurti Gurrema. Please come here.
Sure. Okay, so indeed it's great for you to be here, and I'm thankful for the organizer for the invitation. Today I will be speaking about a Lorenc ODE-based mathematical tool and how to approximate something known as structured singular value. Roughly speaking, a structured singular value is a tool that can be used to discuss stability and stability of feedback systems and control engineering. In other words, you can say that this tool basically helps us to link a bridge between numerical linear algebra and system theory or control engineering, okay? So just to give a brief introduction, I would like to say a few words about the background of the problem. So as you may know that, eigenvalue decomposition and singular value decomposition, these are quite famous tools in order to discuss stability of feedback systems. But the point is, when we are subject to have some kind of uncertainties corresponding to particularly linear time invariant systems, then in that particular case, we do need the generalization of singular value, or let's say singular value decomposition. And that's what we did in this particular article. So just imagine that you are given with the n-dimensional, either real or a complex valued matrix. So you can imagine this is any matrix, okay? It can be a square matrix or it can be a rectangular matrix. And then the second thing, we are given with a set of block diagonal matrices. So in this particular set, we have two kinds of blocks. So first we have repeated scalar blocks, where each identity matrix is scaled with the help of real or complex parameter, and then we have the number of full blocks. Next, please. So you can see here, first I have the number of repeated scalar blocks, and then I have the number of full blocks. And another interesting thing is that the size of each block can vary. So for instance, you can see that maybe for the full block, the first matrix can be, let's say, maybe a 200 by 200 dimensional matrix. And then at the end, maybe I can have a 1x1 simple matrix. And the same is true for the number of repeated scalar blocks. Yes. So our aim is basically to compute SSV, structured singular value, for the given matrix M with respect to B. But there is a problem. So the big problem is that the exact computation of structured singular value is an NP-hard problem. So if you know about complexity theory, so you can imagine the nature of NP-hard problem.
So that's why, since we have, NP-hard nature of this problem, so we need, the approximation of this quantity. So what we did in this particular article, we just, approximated the lower bounds of structured singular value. And the message of the lower bound is basically to discuss, the instability of linear feedback systems and control theory. Yes. Add, yeah. No, further. Yeah. Okay. Not that much reasons. Okay, so here is the definition of structured singular value. So the mu value basically, involves the computation of singular values. So our aim is basically to compute, the largest singular value of delta. So our aim is basically to compute the largest singular value of delta in such a way that our modified matrix I minus m delta must have at least one of its eigenvalue, which is 0. Okay, so if this is not the case, then of course, the exact value of mu value is 0. But that's not the case because we are not very much interested in that particular case because of application point of view. Otherwise, if we have, pure complex perturbations, in that case, instead of, to check the behavior of the determinant of the modified matrix, we do need the computation of the spectral radius, basically. So what do I mean by the spectral radius is basically, the computation of the eigenvalues, but in such a way that we just take, the largest eigenvalue from that particular set. Okay, so we have reformulated these definitions with the help of something known as structured epsilon spectral value sets. So structured epsilon spectral value set is nothing but it's the computation of an admissible eigenvalue lambda from the set of from the spectrum of this modified matrix epsilon m delta in such a way that the largest singular value must be bounded by 1. Okay, but on the other hand, if we have pure complex perturbations, then in that case, the structured epsilon spectral value set is a unit disk. So you can just imagine a disk in the complex plane. So our reformulation basically helps us to give the new definitions of the structured spectral value set. So basically you can see here two highlighted optimization problem. So one optimization problem basically involved, the minimization of the eigenvalue, while on the other hand, the other optimization problem involved the maximization of the eigenvalue. So I want to maximize eigenvalue in such a way that it reaches maximum value 1 and then it remains stable forever because of some practical reason. But on the other hand, the minimum eigenvalue must be 0. Okay. Okay. So basically, what we did, we proposed a methodology, and how do we solve these two problems? So just because of the lack of the time, I just want to share with you the results, what we obtained in this particular article. Okay, so can you just go at the end? Yeah, so you can move. Yeah, just skip these slides. Yeah, further, down. Yeah, okay, here, maybe. Yes, so this is a numerical experimentation. So for instance, I just want to share with you one example. So this is a 5 by 5. You can see that complex valued matrix, while I have this structured, while in the case of perturbations, I do have everything is in the complex basically. So for instance, you can see here, delta 1, delta 2, delta 3, they are pure complex. While on the other hand, the matrix delta 1 is a 2 by 2 complex valued matrix. So we just compare our results with the well-known results, which were computed by these two scientists, Packard and Doyle from Caltech, California Institute of Technology. So they got, the result for the computation of the lower bound of structured singular value, which is, yes, maybe next slide. Yeah, so this is 4.3720. But in our case, our proposed algorithm gives much better result as compared to the one which is proposed by John Doyle. So can you go down? Yeah, so here, this is 4.844, okay? So this is what we got, back in time. Yeah, so just to show you, so this is basically the monotonic behavior of the spectral radius of the proton matrix epsilon m delta.
So you can see that we have a monotonic behavior for the smooth trajectories for the eigenvalue. So it reaches maximum value 1 and then it remains stable forever. And so over here, yeah. So you can see that for a particular value of epsilon, which is the perturbation level, the exact value of the absolute value of lambda minus 1 is equals to 0. In other words, I reaches maximum value 1 and then I remain stable. Okay, so this is just the final slides. So I just want to show this statistical analysis. So for instance, in the first column on the left side, you can see that we have the dimension of the matrices. So for instance, if you see in the first case, we have 100 matrices where the dimension of each matrix is 5 plus 5. So in that case, out of 100 cases, so in 63 cases, we have the same results as proposed by the MATLAB algorithm. While in the 26 cases, we have much better results. While in the 11 cases, they have the much better result. But as you go down, for instance, if you take 100 matrices where the dimension of each matrix is 100, then you see that in 34 cases we have the same results, and 63 cases we have much better results, and 3 cases they have much better results. And if I move above, let's say 100 dimension, let's say maybe 1000, I don't know, maybe 2000 by 2000. So for that we need parallel computation or something like that. We much need powerful PCs for that. Thank you so much.
Thank you very much, Professor Muti Yurama, for interesting and informative report. The next floor for the report is given to the second keynote speaker of the conference, Dr. Akiyuki Kawasaki, Professor of the Institute of Future Initiatives of the University of Tokyo, Japan. He participated in Zoom online forum, so please.
Yes, thank you very much for your kind introduction. And I'm very happy to be, I'm very honored to give a presentation at this high-level conference. So thank you very much for the organizers. So let's start my talk today. The proactive disaster risk reduction investment, case of evidence-based policy making in Japan. So now, firstly, let me show the global risk report by World Economic Forum. As you can see here, now that the many business leaders and governmental high-level person considers that the extreme weather and disasters are the biggest global risk. In the past, the other issues are the main topic, but now, due to the increase of climate change, business leaders also consider that the disaster risk is the biggest issue. And in your country, Uzbekistan also had some disasters in the past. The reservoir dam in Uzbekistan had a partial collapse in 2020. And in the past, the big Tashkent earthquake hit in 1966. So disaster risk is also one of the important issues in your country. Let me firstly show a graph about the disaster risk reduction investment in Japan. So this graph shows how the national government of Japan spent their national budget for disaster risk reduction since 1962. So this orange graph shows that in our country, every year, about 1% to 0.5% of the total GDP was spent for the disaster risk reduction. And 80% of that budget is used for the preparedness, not for the emergency response or recovery. So that this graph shows how our country considers that the disaster risk is an important issue as a nation. So, however, the impact of the disaster risk reduction investment are usually invisible. So, justifying the impact of the disaster risk investment is always faces difficulty by the many countries. So, given that disaster risk reduction structures or facilities are constructed and work well, it's very hard for citizens to imagine the possible damage without such measures. So many countries have difficulty to spend their budget for disaster risk reduction. So you may have a question why our country, Japan, keep scaling such big budget for proactive disaster risk reduction. So here is the answer. The promotion of evidence-based decision-making by policymakers. So this is essential. So in order to promote it, in our country, we had a systematic disaster damage data collection from a long time ago, and conduct a future disaster damage and cost-benefit assessment by using the science and technology. So let me introduce this in my talk later. So let me show one case in Japan. So we had a big flood disaster in Niigata Prefecture in 2004. 15 people died and 21,000 buildings were damaged in this area. So after this disaster, we had a river improvements. So based on the 2004 flood experience. And as you see in this picture, we conducted like this kind of levee improvement or channel widening and excavation. We spent about $1 billion for this improvement. Then, at the same time, not only this kind of structural measures, we also conducted non-structural measures for improving the information sharing among the river managers using information technology. After 7 years ago, the much larger rainfall fall into this river basin in 2011. It was 6 times larger than 2004. So as you see this graph, total rainfall in 2011, it was 1.6% of the increase of the rainfall. However, the number of the buildings damaged and the number of fatalities or missing was largely reduced. More than 90% reduction of the building damage and fatalities. So this shows, and the total economic damage by the flood was also reduced to just 95% of reduction. So in 2004, 150 billion yen was the economic damage, but it was reduced to just 3.5 billion yen. So this means that the best cost benefit of this improvement was very big. So that the effect of the disaster risk reduction investment was successfully proved from this kind of case. But why? But this was possible because of the collection of actual damage and loss data. In Japan, we have been collecting disaster damage and loss data on a systematic way from the 1961. So all the statistics was collected by the government from local level to central. Then actual damage loss was calculated. So like this, after disaster happened, that the municipalities and public services are supposed to collect such disaster information, including economic loss. Then all the data was collected in a prefectural level. And then the central government assemble and make statistics. So along with the basic survey of flood disaster damage, so estimation of the possible future damage by flood disaster is possible. And this is required to justify the investment of proactive disaster risk reduction. So, based on the collected information, we conduct future cost-benefit analysis in the case of the without any countermeasure. So in the left-hand side, in this case, expected flood-prone area without improvement. So if we don't see anything, the flood area would be expected to become large. So on the right-hand side, this is the expected flood-prone area with the improvement. So we can expect that the inundation area will be largely reduced. Then at the same time, the amount of the economical damage is also calculated in the case of with and without improvement. Based on this, the government can calculate the benefit of the investment in advance. So this is the summary of my slide presentation. So evidence-based policy making is essential for implementing the proactive DRR investment. And justifying DRR investment, the disaster risk should be clearly demonstrated with economic analysis. So actual damage data become strong evidence. So now the method for damage data collection and cost-benefit analysis are not yet standardized in many countries. So this is a place for improvement. And government officials should have the capacity to communicate with science and technology. So in order to promote this, academia like us should closely work with the government official from science and technology aspect as well as capacity building. So as my final message is the support from and collaboration with academia are essential to promote proactive disaster risk investment, and developing a framework for embedding academia in national disaster policy making is essential. So particularly for the climate change adaptation, the extreme weather are expected in many countries, including in Uzbekistan. So the government and academia should closely work together for making such disaster risk reduction investment. So that's all my talk. So thank you very much for your kind attention.
Thank you very much, dear professor, for interesting and informative report. So the next floor for the report is given to the next keynote speaker of the conference, Гончаренок Игорь Иванович, Doctor of Physical and Mathematical Sciences, Professor, joined Belarusian Uzbek Intersectoral Institute of Applied Technical Qualifications, Uzbekistan. The presentation theme is science with use for the innovative development of a young sovereign state, new vector of Uktam Murzakov. Please.
Thank you very much, and I will switch my speech from English into Russian. С вашего позволения, я перейду с английского на русский. Ассаламу алейкум, добрый день, уважаемые коллеги и друзья. Значит, мы представляем с профессором Жабуровым директорат совместного белорусско-узбекского межотраслевого института прикладных технических квалификаций в городе Ташкенте, который мы позиционируем как интеллектуальная экосистема. И следующий слайд, пожалуйста. Ну а название моего доклада будет, нашего доклада вот такое: «Наука с молодежью для инновационного развития молодого суверенного государства. Новая ось профессора Умарзакова». Я опять-таки позволю себе переключиться с очень насыщенных научных количественных докладов, которые сделали замечательно мои коллеги, к некому философскому осмыслению того, что сейчас происходит в мире. И особое внимание обращу вот на наследие Уктама Пардаевича, поскольку было много сказано сегодня, но, на мой взгляд, очень важно отметить и такое его качество, как эффективный управленец. А это значит человек, который способен посмотреть на проблему широко, стратегически и выявить определенные глобальные тренды в развитии. Следующий слайд, пожалуйста. Вот его цитата. «Наука и образование – это новая ось, вокруг которой структурируется современное общество». Следующий слайд, пожалуйста. И вот еще одна работа, которая также связана с нашей презентацией. Это аналитический доклад, который был сделан научно-исследовательским университетом Российской Федерации. Это Высшая школа экономики. И назван он был «Наука без молодежи». Поэтому в нашем докладе вот как раз нам очень важно подчеркнуть, что Узбекистан, как не только молодое суверенное государство, но и государство молодежи, где более 60% населения составляет молодежь до 30 лет. А это значит государство, имеющее мощный потенциал. Так вот, выводом, верните, пожалуйста, выводом из аналитического доклада служило следующее. Российского аспирантура остается самым отстающим уровнем образования в Российской Федерации. Я могу обобщить этот тезис и в том числе и на Беларуси, возможно, не позволю себе на другие государства, но, на мой взгляд, это большая проблема, которая сегодня стоит перед нами, которую понимал профессор Умарзаков и которую он активно занимался, создавая научно-исследовательский университет в Узбекистане. Следующий слайд. Ну а теперь я буду немножко сокращаться. Вот здесь есть выдержки из международных трендов. В то время как во всем мире, наращивается потенциал молодежи с учеными степенями и званиями, представителей научной элиты, высшей научной квалификации. К сожалению, для ряда стран бывшего Советского Союза эта тенденция совершенно противоположная. И особое значение здесь имеет, конечно, техническое образование. Очень отрадно, что вы сохранили или ваш университет сохранил в своем названии слово «инженер». Но и наш институт тоже имеет такое же отношение к этому, называясь прикладных технических квалификаций. В данном случае речь идет не только об интеллектуальной безопасности государства, которую мы должны обеспечить, но речь идет о национальной безопасности государства, если мы не задумаемся над теми тенденциями, которые на сегодняшний день происходят. Следующий слайд. Ну, понятно, что мы живем в непростом мире. Появились новые вызовы и глобализация, и, как ни странно, интернационализация. Мы переоцениваем и недооцениваем знания. Я провел несколько лет в Японии как ученый. И для меня было, конечно, услышать о том, что японцы не смогли предсказать цунами и соответствующую катастрофу на атомной электростанции, было удивительно. Не все наука в состоянии сделать, а это значит недостаточно, видимо, у нас профессионализма. Ну и нестабильность и неустойчивость ценностей, которые происходят в настоящем виде, мы достаточно нам включить средства массовой информации, все мы это увидим. Следующий слайд, пожалуйста. Появились новые принципы реальности, социальное расслоение в обществе, расшатывание политических систем, прозрачность мира. Мир стал прозрачным, мы знаем все и обо всех, и самое главное, о нас знают многое. Ну и усиление идей популизма, радикализма и так далее. Следующий слайд. Как результат, мы образуем людей для неопределенного будущего, которое эта неопределенность будет возрастать. Вот коллеги до меня рассказывали это в количественной формулировке. Мне тоже это просто сделать, но я этим не буду заниматься. Буду только говорить вот о качественных характеристиках. И мне очень нравится европейский тренд о том, что образовательные системы должны быть реформированы. Так, следующий слайд. Чтобы готовить людей для рабочих мест, которые еще не существуют, использовать технологии, которые не изобретены, и научить решать проблемы, которые даже еще не возникли. Я еще раз, коллеги, обращаю внимание, что я не читал глубоко технических работ профессора Умарзакова, но то, что я прочитал, оно как раз направлено на вот это, и об этом он мыслил в последние свои годы. Следующий слайд, пожалуйста. Возможно, учиться на прошлом может каждый, но сегодня это уже мало. Сегодня надо учиться на будущем. И это принципиальный вопрос, опять о котором много идет речи. Следующий слайд. Все, что работает, устарело. Это принцип инновации, к сожалению. Если что-то заработает, можно уже сдавать на склад. Поэтому мы должны заботиться и думать о том, что, возможно, еще не стало работать. Следующий слайд. Значит, часто мы смотрим на другие системы образования и цитируем американскую систему. Вот эксперт американский говорит, даже если это хорошая система, но она не значит, что она совершенная. Следующий слайд. Университет 3.0, тоже говорится об этом много, и, кстати, об этом как раз писал Уктам Пардаевич. Предпринимательская культура. Но тут надо преодолеть эффект колеи. Вот иногда мы попадаем в эту колею и не можем из нее выйти. И это очень очевидно. Новые технологические и бизнес-компетенции, которые мы должны сформировать у наших студентов. И это тоже реальность. Ну и никто не отменял коммерциализации, о том, что необходимо уважать, значит, приносимый экономический эффект. Следующий слайд. Можно классифицировать университеты вот по прибавочной или добавленной стоимости, как это делал когда-то Карл Маркс. Идем от университета 1.0 к университету 3.0. Различие во многом связано с той добавочной стоимостью, которая не только, значит, монетизируется, она в том числе и объеме новых знаний и компетенций, которые мы генерируем. Следующий слайд. Четвертая промышленная революция. Мы переживаем массовое внедрение киберфизических систем в экономику, жизнедеятельность человека, цифровая экономика. Опять обращаю внимание на Умарзакова, который говорил о цифровизации университетов, посвятил ряд своих работ цифровизации сельского хозяйства. Аддитивные и квантовые технологии звучат как-то, иногда звучали когда-то экзотически, но сегодня это уже реальность. Следующий слайд. Поиск новой модели научно-образовательного центра. Посмотрите, из института появился новый научно-исследовательский университет. И это не только смена названия, это глубокое философское пересмысление роли университета в настоящем в жизни общества и прежде всего узбекского государства. У всех на слуху Массачусетский технологический институт, который лидирует во многих рейтингах, в которых объединились во многом уже когда-то, не мы, новаторы в этом деле, многие идеи. Появляются новые модели, например, поскольку я в то же время представляю Белорусский национальный технический университет, это связка Ташкентского ирригационного института, условно назову, и БНТУ. Ну и мы очень молодой вуз, 2 года нам всего, но амбиции очень большие, но без стратегии, о чем говорил Умарзаков, тоже невозможно. Следующий слайд. Креативность. Вот призывал он к креативности, но, к сожалению, и я уверен в том, что все дети и все наши студенты очень талантливые, но, к сожалению, социальная среда, в том числе и мы с вами, как профессорско-преподавательский состав, иногда эту креативность немножко уменьшаем. И в этом тоже состоит большая проблема. Я студентам всегда говорю, что вы гораздо умнее меня, профессора и доктора физмат-наук, я просто иногда знаю больше. А молодежь надо уважать, и надо, это основной генератор наших значит, идей. Вот, слава богу, сидят студенты БНТУ, я надеюсь, они тоже это внимательно слушают. За вами, ребята, будущее, слава богу, что вы здесь находитесь. Следующий слайд. Опять обращусь к цитате Уктама Пардаевича. Для осуществления требуемых инноваций сама научно-образовательная сфера обязана применять в своей деятельности самые современные инновационные технологии. Следующий слайд. Модель инноваций. Вот и в Советском Союзе все занимались инновационной деятельностью. Но это была линейная модель инновации. Появляется нелинейная модель, а нелинейная модель отличается от линейной, что следующий слайд, что возникает простой коэффициент, который называется восприимчивость. Ну, по крайней мере, в нелинейной физике, которой я занимался, это позволяет открыть нам много новых эффектов. Так вот, и восприимчивость к инновациям – это восприимчивость, которую мы должны воспитывать у наших инженеров и будущих руководителей, что еще гораздо принципиальнее. Вот такая восприимчивость к инновациям была у руководителя профессора Умарзакова. Следующий слайд. Компетентностная или синергетическая модель. Одна профессия, точка бифуркации, множество карьерных возможностей и основа нелинейной модели, которую я сказал, листаем. Национальный хаб как лидер. Много говорится об этом. Новое слово появилось в связи с созданием информационных технологий. И очень важно, чтобы вот эта реализация, которая была записана в концепции развития высшего образования Республики Узбекистан, где он представляется как хаб международных образовательных программ, реализовалась. Но для этого необходима влиятельность и интеллектуальное лидерство, не только политическое, но и интеллектуальное. Для этого, еще раз, я хоть и не инженер по основному образованию, но практически убежден, что все инновации, или 90% в мире, создаются инженерами. Следующий слайд. Ключевые ценности научной и инновационной деятельности. Понятная истина. Вот все время с математиком Жабуровым мы говорим об этом. Это для математики. Это прогресс и ответственность ученых и инженеров. Следующий слайд. Значит, синергетическая модель не простая арифметическая ошибка, как 2 плюс 2 равно 5. Но что-то новое должно появляться. Идем дальше. Ну вот, а теперь вот про ту новую ось, о которой я прочитал в работах профессора Умарзакова. Это ось образования и науки. Так вот, если общество представить как сложную синергетическую систему, она очень легко формализуется в координатах открытости, нелинейности и нестабильности. Но чтобы эта система была устойчивой, необходима ось. Вот эта ось образования и науки, которую и писал профессор Умарзаков. Следующий слайд. Ну, модель подготовки кадров и модель эффективного управления. Я сам лазерный физик, поэтому, извините, представляю лазерную модель, но она работает и в научной подготовке. Создаем инновационную среду, есть руководитель и есть управление университета. Мы должны подпитывать это все ресурсами и с помощью зеркал подводить, подгонять каждую персональную траекторию талантливого человека, поэтому он талантлив, потому что он индивидуален, под результат на выходе, который обеспечивает когерентность, направленность и инновационный результат. Следующий слайд. Эффективное управление, опять к управленцу, планирование, отбор, научная школа, академическая мобильность, без которой невозможно. Дальше. Ну, если даже стоит, всегда студентам говорю, но и здесь, поскольку, извините, и хорошо, что молодежь присутствует, значит, любая проблема можно превратить, а ребята, можно почитать эту хорошую книгу «Поцелуй лягушки», когда любая проблема превращается в хороший результат. Следующий. Ну вот ТИМСК, на мой взгляд, это университет, не только исследовательский, но и это педагогика лидерства. А в основе вот этой школы педагогики лидерства стоял профессор Умарзаков. Значит, мы должны использовать сетевые режимы работы как наиболее эффективные в информационном обществе. Инновационная восприимчивость, уже сказал, интеллектуальное лидерство. Идем дальше. Что предлагается в аналитическом докладе? Я заканчиваю, друзья. Отказ от стипендий и создание массовой грантовой поддержки аспирантов и студентов магистратуры. Стимулирование продуктивного научного руководства. $3000 увидел за научного руководителя, у которого защитился аспирант. Но это планы, коллеги, это планы. Удержание исследовательски ориентированных студентов и внедрение интегрированных программ исследовательская магистратура и аспирантура. Развитие целевых аспирантских программ, подготовка в интересах регионов и двойное научное руководство, оно не ново. Но, коллеги, когда мы со временем приходим к научному руководству, понимая, что перед нами продукт конкретного общества, поэтому очень важно для узбекского аспиранта иметь ментора, гражданина, прожившего в Узбекистане, научного руководителя, и, возможно, в новом государстве, например, в Беларуси, для того, чтобы провести вот этот процесс достаточно эффективным. Следующее. Ну вот, европейская мобильность, значит, тут говорилось об этом много, идем дальше. А вот это уже заключение. И оно звучит очень как напутствие для всех нас, что нужно оценить бесценный опыт и свои эволюционные накопления. Вот нельзя рушить сразу все. Для нас очень важно сохранить то, что у нас было, в том числе и в совместном историческом прошлом. Кадровые, научно-образовательные, методологические, материальные, структурные, исследовательские, инновационные, чтобы сделать несколько шагов к обновлению. Сделать это необходимо, и этот путь преобразования и открытий, путь трансформации ТИМСХ в современный исследовательский университет. Ну и последний, наверное, слайд, да, вот наши координаты. Уважаемые друзья, большое спасибо за внимание.
Спасибо большое, уважаемый Игорь Иванович, за содержательный и познавательный доклад. The next floor for the report is given to the next keynote speaker of the conference, Professor Hans-Peter Nachtneber, University of Natural Resources and Life Sciences, Institute of Hydrology and Water Management, Professor Emeritus from Austria.
Yes, so I hope it's working. We start, I think, here. So, welcome everybody. Can you see and hear me? Hello?
Yes.
Yes, good. So, distinguished audience, it's a great pleasure and honor for me to contribute to this important conference. Unfortunately, I could not manage to attend physically because I had some timely constraints here in Austria. So therefore, I'm pleased to deliver a talk online. And I would like to speak about collaboration approaches between Austria and Uzbekistan, mainly addressing water-related problems in the region. I'm coming from the University of Natural Resources and Life Sciences in Vienna, Austria, and I was formerly professor for hydrology, water management, and hydraulic engineering. In the meantime, as you can see, I'm retired. I would like to address very briefly 3 topics referring to collaboration between University TIAME and BOKU, what did we achieve and what could be done in the future. What are the reasons for the collaboration? Both countries, Austria and Uzbekistan, have their national territories in international river basins. The economy in the basin is quite different, and both countries observed major political changes in the last decades. We also find water-related issues in both regions. In the Danube Basin, it's more related to quality issues. In Uzbekistan, it's considering both quantity and quality issues. And why the collaboration with TMA? Because several EU universities like Wageningen University, Boku University, University Poznan, and in Warsaw, they have quite a similar profile like TMA. Few words about, to get an impression about the scale. So the RLC basin is about twice as large as the Danube River Basin, while the number of inhabitants in the Danube Basin is larger. About 8.1 million people live in the basin. The Danube Basin, as you can see from the map, is quite international. It's the most international river basin of the world. In the upper part, the upstream countries are Germany, Austria, Czech Republic, Slovakia, Slovenia, and in the middle of the basin, we have Hungary, Croatia, Bosnia-Herzegovina, Serbia, and Montenegro. And then proceeding downstream, there are major parts of the countries of Ukraine, Romania, Bulgaria, and Moldova located in the basin. Additionally, there are some small contributions from Switzerland, Italy, and from Kosovo region. The RLC basin is composed of territories of Kyrgyzstan, Tajikistan, and Afghanistan in the upstream part, while in the lower part we have Kazakhstan, Uzbekistan, and Turkmenistan. As usual, the upstream countries are rich in water, indicated here by the green bars, while the demand indicated by the red bars is much larger in the downstream countries. Obviously, you will find that in many river basins, there is sometimes a dispute about water allocation and water use among the countries. As I said, when we have a short look on Danube and RLC, in the Danube, mainly quality issues are addressed. Until the beginning of the 1990s, water management was based on a bilateral way, so agreements between neighboring countries were made and they met frequently to discuss their water problems. Since the mid of the 1990s, a basin-wide approach has been implemented. In the RLC, we have quantity and quality issues. Until the late 1980s, there was a basin-wide approach. Later on, national perspectives were developed, and Uzbekistan, as a downstream country, is strongly dependent on water use in the upstream countries. Without going into detail, here you have a list what has been achieved in the Danube in the last, let's say, 25, 30 years. I would only like to address here one point, the so-called Convention for Sustainable Use of Water Resources. This convention has been jointly elaborated by the countries, and later on, a River Basin Commission, International Commission for the Protection of the Danube River Basin, has been established in Vienna to execute this convention. And today, we have joint monitoring programs, we have joint surveys with respect to biology, water quality, etc. In the Aral Sea Basin, due to the independence of the Central Asian states, other countries tried to maintain a basis for transboundary water management, and thus it was agreed to establish the Interstate Coordination Water Commission, ICWC, which has been located in Tashkent. And then in 1995, the Nukus Declaration clearly underlined that a collaborative approach is urgent to manage water resources better. Still, national objectives are dominating in the countries. What could be the role of universities? And I've selected here 3 documents where, from the Danube Basin, where experts, scientists from Boku University were involved. One project was at the very beginning of the Danube collaboration, basin-wide collaboration. We did something like a synthesis report about the state with respect to environment and ecology and water use in all the Danube countries. The umbrella organization was here, International Union for Conservation of Nature in Switzerland. And later on, I had been nominated by the office of our Prime Minister as one of the experts, together with people from the World Bank and other experts from the Danube Basin. We developed the first strategic action plan for the whole Danube River Basin, indicating hotspots, etc. And also policies how to improve the situation. Sorry. And next was, jointly with other universities in the basin, under the umbrella of UNESCO IHB, we established a basin-wide water balance at a very detailed level. And this water balance has been finally agreed by all the countries. What did we achieve in the cooperation between Boku University and TMA? Well, one of the first successful steps was to implement a GIS center at TMA University. Then we held, together with experts from Netherlands, Poland, Germany, Austria, several workshops in Uzbekistan. We executed several research programs, and I think very important, it was possible to exchange a lot of students and staff members in both directions. Here you have a list what we have done from starting, let's say, 1998 up to 2022. So I would like to emphasize one project, the rehabilitation of the ecosystem and bioproductivity of the Aral Sea, with the emphasis on the pre-Aralia region. This project has been executed with experts from Siberia, with experts from Tajikistan, from Uzbekistan, and it was under the umbrella of SIG ICWC based in Tashkent. And the final project, which we were working together, addressed climate adaptation and mitigation programs for the Aral Sea Basin. It was a World Bank project. Unfortunately, due to COVID problems, the project had to be stopped last year. The main partners, you know, there was a long list of scientists we met and we collaborated. I only would like to address here a very few of them, like Professor Pulato from TMA, then the late Professor Duchovny, Dr. Sorokin, Tuchin, Dr. Umarov, and Professor Tashmukamedov. Only a few, there are many others, but it's beyond the scope to list them all. We had also several conferences and courses. Some of them were held in Tashkent, Some of them were held in Fergana Valley in Uzbekistan, but also the Austrian embassy, the Uzbekistan embassy in Austria, they organized several events in Vienna and surroundings. They organized in 2007 an international symposium about scenarios for the Aral Sea region, and I had the pleasure to contribute as a member of our university. This is what we have done in the past, what should be done in the future. So learning from other basins where we had been involved, like in the Nile Basin and in the Zambezi Basin, I think a network, a regional network of universities and experts in the region is provides quite a substantial basis for improved collaboration in the field of science, water management, but also environmental protection. And I know there are some networks. I think it would be excellent that the networks would be extended and that jointly research activities could be also executed. For instance, to assist in implementing the Aral Sea vision. This could be done by regional workshops like we did in the Danube Basin or by exchange with other countries. So this was a very, very short summary of what we have done in the last 25 years. And I would like to thank you very much for your attention. Thank you.
Thank you very much for interesting report. The next floor for the report is given to the next keynote speaker on the conference, Mr. Krasnoshekov Ilya Alexandrovich, the head of the representative office of Netafim company for the Central Asia and Caucasus, Uzbekistan. The presentation theme is prospects for the development of cooperation between National Research University Tiami and Netafim. Please.
Добрый день всем. Спасибо, что вы нас пригласили сюда. К сожалению, Илья сегодня не мог приехать. Буду представлять я. Я новый менеджер, который находится в Узбекистане. Меня зовут Амир Узденский. Я приехал с Израиля. Представлю немножко по компании Netafim. И покажу, что мы можем сделать, как мы сделали совместно с профессором языки. Мы тоже сделали все совместно, потому что это компания инновации, компания, которая приехала с Израиля. Секунду, техническая проблема. Но... Сейчас, одну секунду. Мне один момент не повезло на этот момент, потому что передо мной коллега, который разговаривал, он говорил про воду. И мы, как компания Netafim, которая приходит с Израиля, как вы знаете, в Израиле один резервуар воды есть, который очень маленький. И мне кажется, интересно скалибрировать с вашей страной тут и помочь. Мы находимся сейчас, офис у нас находится тут, у нас кадры, которые бегают по региону, 7 человек, которые находятся. У нас тут находится Нурбек, который учился в этом вашем институте, и он помогает нам эту всю ставить нашу инфраструктуру. И это всем нам интересно, потому что это совместная операция. Компания, которая приходит с инновацией. Одну секунду. Да, нам не повезло. Я извиняюсь еще раз. Я расскажу немножко про компанию, пока, если может, можно делать так все. Компания Netafim, главный офис находится сейчас в Израиле. С 1965 года мы производим капельное орошение. У нас на этот момент по всему миру находится 22 завода. Самый ближний завод находится находится в этом регионе, это в Турции на этот момент. У компании Netafim глобально 6 тысяч человек, которые работают, и мы считаемся самой лидирующей компанией в мире по капельному орошению. Самая большая проблема, которая у нас находится сейчас, и компания Netafim старается решить, но это глобально никто из нас это не может решить. Мы стараемся помогать решить эту проблему. В мире очень много воды, но очень мало воды, которая можно использовать для ирригации. Как я вам дам просто маленький пример, который сейчас в стране Израиль, 30% от капельного орошения – это регенерированная вода. Все остальное мы пользуемся опреснированной водой. И может со временем тут придем сюда тоже. Как то, что она сказала, сейчас тут написано 17 заводов, у нас 22 завода, которые со временем наш оборот около $1 billion USA. Мы находимся около 110 стран по миру. Вопрос такой, для чего нам капельное орошение? Это то, что это получается немножко из этого всего. Как я вам сказал, с 1965 года наша компания находится на рынке. В 1965 году был маленький кибуц, это параллельно нам, то, что это называется колхоз, на юге Израиля. Там выдумали, как капельная лента или капельница, которая будет, бежите вперед, да, которая будет просто давать той же самой культуре воду, то, что ей требуется. Любая культура – это живое существо. Это как мы. Когда даешь сильно очень много сразу, она задохнется, ему не будет правильно, ему не будет хорошо. И то же самое потихоньку, потихоньку, потихоньку. Для этого требуется капельное орошение. Мы от этого поняли, что инфраструктура, которую мы будем точно давать ту же самую культуру, это будет легче. Мы работаем в нескольких сферах. Открытый грунт, сады, теплицы, ландшафт, все, что там требуется. То же самое в Узбекистане. Мы делаем несколько проектов. Сейчас мы инфраструктуру, сейчас идем на хлопки, но то же самое мы ведем Косточковая, теплицы, все по этому региону. По Казахстану, Киргизстану, в России, в Беларуси немножко меньше сейчас, но совместно мы работаем на этот момент. Как вы видите сейчас на слайде, это примерно то, что вы можете увидеть, как компания Netafim может делать вам полностью проект. Это имеется в виду, если взять человека, который находится сейчас на поле, ему требуется капельное орошение, ему требуется фильтрат-станция, требуются насосы, оборудование, переработку, и тот же самый человек один, который может это управлять. Любой ресурс, как вы видите, идет на каплю. Вот это, да. Можно? Вот, да, все прекрасно. То, что мои предыдущие коллеги говорили, компания должна быть лидирующей и с инновацией. Сейчас перед вами представлен новый продукт, который уже работает на рынке глобально около 3-4 лет. Это получается Smart Intelligence. Это который контролер получает всю информацию с поля или с открытого грунта, или то, что вам требуется, и имплементирует. Он может открывать клапана, которые находятся на поле, и он все это по радиосистеме. И та же самая фирма, которая сидит сейчас в офисе в Ташкенте, а у нее фирма, которая находится сейчас в Фергане, и он может это все увидеть, как он управляет и как это все работает. И со временем эта система будет давать имплементацию и инновации, какое можно адаптировать со временем. Все любые компании, которые мы совместно работаем, тут должны быть инновации. Next step. Можно следующий. Что такое капельное орошение? Как я вам уже сказал, это получается немножко у нас совместилось это. Капельное орошение, то, что я вам сказал, подается вода и дает до того же самого растения по капле, по чуть-чуть, то, что требуется. Что мы до этого достигаем? Уменьшаем количество воды, которое требуется во всем мире глобально. Требуется уменьшать этого ресурса. И то же самое у вас тут нет, у нас уменьшается со временем. Даем точное количество удобрения, которое требуется, и уменьшаем давление, которое это давление, это энергия. Энергия – это ваши деньги. Дайте еще раз. Вот. Как я вам говорил, мы компания с Израиля. Это посол, если вы видите на нижней фотке, третья с правой стороны, вместе с Нурбеком и с нашей командой, с Ильей, и с Нурбеком, который тут сидит и тоже в зале, мы, вот еще лучше видно, совместно с профессором, и он очень любил инновации. Он совместно с этим институтом, мы сделали проекты, которые дают следующий шаг вперед. Он был этим заинтересован. У меня не было такого времени познакомиться с ним, но это, что от вас у всех увидел, это было очень важно. Человек, который смотрит вперед. И как видите, тут у нас совместные с ним проекты сделались, мы совместно с институтом. Вот Черчик мы сделали совместный проект, который может показывать студентам 3 демонстратических поля, которые показывают несколько технологий, которые показывают технологии и с капельным орошением, спринклерами и без ничего. И там студенты могут почувствовать, попробовать, или это интересно, это нет. Это как выглядит там. Видите, ирригационная комната, резервуар, поле, всякое, только миниатюрное. Да, это тут у вас находится совместно с профессором. Еще немножко датчиков. Я понимаю, уже все очень сильно, все информации уже устали. Я не буду вам дальше говорить это все. Но как компания Netafim, у меня большое еще решение. Мы находимся тут. Мы совместно с этим институтом будем сейчас ставить ирригационную комнату, показать студентам, что можно сделать с инновационной компанией. Это датчики пацометры, влажность, которая находится в почве, и всякие такие вещи. Большое спасибо.
Большое, уважаемый Илья Александрович, за интересный доклад. The next for the report is given to the next keynote speaker of the conference, Liu PhD, professor of Xinjiang Institute of Ecology and Geography, Chinese Academy of Sciences, China. The presentation theme is the influence of groundwater in Oral Sea Delta to ecosystem and agriculture. Please.
Okay, thank you, sir. And can you see my screen?
Okay.
Good afternoon, distinguished experts and colleagues. My name is Liu. I'm a hydrologist from the Xinjiang Institute of Ecology and Geography, the Chinese Academy of Science. I would like to present some research results which we worked together with our Uzbekistan colleagues, Dr. Shamshod and Professor Alishir from the Hydromelioration Department. I also would like to express our appreciation to the collaboration of the Ministry of Higher Education and the Ministry of Water Resources. So this title of my presentation is the special and temporary variation characters of the groundwater in the South IRC area and the climate change scenario. This presentation will follow as 4 parts. The first part is the background. As all we know from the 1960s till now, the river of Amadaya River flow to the LC reduced sharply. The area of the South LC declined as such as 80%, and the volume decreased by 90%. So the salinity of this water body increased like 20 times, especially after 2000. The stream flow disconnected with the LC from time to time. And if we see the reason, probably the low efficient irrigation or the water management method has the significant influence to the flow to the LC. So only the white year the flow to the stream flow can reach the Monac town where the shell line used to be. And the exposed lake bed caused frequent salty dust storm, which further lead to the agriculture and also the ecological disaster in this region. Without this stream flow, the groundwater flux becomes essential, very important to recharge the South LC. On the other hand, the groundwater is the critical component of the water circulation in this region, supporting the ecological and also provide the available water resources for the agriculture and domestic use. Therefore, the climate change and human activities have a very important influence to the groundwater variation. The raising of the groundwater level in this irrigation area has increased the groundwater flux to the LC, but where at the same time it caused also the risk of the salinity. So there are three scientific questions that would be like to answer before any efficient management schemes. The first one would like to be what's the characters of the groundwater variation. The second one would be what's the influence of the climate change and human activities to the water balance. The last one would be what's the suitable groundwater level for the management of agriculture and also ecology. So the next part is our research contents. In the research contents, we split it into three parts. The first part is to carry out the study on the quantitative detection and attribution of the groundwater level variation in this Amadaya River basin. And we use the statistical method to analyze the trend, the mutation, and the period of this groundwater flux. And also, we study the correlation between the groundwater level with the climate factors and also human factors. And the second part, we would like to understand how the groundwater varying. We use the model flow groundwater model to simulate the groundwater flux from the irrigation zone to the dry lake bed. Also, the internally you will flow to the LC, and then we will see how the IPCC scenarios to project the future possibilities. In the end, we come up with the ecological water level theory to figure out what's the suitable groundwater level in this irrigation zone by considering the influence of the capacity in this farmland. And in the left side, we could see the groundwater level is relatively stable with the increasing trend, where in the no irrigation zone, it shows the declined trend. In the irrigation area, the groundwater level has a strong relationship with the irrigation water, NDVI, also the upstream flow of the Amadaya River. The groundwater level of Monac joined to the South LC is highly correlated with the water level of the South LC. And the three climate scenario in the future, like SSP 126, SSP 245, and so on, and the precipitation, evapotranspiration, and the surface runoff in this South RC region was considered, which shows an increasing trend, and the evapotranspiration, also the surface runoff will increase slightly from the December to March in the future. And in the historical simulation of the model flow, the flux of groundwater into the LC exceeds the runoff of the supply from the Amdaya River in most year. And in the climate change scenario, the consumption of the evapotranspiration in the future is so great, it's more than the recharge of the groundwater and precipitation. And by our calculation, in the future, when the South LC becomes stable, it will continue to shrink until water balance. The surface of this LC, South LC, will keep around 4,000 kilometers square. Since we already know the situation become continuously worse, we would like to control the groundwater in an optimized way. If the groundwater is too low, the plants will be jeopardized and cannot extract the groundwater efficiently. If the ground level is too high, the salinity will cut. And therefore, by considering the calibratory capacity, we will set up the upper limit 1.78 meter and the low limit like 2.78 meter. By this kind of criteria, only 56% of the year and 54% of the total area, the irrigation zone cannot meet with the right groundwater levels. And if we use this criteria to control the groundwater level, we have to drain like 62% of groundwater in the summer season, and supply like 100 million cubic meter fresh water to recharge the shallow aquifer. And this kind of arrangement surely have the benefit after this kind of optimization. 88% of the year and 87% of the total area can meet with the suitable groundwater level. So there are some conclusions for our study. And the first one, the groundwater level in the irrigation area around the South LC shows a continual increasing trend. And the future scenarios, the South LC will keep shrinking to around 4,000 kilometers square. And the ecological water level of the nucleus irrigation area is should be set up to 1.7 meter to 2.7 meter. And also for this region, the groundwater zoning regulation and the dripping irrigation can efficiently manage the issue of the LC disaster. And also, we would like to propose a solution. Like, for instance, we would like to introduce the dripping irrigation technology and the drainage channel method, and also the surface water and groundwater combination irrigation method. And here is some collaboration results. In 2021, with the support of our colleagues, we carry out the dripping irrigation technique demonstration work in the Kashkadaria state. On September 27th last year, we honored to invite the expert of the Ministry of Water Resources, TIME, and also our the expert from the Institute of Water Problem, and also the expert from the Institute of Genetica, and some local expert to our coating field and to measure the coating yield. And finally, the yield is quite good, and it reached to 6 tons per hectare. And it can be seen that our dripping irrigation technique is quite good and work very well in this region. And for this year, we continuously work with the localization of this technology. And here is some result. And to review the collaboration with our two universities. In the past 4 years, we analyzed the course of and the distribution of this ecological disaster and the form of the spatial distribution of plant, how to restore the ecological system, and also propose water, social, economical, and ecological collaborative plan, and also demonstrate water-saving irrigation technology. Therefore, sincerely wish our collaboration between our institute and TIAME to go to well in the future. Okay, thank you very much.
Thank you very much, dear professor, for a very interesting and informative report. Уважаемые коллеги, уважаемые участники конференции, сейчас объявляется перерыв на 30 минут для кофе-брейка. Пожалуйста. У нас рабочая конференция продолжится в 4:00. А? 20 минут? На 20 минут тогда. Кофе-брейк, да.
По короткой дороге пройдем, чтобы времени. Может быть,
Что?
Bir, ikki, uch, to'rt, besh, 711, 712, 713, 714, 715, 716, 717, 718, 719, 720, 721. Bir, ikki, uch, to'rt, besh, olti, yetti. Bir, ikki, uch, to'rt, besh, 7. Bir, ikki, uch, to'rt, besh, 6.
Zoomchilar da yo'q.
Mana? Başına olarak. Servis. Şimdi krişke. Yaşı.
They can. Not for, yeah, okay. I think mine is 11 or 12. There will be more. Altogether, there are 8.
Так, уважаемые участники, продолжаем нашу сессию. The next call for the report is given to the next keynote speaker of the conference, Kozlov Dmitry Vячеславович, Professor, Doctor of Technical Sciences, Moscow State University of Civil Engineering, National Research University, Russian Federation. The presentation theme is Scientific and Technical Support of Engineering Survey, Design and Construction of Hydraulic Structures.
Спасибо. Уважаемые коллеги, еще раз всем добрый день. Спасибо. Я хотел бы сделать небольшое все-таки сообщение об одном интересном проекте, который реализуется на кафедре уже несколько лет. Это научно-техническое сопровождение реальных проектов гидротехнических сооружений, которые проектируются, строятся на постсоветском пространстве. Вообще научно-техническое сопровождение – это не некоторое новшество, а это в некотором смысле продолжение нашего инновационного проектирования, строительства и эксплуатации гидротехнических объектов, потому что понимать мы его должны не как авторский надзор, не как процедуру экспертизы, а это именно сопровождение современными методами проектирования, современными методами анализа, мониторинга тех проектов, которые реализуются в нашей профессиональной области. Основные этапы научно-технического сопровождения соответствуют основным этапам жизненного цикла наших сооружений. Это этап изыскания, проектирования, строительства и эксплуатации. И реализуется эта работа в соответствии с действующей в Российской Федерации нормативной базой, техническими регламентами, сводами правил и региональными нормативными и отраслевыми документами. Примеры тех объектов, которые прошли научно-техническое сопровождение на кафедре гидравлики и гидротехнического строительства в последние годы. Это достаточно интересные, серьезные и многоплановые объекты нашей экономики. Ну, начну, наверное, с интереснейшего объекта. Это база плавучего энергоблока в городе Певек в Чукотском автономном округе. Именно на этом объекте было выполнено специалистами нашей кафедры научно-техническое сопровождение проектирования гидротехнических сооружений плавучей атомной теплоэлектростанции. Ну и второй такой же чисто гидроэнергетический объект – это Гацатлинская ГЭС. В рамках проекта научно-технического сопровождения проводилась оценка и анализ проектных решений, которые направлены были на локализацию и ликвидацию причин повышенной обходной фильтрации. Сегодня на кафедре идут несколько проектов научно-технического сопровождения. Один из них, правда, закончился вот буквально весной этого года. Это экспертиза результатов строительно-технического исследования аварий, которые произошли на Белопорожской гидроэлектростанции на реке Кемь в Карелии. А второй интересный объект, который идет сейчас, это проектно-изыскательские работы по реконструкции судоходных шлюзов Городецкого гидроузла на реке Волга. Объект с серьезной историей, связанной со строительством каскада Волжского гидроузла. Я думаю, что для вас не секрет, эти объекты были построены еще в советское время, и один из них, Чебоксарский гидроузел, до настоящего времени эксплуатирующийся с 70-х годов, до настоящего времени еще не введен в проектную эксплуатацию по причине достижения проектных отметок НТУ, но создавший определенные проблемы ниже Нижегородского гидроузла, то есть как раз от Городецкого шлюзового комплекса и вниз по Волге до Нижнего Новгорода с пониженными судоходными глубинами, а следовательно с недостаточной пропускной способностью судов в период навигации. Сегодня этот объект поставлен на реконструкцию, и вот специалисты нашей кафедры получили проект по научно-техническому сопровождению этих работ. Еще один интересный объект, его нельзя назвать объектом, потому что объектом служат почти 3 сотни гидротехнических сооружений, небольших гидроузлов, водоподпорных, в том числе в черте Москвы и в первую очередь в черте так называемой Новой Москвы. Это наш Новомосковский Троицкий административный округ. В рамках этой работы были выполнены решения по эксплуатации гидротехнических сооружений и обеспечению безопасности. Ну и самое главное, завершающим итогом этой многолетней работы, она выполнялась на протяжении последних 3,5 лет, был проект региональной программы обеспечения безопасности гидротехнических сооружений, который расположен на территории города Москвы. Было обследовано 250 ГТС, составлено преддекларационных актов около 200, проведены обследования инженерных сооружений на водных объектах. Причем интересы этих сооружений исторически совпадают с 500-летним этапом развития гидротехники на территории Москвы. Вот здесь справа, я прошу прощения, справа фотография показана. Это часть конструктивных элементов так называемой Борисовской плотины, построенный первый вариант, который лежит внутри, в теле современной плотины, еще во времена Бориса Годунова в районе Царицы. Есть у нас два проекта научно-технического сопровождения объектов на территории Узбекистана. Сложные объекты с непростой гидротехнической судьбой. Естественно, это Сардобинское водохранилище, плотина. После 1 мая 2020 года она стала одним из объектов наших интересов, более судьбы. Мы участвовали вначале в аналитике причин этой аварии. Сейчас нас привлекли к проекту научно-технического сопровождения. Я, не вдаваясь в анализ технических решений и будущего этого объекта, скажу только одну фразу. Жить, строить, эксплуатировать, проектировать и совершать в том числе действия по научно-техническому сопровождению нужно честно. Тогда каждый из нас сможет сказать, что все, что ты смог сделать, ты сделал достойно, ты сделал правильно, и ты гарантируешь, что решения, принятые при создании этого объекта, не принесут рисков потери человеческих жизней, нефункционирования гидротехнического объекта или сооружения, ну и в целом спокойствия в окружающей среде. И вот здесь следует отметить, что, конечно, само водохранилище, сама плотина скорее, да, Сардобинская дамба, она требует к себе повышенного внимания не только со стороны гидротехников, именно проектировщиков, а в большей степени строителей и эксплуатационщиков. Это нужно понимать, и в том числе на этапе реконструкции этого сооружения после известной аварии. Ну, а Пскемский гидроузел – интереснейший объект, который сейчас реализуется. Мы также участвуем в научно-техническом сопровождении этого гидроузла. И здесь, я думаю, я надеюсь, по крайней мере, проблем в меньшей степени будет касаться проектирования, в меньшей степени будет касаться вопроса проектирования. Что элементы работ, которые были реализованы в рамках этих проектов, вот здесь просто в качестве примера предоставлены согласованные материалы. Это сравнительный анализ исходных данных, который был получен после аварии на Сардобе. Они легли в основу нашего заключения. Это, естественно, как элемент расчетного обоснования составления геотехнической модели дамбы и выполнения расчетов по ее устойчивости, работы конструкции и прогнозу поведения ее при различных режимах работы Сардобинского водохранилища, скорости опорожнения, наполнения емкости. Здесь представлены сценарные расчеты для оценки обеспечения устойчивости дамбы уже при сейсмическом воздействии, результаты фильтрационных расчетов, которые положены в основу тех заключений, которые мы делаем в рамках этих проектов. Что я хотел бы отметить по обеспечению всех этих работ? Научно-техническое сопровождение – это сопровождение с использованием современных инструментов расчета, анализа, мониторинга и даже в некотором смысле обобщения анализа. Поэтому мы стараемся к этой работе привлекать не только педагогических и научных работников кафедры, это, естественно, научные работники наших лабораторий, которые оснащены современной лабораторной базой и позволяют решать различные задачи, в первую очередь, если это касается объектов в Узбекистане, то это, конечно, нацгеотехника. Это аспиранты, это даже магистры, и вот здесь я в качестве примера привел реальную выпускную работу, которая защитилась магистром в этом году, и связана она с научно-техническим сопровождением проекта реконструкции углического гидроузла на реке Волге. Магистр Щербина Полина не только выполнила весь комплекс поставленных задач в рамках этой работы, она в течение 2,5 лет работала на этом объекте и стала участником той реальной работы по реконструкции гидроузла. И, соответственно, в нашей части научно-технического сопровождения это, естественно, ей помогло не только совершенствоваться профессионально, но еще и решить задачи, стоящие перед ней, как перед магистром нашей кафедры и перед сотрудником этой гидроэлектростанции. Сегодня комплекс работ по научно-техническому сопровождению в нашем Московском государственном строительном университете реализуется в рамках нескольких областей. Это в первую очередь инженерные изыскания с разработкой рекомендаций, техническим заданием с оценкой анализов материалов инженерных изысканий, оценкой биологических рисков, выполнением научно-исследовательских работ для проектирования, в том числе фундаментов и так далее. Это область проектирования с составлением независимых расчетных моделей и с использованием альтернативных сертифицированных программных средств. Это крайне важно для того, чтобы, с одной стороны, сделать более современными решения, реализуемые в проекте, а с другой стороны, оптимизировать эти решения с использованием альтернативных программных продуктов. Это, естественно, определение правильности расчетных моделей, обоснованности принятых решений по ним. Выполняется выборочная проверка этих проектных решений с расчетом наиболее ответственных конструктивных элементов или сооружений, если мы говорим о составе гидроузла. В рамках научно-технического сопровождения выполняются и достаточно редкие работы. В частности, это уточнение аэродинамических коэффициентов на основании модельных испытаний в аэродинамической трубе. Это нам позволяет сделать наша специализированная лаборатория в НИУ МГСУ, если такие задачи стоят. Это, естественно, геотехнический прогноз влияния строительства на окружающую среду, геологическую среду, экологическую обстановку. Для этого мы с интересом и с пониманием приглашаем наших коллег-специалистов с кафедры изысканий и из геотехники. В следующей области, непосредственно в строительстве, научно-техническое сопровождение проектов осуществляется через систему мониторинга. И вот здесь я как раз привел примеры тех работ, которые выполнялись на углическом гидроузле с участием наших студентов. Именно эти работы позволили выполнить разработку рекомендаций и корректировку проектных решений по реконструкции гидроузла, составить перечень работ, оборудования и работ для того, чтобы реализовать эту систему мониторинга, провести контрольные испытания, контрольные обследования. В частности, здесь вот показано поведение бетонных сооружений углической ГЭС на этапе восстановления, которые необходимо осуществить в рамках предполагаемых работ. Сами участники этих проектов, в первую очередь, конечно, это студенты и аспиранты, участвуют в инструментальном и визуальном обследовании объектов, предоставляют эту информацию для последующего анализа и формулирования рекомендаций. Ну и значимость вообще всего научно-технического сопровождения современных проектов подтверждается интересом государства к этим работам. Весною 2022 года на сайте Национального объединения изыскателей и проектировщиков нашей страны. Для профессионального обсуждения был вывешен проект свода правил научно-техническое сопровождение инженерных изысканий и проектирования, основные положения, который включает перечень основных положений, устанавливает цели и задачи, требования к организациям, которые осуществляют это сопровождение, общие требования по составу и содержанию этих работ, организация этих работ, по составу и содержанию отчетной документации. То есть мы понимаем, что эти работы становятся некоторым обязательным этапом при проектировании, строительстве и эксплуатации объектов, особенно относящихся к категории, к высокой категории. Ну, а в заключение несколько выводов. Наверное, самое главное последнее, что в современной строительной практике научно-техническое сопровождение должно обеспечить эволюционный рост в области проектирования и строительства гидротехнических сооружений, ускорить процессы внедрения новых строительных материалов, конструкций, новейших техник и технологий в гидротехническое строительство. И именно в этом смысле мы и понимаем содержание своих работ, никаким образом чтобы они не противоречили авторскому надзору, работе по вхождению в экспертизу, непосредственно проектированию, а позволяли лишь интенсифицировать, оптимизировать путь проектирования, используя современные техники и технологии. Спасибо.
Спасибо большое, уважаемый Дмитрий Вячеславович, за интересный, содержательный доклад. Нам было очень интересно послушать вас. The next floor for the report is given to the next keynote speaker of the conference, Gisela Tomich, Associate Professor, Vilnius University, Lithuania. The presentation theme is assessment of impact of irrigation network on groundwater, example of the Karasu River. Are you with us? Online. Formula? Unfortunately, she's absent, so the next floor for the report is given to the next keynote speaker of the conference, Bobmurat Ahmedov, Professor, Institute of Fundamental and Applied Research under TMA, National Research Institute, Doctor of Physics and Mathematical Sciences. Okay. Okay. Okay, it is great pleasure to be here and to make talk from the name of the Institute of Fundamental and Applied Research, which was established on the initiative of Uktam Pardavich. So I'm mainly working on the fundamental part. So I would like to speak about stars and universe. Okay, make the next. Okay. Okay, good.
Okay. There is a big difference between natural science and astronomy. For example, any natural science is justified by experiment. But if you go to the astronomy, in astronomy, the experiment is made by the nature. So something happens in the far astronomical objects and we need to observe them. But we can observe them through electromagnetic radiation, but electromagnetic radiation is captured or scattered by the atmosphere. So if for the life, water is very important, but for astronomers, the water precipitation is enemy. So from this point of view, Uzbekistan has very good astroclimate because in our area, weather is dry. So if you go to the Majdanak region, at the mountain area, we have the best astro point for astronomical observations. But if you look to the whole electromagnetic spectrum, the information which is coming from the far distance from the objects, it will be blocked by atmosphere. So atmosphere will not transparent and only in some visible light observation can be observed. Otherwise, some in radio diapasons. So from this point of view, we can't observe the astronomical objects sitting on the Earth. So what we need to do? So go to the next slide. So I would say the following. So the most important event for the mankind happened in 1957. In 1957, for the first time, the mankind was able to escape the gravitational field of the Earth and go to the cosmic space. And now what happened? So we have the whole amount of the astronomical telescopes, cosmic telescopes, which are outside of our atmosphere, and they provide us very important information about astronomical objects. And what happened as a result of these observations? So now we have revolutionary discoveries. For example, if we go to the composition of the universe, 96% of the universe was absolutely unknown for us. So it is dark matter and dark energy, and only 4% of the matter of the universe is baryonic matter, which we see as stars and black holes and everything which we can see. It contains only 4%. You can look to the pie. Here you can see that we don't know what is the 96% of the universe. And here you can see image of the different, it is King's again. It is the most interesting Hubble telescope. And the next one is the Spitzer telescope. Now what is important? So we can observe through X-ray very highly energetic processes in the universe. Okay. If we look to the history of the cosmology, we had 3 revolutions. First revolution was made by Claudius Ptolemy. He said that at the center of our universe is the Earth. And in 16th century, Nikolai Copernicus said, no, in the center of our universe is the sun. So, but now in the 20th century, we came to the Big Bang cosmology. So Edwin Hubble was able to show that Big Bang happened 14 billion years ago and our universe is expanding, but now we know that it is expanding with acceleration. Okay, next one, next. So now what we know from the universe, so universe contains 100 billion galaxies, and each galaxy contains 200 billion stars. So it is full of stars, which we can, so the number of stars is infinite. So a huge number of the stars, which we can observe, and this universe is becoming bigger and bigger. The next one. And for the distances which we observe, for example, in the solar system, we have the astronomical unit. It is the distance between Sun and Earth, it is the light, the distance which will be made by light in 8 minutes, but it is not enough for the universe. In order to study in the galactic scale, we go to the light years. So it is the distance which will be made by the light in 1 year, but even 1 year is not enough. So the nearest star from us is at the distance 4 light years. So in order to have an idea, I would say that the moon from the Earth at the distance 1 second. Okay, so you can imagine how far the stars in our galaxy. So the next one, Kingston. So if you go to our solar system, we have 8 planets, and they have some structures. These planets are moving with respect to the sun, according to the Kepler law, and we have the structure of the solar system. So if we then we said that what sun is doing. So if all planets are moving with respect to the sun, but sun is making revolution with respect to the center of our galaxy. So there is Sagittarius A star, and our at the distance 28,000 light years, and in 230 million years, our sun makes 1 galactic year. So with respect to the beginning, it made maybe 20 revolutions. So from the galactic year, our sun is, from one point of view, it is 4 billion years old, but from the galactic year, it is only 20 or 22 years old. Okay, so this is the question. So now we may ask the question, if there are so many stars in our galaxy, are there planets around them? And the answer is yes. So there was Kepler mission, which was looking for the planets in the solar system. And now, for example, a few months ago, it was announced by NASA, there are 5,000 exoplanets which were observed around stars in our surroundings. So we have huge number of the stars. So it seems the planetary system is very common for the around stars. So, and the number of them depends, of course, from their size. You can show the next slide. So you see that the number of bigger planets is bigger because it's easier to observe them. It is not due to the reason that the number of the giant planets is bigger, but it is due to the easy observation. And now we may ask the question, are there habitable? Is there life at the planets? And the question could be answered yes. So if we can look from the astronomical point of view, is there enough heat which is coming to the planet? And there are many, here you can see the number of the planets which are located at the habitable zone. So we believe that there is the life in the planets, and what is very important, that the most close of them, it is around Proxima Centauri b, it is only 4 light years from the Earth. So it is very close from astronomical point of view. Okay, now you can go. So we may ask what our galaxy do. So then when we look to our galaxy, it appears our galaxy in the local group, and these galaxies are making clusters. So they're moving with respect to each other, and they have some structure. So if you look to the next slide, so we have planets orbiting sun, and then we have sun orbiting the Milky Way galaxy, center of the galaxy. It makes local growth, and then it makes supercluster. So some clusters and the distribution of the matter. You may show the next slide. So the distribution of the matter looks like filaments. So there are very void places, and there are some places where you can see the distribution, big distribution of the matter. So it may be shown by the simulations. Also, you can go to 36. Okay. Here you can see our local system is very small. So usually galaxies are in the node, but here you can see that in the node there are not many of them. And it is the question. Now we can ask other question. So what's second topic? What about the evolution of the stars? So the stars also evolve with the time. So they appear and live and then collapse. So they die, I would say. So then in order to find them, we look to the blue stars, which are younger, and depending on the mass, we will have different scenarios. So for example, light stars will end with the white dwarf, more heavy stars will make neutron stars, and more heavy stars will make black holes, and so on. And most interesting about from this object, because I say for astronomy, for example, for irrigation, the most important is water, yes? But for astronomer, is the most important is the mass. So depending on the mass, we have different objects. So for the massive stars, we have at the final stage, we will have black hole, and then you will ask, what is a black hole? So black hole is a very mathematical object. So from this point of view, we say black hole does not have hair. There is no hair theorem. So for example, when I go to the Indian embassy, they ask, there is question, how you look? I write bold. But this bold does not work for black hole, because when you look to my boldness, I have some hair. As soon as I have hair, it has chemical content, it has length, it has size, and many, many other things. From this point of view, black hole is very simple. It has, for example, if it is non-rotating star, it has single parameter, total mass of the black hole. That is all. And then it is very simple, but surrounding this black hole, I can make some hypothetical sphere, and then I will tell it, call it as event horizon. So what is interesting with the event horizon? So why I see these keys? Because photons come here, reflected, and come to my eyes, and then I can recognize. My computer says that it is key, which is made from the metal or something. It is shining, but here, from the black hole, from the event horizon, even photon can't escape. So then you would ask me the question, even if photon can't escape this object, why do I interested on it? Why it is interesting for me? But here, the interesting part of this is connected with the following condition, because in our galaxy, majority stars are in binary systems. So they are not single as our sun. So if it is in binary system, they can start to eat surrounding star, and the next one, it is called low mass X-ray binaries, and matter which will fall down to the black hole will make very high speed, ultra-relativistic speed, and radiate X-ray radiation. So then I may observe X-ray radiation and start. Okay, so I'm told that time is enough. I will continue next time. Okay, thank you very much.
Thank you very much, the professor, for interesting report. The next floor for the report is given to the next keynote speaker of the conference, Professor Yaroslav Rybak, Wrocław University of Science and Technology, Poland. The presentation theme is dynamic monitoring, vibration mitigation techniques, and calibration of geotechnical technologies. Sorry. So, are you ready?
Yes, I'm ready. Can you hear me?
Yeah.
Great. So I will start my presentation. Just because of the time limit, I had to shorten a little bit the title and shorten a little bit the content. But firstly, I would like to greet everybody. I'm really happy to be back in Tashkent, this time in an online mode, but I hope that one day we'll meet again. Okay, so dynamic monitoring and calibration of geotechnical technologies. Professor Akhmedov took us to the outer space, to the stars, and I'm going back to the Earth, to the very simple works which have some educational and scientific value. I know that this conference is somehow related to the memory of your former rector, Professor Umurzakov. So I would like to point very much this aspect of this cooperation. That's why I gave me and my friends as the authors of this presentation, because it's a group work, let's say. The first part is about some numerical modeling of the dynamic impact of geotechnical works. The whole team consisted of my colleague Aneta Herbut, professor from my university, me, and colleagues from the National University of Science and Technology in Moscow, Mrs. The main ideas of this part is some kind of introduction, codes and regulations concerning the dynamic impact of vibrations, some site measurements, and what is the most important, some attempts to make the finite element model. And of course, I will end up with results and discussion. In general, sources of the ground vibrations, where how they appear, where does it come from? So we have natural phenomena, of course, mainly earthquakes. That impact is very, very strong, and truly said, we cannot control it. It means we can mitigate the bad consequences, but we cannot prevent, you know, earthquakes. Then we have some human activities related to so-called paraseismic influence of mining works. In that case, it's also difficult to be controlled, but I know that the mining industry does everything to, let's say, reduce the harmful impact of the works on the surface. But in that case, the range of the dynamic impact is also quite huge and appear randomly, meaning that it's hard to be prepared for every impact. Then we come to activities of rather lower intensity. It's a kind of machine work, operation of machines. Then we come to the roads, railway traffic. And this part, which is the most interesting for me, is construction activities related to the civil engineering sector, some geotechnical works, let's say. And then we do a lot of such control procedures as the university, and we are trying to involve our students, our trainees from the Erasmus program, also our trainees from the countries which are not within Erasmus program. They can come, they can make some measurements on site with us to participate also in the evaluation of the results. We have some articles together, and I think this cooperation is very fruitful. But coming back to the meritum of this presentation. So we have geotechnical works. As you can see, there's always a source of vibrations. It's usually a piling rig. Then we have the seismic waves, coming from the building site towards the neighboring structures. Then we have people inside the buildings. They can be angry. This adjacent building can be shaken by the dynamic impact, and that causes sometimes some serious quarrels, some claims, and well, in very rare events, sometimes even some kind of fights when this impact is too big. To avoid the claims, to avoid the problems with the neighbors, there are some criteria established in codes and standards. Yeah, we have criteria for the whole structures, meaning the overstressing of the structural members. We have some criteria for humans, yeah, for people inside, and also for the equipment inside the buildings. This is extremely important in the case of some industrial facilities or hospitals where with the operating rooms, with surgeries, then the well, vibrations are certainly not allowed. Then speaking about the codes, we have different codes from different countries. I believe that also Uzbekistan offers some kind of regulations, some limits for the allowable vibrations. I know the same. Well, not the same, but just the same kind of documents exist. Well, in Russia, this one is from Germany. This is from the Great Britain, British standard. This is, I think, from Sweden. Yeah. What is important? We live in a global world right now, so we need to understand that most of these regulations are well, not the same concerning the numbers, but they provide briefly the same kind of limits. If you look at the European codes and the American recommendations concerning various kind of buildings in the vicinity of geotechnical works, we have pretty similar values, as you can see here. For light commercial buildings, it's something between 10 and 12, and in Eurocode 3 you have just 10, so it's the same range for the structural criteria. And coming back to the Meritum, we have the possibility to use various sensors. In my university, we have, I think, three different sets, three different machines, let's say, which gave us a possibility to register the vibration velocities in 3D, or also the accelerations. This one was produced in Canada. We have another one which is Polish production, and another one which is made in the Netherlands, I guess, Vibra. So the equipment is pretty much available, and it's not a big cost, let's say. It's well, it is more expensive than a standard laptop, let's say, or a personal computer, but this is not a very sophisticated equipment. And why I gave this introduction, it's just because we know that the vibrations are attenuated with the distance from the source. Very close to the machine, like in here, this is the distance from the piling rig, like 0 meters, it's very close. Yeah? We have a very high particle velocity. This is kind of this is equivalent to the paraseismic excitation, or even the seismic excitation. And but when we go well, to the distance of 20 meters, it is very much decreased, 8 times less. And when we are in the distance of 50 meters, well, in this particular case of this machine and this ground, we reach the values which are still allowable concerning the codes that I showed before. So if we make experiments concerning various machines and various ground conditions on site, then we can find similar graphs, and we can provide some recommendations. How close can you come with your geotechnical technology to the building that we want to protect from harmful shocks and vibrations? as you can see here, these results are very similar, but they are not taken from the building site, but they are taken just from numerical modeling. Concerning the energy of the impact and concerning the properties of the ground, we can develop, I will come back for a moment, we can develop a similar graph in the, let's say, office, in the camera conditions, yeah? And as you can see here, the ranges of the vertical peak particle velocities achieved are somehow similar to the ones achieved on site. The same with the horizontal vibrations, which are a bit smaller. And what is important in here? I will just go to the next slide. We managed to test and compare, let's say, some ground conditions in granular soils. You see here compacted fields made of kind of sand with some gravelly parts as well. We have here a huge earthworks related to the earth dam, so it's flat protection not far from my city, from Wrocław. And this dam was constructed of cohesive soil. And here we have also the big earthworks involving the crushed concrete. So it's a kind of, sustainable building. We reuse the spoiled material and so on. And in the last example, we had a field with a rather soft clay, not very good one, but stabilized with lime. So the lime reduced a little bit the humidity and the moisture content, and also worked a little bit like a binder to achieve a hard soil. So having this tests from the site, we could try to build the numerical model. Actually, this one was made by my co-author, Aneta Herbut. She's quite a good mathematician. And this numerical model gave us a possibility to measure, to evaluate, let's say, the vibrations appearing on the ground level, being the result of a Rayleigh wave, a surface wave. Yeah, this is exaggerated drawing. Of course, it doesn't look like that. You see here on the horizontal axis in meters, and this one is in also in meters, but it's the range is much smaller. But I just wanted to show you the shape of this wave. And we can get these CAT sections. And what was the result? Because I just told you that, yeah, well, we did something. Yeah, we measured something on site when we modeled, but we do science just to achieve some surprising results, or results that make us think about, well, the purposes, or maybe we are wrong. Our hypothesis should be tested again. This is quite surprising to me personally, because it seems like the vibrations before compaction, when the ground was softer, let's say, the vibrations transmitted to a longer distances were still bigger than after compaction. This is, well, I always thought that when we change the density, when we densify the ground body, then the vibrations will be transmitted easier. But it seems like it's not necessarily the true. And that made us think that maybe we should go again to the building site and try to make the real on-site measurements to check if it's true or not. So as you can see here, the cycles of dynamic roller, approaching and going far, approaching, going far, and so on, in coming close and far, close and far. And you see that to a certain moment, the vibrations increase, but then they decrease. And well, we didn't have a lot of time to spend on there, but this decreasing trend was visible. So some conclusions: presented results can be helpful for planning of geotechnical works. In the results of similar investigations with dynamic impulse compaction were recently presented. Well, will be presented soon in a moment by me. And the results are highly dependent on ground conditions, which is obvious. Yeah, and yeah. And so I will just skip the conclusion, and I will go to the second part, which is also a group work. A guy from the construction company, Przemek Dobrzycki, my colleague from the building side, and me, and colleagues from also National University of Science and Technology, Mrs. in Moscow. Actually, the last girl is also from Moscow, but at the moment she studied in USA, so she had American affiliation. Yeah. So very briefly, I will introduce the rapid impulse compaction. I will show the intensity of vibration, some site measurements, and some primary conclusions. So rapid impulse compaction is like the foot of the elephant leg, like bang, bang, bang, bang. We have a slab here of a diameter of approximately 1 meter, and then we have the hammer which is smashing the slab, and then the ground is compacted below. The compaction works are usually situated in a grid. What you can see here, the circles are just places of the compaction. They always are arranged in a grid. It can be rectangular, it can be triangular. There are various philosophies how to arrange it, but as far as I know, but this triangular is really good. So we have buildings, we have the building side nearby, we have dynamic roller again, and we have machines providing the impulse compaction. The results of velocity, peak particle velocity measurements are usually presented in a graph in a frequency domain, right? Like we have the frequencies and velocities. Similar graphs appear in most of the European codes. And then you see here our accelerometer, so this instrument, and the recorder that measures the vibrations, and two machines like the vibratory roller and the impulse compactor. The distances that we checked, it was 30 meters for the roller and 60 meters for the impulse compactor. And you see here the measurements that partially confirm what we observed in the numerical modeling. When we are far, we can't see a big difference, yeah, if it is the first stage of compaction or not. In here, we have the increasing vibrations within one set of blows, let's say. But when we come closer and closer, it seems that with every blow, the intensity of vibrations is smaller and smaller. I'm not sure if you can see it here. Oh, sorry. I have to go back because I touched the screen with my pen. Yeah. So in the testing phase, we have the first phase approaching, then we have the second phase when the machine was going far from the place where we had our instrumentation, and you see here the decrease in course of compaction. In here, it's pretty far, it's rather equal, but then we have rather equal, significant decrease. This is a slight increase, equal, equal, equal, equal, equal. So that means that the compaction of the ground may reduce in time the harmful effect of the compaction works. In the case of the vibratory roller, we just observed something which was similar to our previous graphs. Like when the machine was approaching, it was more and more, meaning the peak particle velocity on the ground level. When the roller went away, let's say, these vibrations seriously decreased. And some conclusions. When we are on the building site, sometimes we have more than one source of vibrations, and it's very difficult, of course, to control the impact, which can be multiplied, yeah, by many machines, yeah. But this phenomena of superposition of vibrations can also be used in so-called active technologies to mitigate the vibrations. On the larger scale, it can be observed in the construction of high-rise buildings in seismic areas. I know that colleagues from Japan, they have a great experience, yeah, producing some systems that can pump water to different floors of the building to change the eigenfrequency of the building to avoid the resonance with the seismic waves, which is near to come. And in the case of the civil engineering works, that kind of works are still not, that kind of mitigation technologies are not used because of the cost, of course, yeah. The presented results can be helpful for planning of geotechnical works in the neighborhood of vibration-sensitive buildings. It means that when we gather experiences and when we have some basic knowledge on numerical modeling of these vibration effects, then we can define so-called safety zones, safe zones, like you should not approach closer than 30, 40 meters from this historical monument, for example. You should not approach with your technology. If you change the technology, maybe we give you another limit, maybe you can work closer. These results are highly dependent on ground conditions and vibration energy. This is also related to what I said before, just yes, we can control to some extent the vibration, but if we make some tests before the entire work, yeah, then we can provide some recommendations. And what we like at the university very much is the necessity of further examination. Well, usually as a reviewer in technical papers, I don't like this sentence at the end of every study that anytime the author doesn't know how to respond to the reviewer, he says that, well, this is going to be the subject of our future studies. But in that case, I have to use this sentence myself, just because there's really a need to collect information, collect experiences. And when we have these experiences, then we can be more accurate in our judgment. And thank you very much for your attention and welcome to Wrocław. Just one sentence, because I probably extended a little bit my speech, but I'm very glad with the cooperation with TIAME. I know that in June this year, colleagues from TIAME, I mean Farouk and Farouk Shaziz, the chairman of this session, and my friend Edward Khan, they participated in a conference in in Wrocław in an online mode, like me in Tashkent, but it was very fruitful. I hope for both sides. I know that the organizers of our conference were extremely happy to have people from Uzbekistan in Poland, because they could just provide some, let's say, viewpoint and also some information on the issues which are not well known in Poland, but which are vivid, important for the scientific world. So thank you very much again, and I hope to see you in my city. Thank you.
Okay, thank you very much for nice presentation, for interesting presentation. So we have to be fast. The next floor for the report is given to the next keynote speaker of the conference, Professor Maslov Konstantin, Joint Institute for Nuclear Research, Dubna, Russian Federation.
Okay, good afternoon, everyone, and thanks a lot for giving me the opportunity to present a little talk at this very nice conference, which I enjoy. So today, and special thanks to Professor Rybak for bringing us back to Earth for a couple of moments, and now we are going looking to the sky again, and now discussing neutron stars and how can we use the neutron star data and observations to study questions of nuclear and particle physics. Next slide, please. Можно следующий слайд? So I will start with a little bit of history, or maybe by now folklore of how the neutron stars were first suggested, then found. And actually, this is one of not too many objects which was kind of predicted by theorists first, even before the discovery of neutron in 1932 by Chadwick. There was already not a real clear statement, not a discovery, but anticipation that such kind of objects could be formed in the sky by Lev Landau. As you can see at the right, in the very nice review about history of neutron stars by Yakovlev, Landau was discussing, publishing a paper about such electrically neutral objects made of some very dense matter, maybe resembling one giant nucleus made of neutrons. But neutron was not known before, which is another proof of maybe Landau's genius. Unfortunately, it wasn't published, and in 1933, Bade and Zwicky actually have created the term supernova, which we know now, I think. Everybody heard it at least once, and the neutron star. So given an assumption that a supernova can be a normal star transitioning to a neutron star with an extraordinary release of energy. In the next couple of years, there were, of course, the more theoretical studies of this topic, but the first observational evidence of something resembling a neutron star was made in 1967 by Jocelyn Bell, a graduate student of Anthony Hewish in the United Kingdom, of a very stable source of radio pulses with some rather small period of 1.5 seconds. So what can send us stable pulses from the outer space? Well, first assumption was that these are little green men. So some alien species which are trying to communicate with us by such periodic pulses. But after more sources were found, people decided that probably not all the aliens want to talk with us in the same way. And the only candidate for this was a rapidly rotating compact object, which was called Pulsar. The source was called Pulsar. And 1974, there was a Nobel Prize for this. Unfortunately, just to Hewish and not to his students who actually found it, which is not the brightest year of the Nobel Prize history. Next slide, please. So current knowledge about neutron stars in few words. So in few words, neutron star is a star with the size of a city. So you can see here a picture of a sun, and just imagine that neutron star is what happens if you collapse the sun into the size of Tashkent, as you can see. Yeah, so neutron stars are extremely dense objects. So with mass of 1 to 2 masses of sun and radius around 10 kilometers. So it has extreme density, extreme mass per cubic centimeter. And actually, this density is more than density inside a nucleus, a tiniest and densest part of our parts of our body, for instance. So these are relativistic, which means compact object sustained by strong interactions. It means by the same forces which make our nuclei, atomic nuclei, work. And now it's clear that pulsars are actually neutron stars, but which are rapidly rotating. As you can see on this picture, so by these wiggly arrows, these are photons of radiation, of radio or X-ray radiation, which emits along the magnetic field direction, actually. Yeah, so, and if it has an angle between the rotation axis and magnetic dipole moment direction, then these beams will scan the space around it like a lighthouse, mayak. So, and when we happen to be in the field of this lighthouse radiation, we will see a pulse. So if it spins fast, we will see this rapidly pulsing radiation, which we call pulsar. We know around 3,000 of them. We get a new one every half a day. I think so. For tonight, it was 3,320. And for some of them, they are in binaries, and as we will see on the next slide, we can measure their masses more or less in a more or less nice way. Yeah, so how to describe the neutron star structure? What do we need to know theoretically to get to know how much can be the mass or how large can they be? We need to know the equation of state of a neutron star mirror, which is basically the same mirror which exists in the atomic nuclei. So if we have some model, so the pressure, what's an equation of state? It's how the matter doesn't like that we try to squeeze it. So how much it pushes back. So it's pressure as a function of the density or energy density, as here. This is some curve, you can see it on the left, and each of this curve corresponds to some line in the mass and the radius plot, which you can see on the right panel, which is a one-to-one correspondence to an equation of state, which means that, for instance, yeah, every of these curves, MR curves, has a maximum value. So each equation of state predicts some maximum neutron star mass that can exist. Otherwise, you can see, so if you increase the density, mass goes down again. So, and this is the maximum possible mass if we assume this equation of state, blue or red one. And could we go to the next slide? And we now have some precise measurements of rather massive neutron stars. So they are made in binary systems, and as you can see, they are around 2 solar masses, most massive known pulsars, and it means that all the possible theoretical equation of state, we have to calculate somehow, theoretically. We need to sit, do nuclear physics carefully, calculate diagrams, all processes, whatever we have to do, and get some output. But if it predicts the maximum neutron star mass too low, so if the maximum neutron star mass is too low, then this equation of state is not viable. This is basically the first way how we can test particle physics with astronomical observations. If our model of how nuclear particles should work, should interact with one another, give us a too low neutron star maximum mass, then it is probably not correct. Go 2 slides forward. 2 slides, yeah. Yeah, so a couple of more words about strong interactions. So in the physics of strong interacting system, the very important target is to build a phase diagram of quantum chromodynamics of strong interactions. And what's important to point out here that, first of all, there are many experimental efforts going into studying this phase diagram. So new accelerator experiments at LHC, in CERN, in FAIR, Germany, NICA, in Dubna, in Japan, everywhere people are building accelerators for studying this phase diagram. And as you can also see, there are many phases. Purely hadronic physics, which we more or less know, then maybe quark, gluon, plasma, which we can't create outside some extreme environments. And an important thing is that neutron stars are exactly that kind of extreme environments. So neutron stars are something made by nature with huge energy released and required for this. So basically, astronomy and astrophysics allows us to study the same physics as we would do on accelerators, but without spending too much money. This is why it's important. One of the points. Next slide. And of course, this rich phase structure which we had for QCD also reflects in the many possibilities for internal structure of neutron stars. So neutron star is kind of an umbrella term. Everything which has such properties, but we don't actually know what's inside. And there are still many possibilities. And if by some astrophysical measures, we figure out what is definitely inside of there, maybe by some radiation, which any specific phases of this can emit, maybe absolutely stable, strange quark matter, hyperon, and many, many phases. So we can then understand what would happen in ordinary nuclear matter under extreme conditions. This is the most important value of neutron star physics for us. And that's like, yeah, and the last aspect for neutron stars, which I think is most important to mention here in Tashkent, that, well, neutron stars are relativistic and heavily gravitating objects. So we can study extreme gravity here, where, as we think, Einstein relativity works well, and it should. But there are still some space to test modified theories of gravity. And actually, not just by extreme gravity of compact neutron stars, but by studying the gravitational wave signal. There was a Nobel Prize 5 years ago for first experimental confirmation of a gravitational wave signal from a black hole merging. And also there is signal from neutron stars merging. And so here in Tashkent, specifically a group in Institute of Nuclear Physics, Astronomical Institute, and here in the new Institute for Fundamental and Applied Research, is working on basically using what we know about nuclear physics and neutron star physics to test whether there can be something beyond, something more to the general relativity of Einstein we all know. And that's all for now. Thank you very much for your attention.
Thank you very much. The next for the report is given to the next keynote speaker, Laurent Folderay, professor from Budapest University of Technologies and Economics. Are you here? Yeah. Okay. The next. Are you here? Okay. Come. Ladies and gentlemen, let's move to a totally different topic. The question is raised here: what can geoinformation science, or I would say, what can GIS do for present-day challenges? Here, the key point is present-day challenge. What present-day challenges we have? Keeping in mind that this conference is about conceptual mechanics, hydraulics and water resources engineering, let me start with water resources. We know very well that the RRC is shrinking drastically. We can observe it in the last 60 years. In addition, the loss of water, we can also observe that there is an intensive desertification in this area. It means that the soil of the river, of the RRC basin is getting to turn to sand, which is already not a living object, which is already not useful for biodiversity, not useful for nature or agriculture. If we check, RRC is just an example. Worldwide, we can identify that there are desertification processes more intensely occurring, and the desertification is a process which worsens the climate change itself in several ways, including the vegetation cover, the loss of vegetation cover, change in the surface albedo, or different aerosols of sand and dust are appearing, and greenhouse gases, fluxes. So there are different ways how it is affecting the climate change. And we should also recognize that how the desertification is going on in present world. If you look at this picture, all those areas which are with red color, they are the hyper-arid area. These are the real deserts, which are orange. They are arid. They are also kind of deserts. The yellow are a kind of transition form, semi-arid or dry subhumid area, and only the humid area, which is here with the gray color, this area which has a chance that can be useful for agricultural use. If you look at the different goals of the sustainable development theory, I would say, because this is not a realistic way of considering our future. So the sustainable development goals are all influenced by the impact of desertification processes. And here at each icons next to it, what you can see is an intensity, how much it is influenced. What is more interesting is in the figure on the left side for me, right side for you, which says that by 250, how much the number of people will be influenced by the desertification processes. So here we can see 4 different kind of area where people are living, and we can see how from the present state, that is the gray color, and the number of people who are already influenced by the process of desertification, how it will be increased by time. So I think these are pretty unlikely processes,
from the desertification side. It's one problem from one side, the other problem is from the water side. So even though we have less useful area, humanity turns out to want to use more water, so the water consumption is increasing. So if we look at this figure with the different colors, we can see, let's start with the total, that in totally year after year or decade after decade, there's an increased number of water consumption worldwide, and it is added up from different components of water use in each segment, including agriculture use, municipal use, industrial use. These are all in increase, so it is not good. We have less easily accessible water on one hand, and we would like to use more water on the other hand, so simply the balance cannot be found by any means. Let me skip it. Also this one. So all in all, I would like to say that if we keep the way of life as we do now, or as we did so far, then half of the world's population will suffer severe water stress by 230. So it is a phenomenon which would clearly influence our life in all aspects of life, and also demand for water will exceed supply by 40% in 2030. So even by 2030, if we don't change the present trends, the demand for water supply will be exceeded. So it's simply in the equation we miss in the formula the available amount of water. And so far I was talking about water supply in relation to the topic of the present conference, but I would like to go more to the general points. What we can see here, as we have learned in elementary school, this is the periodic table of elements created by Mendeleev. And these colors means what kind of elements we have here. But if we look at this, the periodic table in a different aspect, with different colors, it has now a temporal interpretation of the periodic table of elements. It says what is green, that these elements are available without any risk, any limitation in the present day. What is orange? It seems that there is already a limited availability worldwide. So if I would like to do a mining, if I would like to purchase that element, I have limited possibility to do so. When it is orange turning to red, there's an increasing threat, the rising threat due to the increased use, and which is red already, there's a serious threat within 100 years, which is red already. It says that within 100 years, simply there will be no available element there. So even though I have all the money of the world, and I say that I would like to buy, for example, zinc, 100 years later, they will say that you cannot buy because it is not existent. So it is not a question of money, it's not a question of economical situation, it's question of nature. If all the elements are used or overused, then simply we cannot make use of that anymore. It is the one side that the elements around the world are less accessible by time. On the other hand, if we look at present day strategies, what we say that, oh, we don't like fossil fuels, let's move to green energy, renewable energy, and it sounds cool, very nice. And if we want to change the whole world from this percentage of use of energies, it turns out that we would also face a problem. Why? Because if I want to use renewable energies, I have to build solar panels, I have to build wind wheels, I have to build dams, and all these needs material. So consequences, if I want to phase out fossil fuels, then I would have an increased amount of use of metals, different kinds of metals, and very special metals, the so-called technology metals, are those kind of metals like germanium, for example, which are available in a small extent. So simply this idea that let's move all fossil fuels to renewable energy, it is simply the Earth cannot afford it because of lack of material. Also, we say that we want to move from a classical benzene-driven vehicles to electric vehicles. Good idea. The only problem that we don't have enough material in the world to change. Why is it not working? Yeah, but I cannot move. No, it is. No, okay. So it is simply we don't have enough material to get all those elements which is needed to build sufficient number of electric vehicles. Also, this statistic shows clearly that in the last 18 years, the demand for using elements has increased drastically, not only energy supply like coal, gas, or oil, but also particularly industrial materials. Use of industrial materials has been turned to be bigger with 150%. It's a huge amount of increase. Simply, the Earth cannot afford it due to lack of sufficient amount of industrial materials. Just quickly, let me show you the example of copper, because they say that it's a very good model. It is a very good proxy to model how the global industrial ecosystem is changing. Here in this figure, only the bottom figure is the interesting. It says the bottom figure that how it has been increased by time, the amount of copper in each year which has been mined. Clearly, you can see how the how the tangent of this curve is increasing by time. And if we take a careful examination of this figure, we can understand by keeping this same tendency by time. In let's say in 2019 we have there was a mining of 24.5 million tons. At the same year, the available resources were only 870 million tons. By keeping the same tendencies without changing the mining and the recycle rates, it would mean that within 35.5 years, all the coppers would diminish. They would be not available anymore. Because of that, we have to change either the mining or the recycling tendency. Okay, let's try to increase the mining. If we are looking for the tendencies, how the new deposits was found, and let's look at the left figure with the orange color, it says that by time we have less and less new deposits to be able to discover, simply because there are none. And as another example, in the right figure, you can see the gold, the same tendency for gold and many other elements, that opening new mines are problems because of lack of available resources. The other solution, they say that, okay, then if there have been already mined, then let's do a recycling of the mined elements. Here, the problem is that the technology is not available for that so far. For most elements, there is no technology for recycling. The most easier way is recycling metals, but even for metals, it turns out that it is too complex and too expensive to do the recycling, and in practice, it is not efficiently used so far. So we should focus more on recycling than on mining, otherwise we would have a great problem. And now let me tell you how GI science can possibly contribute to water, energy, or resource supplies. These are the points. Well, if we are without any details, because I have lack of time, when we talk about geoinformatics, according to any kind of definitions, it always says that is something which deals with geoinformation or spatial information. So basically, it is just taking whatever information you have and you map it. So a local-based mapping of information would make sense. Geoinformatics is closely related to different sciences, from geodetic and earth sciences to GI and geospatial information processing. These are all such kind of information that in the list, which can be directly used for monitoring, for handling the lack of resources. So even from a textbook, I was taking this sentence: the importance of spatial dimension of assessing blah, blah, blah, is to monitor and modeling various issues related to sustainable management of natural resources is recognized all over the world. So in textbooks, we say that we can apply GIS techniques for the purpose, but in reality, it is not much applied so far. Actually, basically on our most simple understanding of GIS, that is like mapping, we can say that yes, related to this issue, to these problems, we can do mapping of these different quantities and qualities related to the lack of natural resources, like mapping water quality, underground water management, hydrology, and so on. You can read the list, but based on mapping, which is the geographical mapping, which is the first point, the first and most direct way how GIS can contribute to these problems is mapping. Also based on the available maps, so the localized information on this, we can get geostatistical analysis. We can draw certain attention based on the available sources. What I found more important, that geopolitical analysis can be done. It means that if from the map, it turns out that I have all the phosphors, for example, in Morocco, then I will understand that politically, geopolitically, Morocco has a strength, and I will not try to get a war, or I will try not to make an enemy of the country, because this is a threat also for myself. This is predictions, forecasts for near future availability can also derive from this, but what is, and we can also understand that based on the available resources, what economical consequences for future can be defined. But you want to go to the next time that what is the real strength of GIS is not the mapping part, but also the temporal part, that we have different layers by time, different epochs we can have for our maps, and based on that we can do planning of new deposits, and based on that we can estimate the costs, how much it would cost to get to start the mining of the new deposit. Also, the cost is very interestingly, it's always related to quality. So if you think about oil, for some 20 years ago, it was said that the oil is gone, but then went to Ala oil, which is a lower quality, which is accessible only for a higher cost, but it provided a solution. So by time, new deposits means lower quality, increased cost. We should have to live with it, unfortunately. And yes, and nearly these are all the points, and others can be continued, but basically I think that GI science can clearly contribute for finding solution for the lack of different resources. And we should definitely make use of that because it's not in the forefront of our application field. Thank you very much for your attention.
Thank you very much, the professor, for an interesting report. So the floor for the report is given to keynote speaker, Nicola, professor, Doctor of Technical Sciences. Are you here?
Здравствуйте, уважаемые дамы и господа.
Okay.
Привет из Варны. Привет коллегам Рано Газиевой и Пехнос Байдукаевой. Можно начинать?
Да. Демонстрация экрана, да, все окей.
Сейчас.
Видно.
Представляю вашему вниманию доклад на тему «Алгоритм для адаптивного наблюдения на основе метода инструментальных переменных». Вы видите имена соавторов доклада. При проектировании систем управления с обратной связью по состоянию очень часто возникает необходимость восстановления вектора состояния по измерениям выходной величины и входного воздействия управляемого объекта. Алгоритм, используемый для определения вектора состояния, называется, как известно, наблюдателем состояния, а когда этот наблюдатель включает в себя алгоритм оценки параметров объекта, его принято называть адаптивным наблюдателем состояния. На рисунке 1 показана структура адаптивной системой управления с обратной связью по состоянию, а часть, окрашенная в зеленый цвет, представляет собой адаптивный наблюдатель состояния. Здесь я представляю вам нерекурсивный алгоритм для одномерных объектов, разработанный на основе метода инструментальных переменных. Что очень важно в этом алгоритме, так это то, что оценщик параметров в адаптивном наблюдателе построен на основе математической процедуры с низкой вычислительной сложностью при инвертировании информационной матрицы, которая представлена в другой нашей публикации. Рассматривается одномерная, линейная, стационарная, дискретная система, описанная в пространстве состояниями через уравнение 1. Показана форма системной матрицы А, входного вектора B, вектора выхода C. Элементы вектора Ф и B неизвестны и должны быть оценены. Порядок системы N известен заранее. XK неизвестный n-мерный вектор текущего состояния. X0 неизвестный n-мерный вектор начального состояния. UK скалярный вход, YK скалярный выход, а FK это аддитивный шум. Дискретная передаточная функция соответствует описанию в пространстве состояния, представленному уравнением 1. Соответствие между элементами B и вектора B и коэффициентами H и полинома числителя дискретной передаточной функции 4 определяется выражением 5. Элементами А и вектора А являются коэффициенты многочлена от знаменателя дискретной передаточной функции 4, взятые в обратном порядке и с обратным знаком. Задача состоит в том, чтобы оценить неизвестные параметры вектора А и Б, вектор начального состояния x0 и вектор текущего состояния xk. Вычислительная процедура алгоритма состоит из 12 шагов и представлена ниже. На первый шаг формируются массивы входно-выходных данных. Матрицы Y представляют собой прямоугольные матрицы теплица, все диагонали, которые параллельны главной, заполнены одинаковыми элементами. Это также способствует снижению вычислительной сложности алгоритма. Количество необходимых входных и выходных измерений обозначается прописной буквой N, вот здесь, и зависит от порядка объекта управления и количества строк L матриц. Вот так. Матрицы U также являются прямоугольными теплицевыми матрицами. На шаге 2 под матрицей G вычисляются исполнением использованием ранее сформированных матриц U и Y. На шаге 3 формируется ковариационная матрица C. Это блочная матрица, сформированная на основе ранее рассчитанных матриц G. А шаг 4. Оценки векторов H и A определяются с помощью векторно-матричной системы 6. Сначала определяется оценка вектора P. Тогда первые n элементов, взятые в обратном порядке и с обратным знаком, образуют вектор A, а последние n элементов образуют вектор H. Шаг 5. Здесь оценка вектора B вычисляется с помощью следующей системы линейных алгебраических уравнений. 7. Матрица T представляет собой нижетреугольную теплицевую матрицу. На шаге 6 вычисляется вектор начального состояния x0. Шаг 7. Оценки выходного реакция Y. Вектор G здесь синтезируется таким образом, чтобы матрица F имела нулевое собственное значение или такие, которые расположены дальше внутри единичной окружности, чем собственное значение А. На шаге 8 составляются инструментальные матрицы V, которые заполняются ранее определенными оценками Y. На шаге 9 пересчитывается матрицы G. На шаге 10 пересчитывается вектор параметров P. Шаг 11 требует повторения шагов с 7 по 10 4 раза. Шаг 12 вычисляется вектор текущего состояния xk. Как я уже говорил, вектор G можно получить путем синтеза по заданным полюсам. Предпочтительно синтезировать G так, чтобы матрица F имела нулевые собственные значения или те, которые расположены дальше внутрь единичной окружности, чем собственное значение матрицы А. Вычислительный эксперимент проводится в среде MATLAB при следующих условиях. По заданному описанию объекта наблюдения и входного воздействия УК моделируются его выходные реакции Y, потом к входу объекта добавляется цветный шум FK, входное воздействие УК и зашумленный выходной реакции YK подается алгоритм наблюдения. Потом на основе последовательностей входных выходных данных алгоритм вычисляет оценки параметров объекта и его вектор состояния. И компьютерное моделирование выполняется с объектом шестого порядка, дискретная передаточная функция, которого показана ниже. Здесь показаны векторы, которые соответствуют описанию передаточной функции в пространстве состояния. Здесь видно собственное значение матрицы А. Для входного воздействия УК используется псевдослучайная двоичная последовательность, сгенерированная в MATLAB с помощью приведенного ниже выражения. Вот это. Световой шум FK добавляется к симулированному выходному реакцию объекта управления. Он был получен путем фильтрации белого шума через фильтр передаточной функции 10. Уровень шума это рассчитывается вот здесь. Рассчитывается как отношение стандартного отклонения шума сигма F и стандартному отклонению сигнала сигма Y по формуле 11. Ошибки оценки векторов A, B и XK являются относительными средноквадратичными ошибками и рассчитывается по формулам 12. Вот так. При бесшумном выходе, то есть при FK равно 0 и L равно 0, то есть при минимальном количестве входно-выходных измерений, получаются результаты, показанные на рисунке В. Здесь видно, что алгоритм начинает работать на 18-м такте. Вот этот момент. А ошибки наблюдения ЭА, ЭБ и ЭХК являются нулевое значение. Имеют нулевое значение. При зашумленном выходе с это 10.018 и L40 получаются результаты, показанные на рисунке 3. Алгоритм начинает работать на 98-м такте, и ошибки наблюдения составляют для вектора А меньше, чем 0.033, для вектора B 0.01, для вектора XK 0.065. При зашумленном выходе с это равно 10.014 и L равно 100, получаются результаты, показанные на рисунке 4. Алгоритм начинает работать на 218-м такте, а ошибки наблюдения, как видно, меньше, чем 0.017 для вектора А, 0.0057 для вектора B и 0.024. Видно, что увеличение входно-выходных измерений N проводит к увеличению помехоустойчивости алгоритма. Уменьшаются ошибки наблюдения, но увеличается время сбора исходной информации. В заключение могу сказать, что метод инструментальная переменная является одним из лучших при оценке предварительно собранных данных, но в закрытой системе шум FK передается на выходный сигнал по каналу обратной связи, поэтому не может быть независимости между инструментальными матрицами и шумом. Только если шум белый, возможно, что оценки не смещены, но в реальных системах это предположение нереалистично. Использование метода в замкнутом контуре возможно только при наличии дополнительного входного сигнала. По этой причине использование предложенного алгоритма наблюдения в закрытых системах не рекомендуется. Этот алгоритм разработан на основе прямого, нерекурсивного метода, поэтому проблем со сходимостью процедурой не возникает. Достоинство алгоритма, однако, заключается в способе формирования информационной матрицы. Здесь она образована 4 подматрицами. Таким образом, снижается вычислительная сложность процедуры обращения матрицей G. Они 4. А независимо от количества n измерений ввода-вывода, только двухматрицей инвертируется для оценки коэффициентов HI и AI, которые всегда имеют размеры n. В остальных случаях эта процедура предполагает обращение матрицей размерности больше, чем это. Благодарю за ваше внимание.
The next floor for the report is given. Пожалуйста, демонстрацию выключите, пожалуйста. The next floor for the report is given. Keynote the speaker, Usmanov Abdulkarim Suliyevich, academician of Academy of Agricultural Sciences of Kazakhstan Republic, professor, leading researcher, Scientific and Production Center of Agri-Engineering, OLP, Kazakhstan. Please.
Демонстрация.
Assalomu alaykum, hurmatli domlalar, studentlar, mehmonlar. Men Timsxona 1965-yilda o'qishga kirib, 1970-yilda tugatganman. Timsxa diplomini olganimdan mamnunman. Bu bilan men faqat faxrlanaman. Bugungi kunda men Qozog'istonda faoliyat olib boryapman, ishlayapman. Bugungi kunda bilasizlar, sifrovoy texnologiya hamma joyda joriy qilinyapti. Qozog'istonda 2017-yilda sifrovoy Qozog'iston degan programma dastur qabul qilingan. Shu dastur bo'yicha xalq xo'jaligi hamma sohasida sifrovoy texnologiyani joriy qilish kerak. Bugungi kunda bu ishda ko'p amallar bajarilgan. Transport sohasi почти 90%, aloqa sohasi 90%, yana boshqa sohalari hammasi, moliya sohasi почти 100% ga raqamlashtirgan. Bizda даже naqd pul olib yurish hozir modada chiqib qoldi. Hamma narsa raqamli. Qayerga joyga to'laydigan bo'lsangiz, faqat shu raqamli sifr bo'yicha to'lanadi. Mana shu borada qishloq xo'jaligida nima ishlar qilinyapti degan savol tug'iladi. Bugungi kunda biz qo'yni, sigirni, tuyani dron bilan yoki bo'lmasa kaptorlar bilan boqyapti. Qayerda yurganini hammasini bilib nima qilib o'tiradi. Shu sohada 6 ta ilmiy tekshirish instituti birlashib Agripark degan tashkilot tuzdi. Bu tashkilot hamma o'zining sohasi bo'yicha shu raqamli texnologiyani amaliyotga joriy qilish bo'yicha. Bugungi kunda bir necha texnologiya bor. Qishloq xo'jaligida mahsulotlarni yetishtirish bo'yicha. Shulardan faqat 3 tasigina Bugünkü günde 3 teknologiya asosan ishlanadi. Bu birinchisi tradisional texnologiya, bu an'anaviy texnologiya. Oldindan yerni shudgor qilib, ag'darib, keyin ekishga tayyorgarlik ko'rardik va ekardik, unga o'qot qilardik, keyin yig'ishtirib olardik. Bugungi kunda bu eski texnologiya bo'yicha faqat kichkina fermer xo'jaliklarida ishlayapti. Ikkinchisi nollik texnologiya. Yerni qaydamasdan yerning o'ziga ekish. Bugungi kunda Qozog'istonda 1,8 million gektar joyga shunday texnologiya ekyapti. Üçüncüsü minimal texnologiya. Bu yerda ikki xil texnologiya qo'llanilyapti. Birincisi plaskoresniy обработка deydi. Yerda bo'ladigan to'proqlarda yerni ag'darmaydi, past tomonni yumshatib ketadi. Va nihoyat oxirgisi minimalniy texnologiya bu kombinirованный mashinalar bilan bir o'tishda 7-8 operatsiya bajaradi. Mana bugun qaysi nimalarni tekshirishimiz mumkin? Sifroviy texnologiya bo'yicha. Asosan sistema parallельного вождения и агрегат автопилотирования. Bu asosan oldin g'alla urganda 1 metrgacha kirib ketish ya отклонение bo'lardi. Hozir 15 santimetrgacha bo'ladi. Bu ish unumdorligini ko'paytiradi va kerakli aniqlikni kiritadi. İkincisi, bu qaysi operatsiyalarni texnologik jarayonda bajarish mumkin. Asosiy tuproqni tayyorlashda, ekishda, kimik обработка asosida va уборкада. Eng kamida 10-12 ta operatsiya. Bugungi kunda hech qanaqa muammo yo'q. Oldin traktor ishlayaptimi, kombayner ishlayaptimi tekshirish kerak. Buni tekshirmaymiz. Smartfon bo'yicha qayerda ishlayapti, nima qilyapti, necha gektar yerni g'allasini o'rdi, hammasini nimada uyda o'tirib, ofisda o'tirib nima qilish mumkin? Nazorat qilish mumkin. Keyingisi sistema differentsiyalniy внесения удобрения. Biz o'g'itni hozir kerak bo'lsa ham, bo'lmasa ham beraverdik. Hozir faqat shu qayerga ma'lum kerak bo'lgan joyga o'g'itni beramiz. Buning uchun 3 ta korxona yig'ilishim ertaga qo'yishdida sputnik orqali svязь bilan hamma joyini tekshirish mumkin. Tepadan turib qaysi joyga o'g'it berish kerak, qaysi joyini kimik обработка qilish hammasini ko'rsatib turadi. Keyingi monitor vысыва. Bilasizlar, ekish paytida sochliklar bor. Bir sezgani kamida bo'lishi 20 ta, 30 ta, 40 ta. Qaysi bir turboprovod tiqilib qo'ygan, ishlamayapti. Mana shunda monitorda hammasini ko'rsatib beradi. Keyingisini o'tkazinglar. Keyin o'g'it berish, herbitsid. Bu ham shu. Ma'lum joylarda operatsiyasini bajaradi. Bugun bilasizlar, herbitsid bu mana nolliy texnologiyada faqat haligi chiqqan sagnaklarni shu nima bilan ketirish mumkin. Herbitsid bilan. Keyingi sistema определения места расположения. Qayerda ishlayapti, nima ishlayapti, hammasini shu ofisda o'tirib aniqlash mumkin. Bu sifrovizatsiyani bugungi kunda hamma xo'jaliklarga emas, faqat nima deydi, yangidan tuzgan sovxoz предприятияларga qo'yapmiz. Agar yer maydoni 200 gektardan kam bo'ladigan bo'lsa, bu nima deydi, iqtisodiy tomondan ijobiy baho bermaydi. Keyingisini aytaylik. Bu mash bo'yicha ketgan, o'g'it ketgan, to'plov ketgan, ish haqi ketgan xarajatlarni aniqlab, biz taqqoslab qaysi usul bizga qulay ekanini aniqlaymiz. Mana bugungi kunda biz 3 ta nimani oldik, firmani oldik. Birinchisi John Deere kompaniyasının texnikalari, uni o'zi trambil degan sistemasi bor. Hamma traktorga, kombaynga qo'shiladiganlar xohlagan pakazatellarni ko'rsatib berish mumkin. Hadi yuqorida ko'rsatilgan. Ikkinchisi u Germaniyaning nimasi? Sistemasi. Bu yerda Isobus degan sistema bor. Germaniyaning hamma kompaniyalari qishloq xo'jalik mashinalarini chiqaradiganlar shularga standart bo'yicha chiqaradi. Va nihoyat uchinchisi Belarusyaniki. Bu Belarusya bugungi kunda hamma ko'rsatkichlarni tekshira olmaydi, faqat 30-40% ko'rsatadi. Keyingisini. Mana biz 3 xil nima oldik? Qishloq xo'jalik mahsulotlarini yetishtirish bo'yicha birinchisi soyaga biz 600 gektar joy ajratdik. İkincisi makka yuqori, bunga 100 gektar. Üçüncüsü zimaya pshenitsa, kuzga buğday va nihoyat yachmin arpa. Mana shu 4 mahsulotga hammasi bo'lib 1000 gektar yer ajratildi. Yana 400 gektar yer для poligon, испытание qilishdi. Oldin shu kerak texnikani испытание o'tkazamiz. Rezultatni olamiz, taqqoslaymiz, qaysinisi iqtisodiy tomondan bizga ma'qul bo'lsa, shuni olamiz. Keyingi bu yerda qaysi texnikalar sotib olingan? Bugungi kunda eng nima deydi? Sifatli, arzon, qulay texnikalarni biz shu испытание orqali taqqoslab belgilab oldik. Keyingi bunun için traktörde 3 klas aldık. Brutor klası, bu MTZ 80, MTZ 82. İkincisi MTZ 12-21. İkinci klastaki, nihoyat üçüncü klastaki klasına traktörler. Yani, devam ettirelim. Qaysi texnikani, qaysi ko'rsatkichlari, qaysi ekini yetishtirib olishda qo'llaniladigani ko'rsatilgan. Yani, bugungi kunda bilasizlar, oldinda yerni ag'arardi, keyin razval solib yotardi, uni tekshirib yotardi. Bugun bu texnikani hammasi nima deydi? Оборотный plug bilan bajariladi, tekshirlash faqat 5 yildagina tekshir planировка yasaladi. Qolgan paytda shu o'zini ikkiga bo'ladi. Bu ekonomik bo'ladi. Keyingisida bu kombaynlar. Valla o'rish kombaynlar va makka o'rish kombaynlar. Keyingisida yana mana qaysi usul bo'yicha necha sentnerda hosil oldik va uni qanaqalar ko'rsatilgan. Yana listda. Eng kamida biz 10 sentner olardik. Nimadan? Zalli joydan. Hozir o'sha 20 sentnerga chiqdi mana shu nimadan keyin. Bu 2 barobar degan so'z. Bir tomondan ekonomiya, ikkinchi tomondan endi ozgina xarajat bo'ladi. Shuning uchun 2017-yildan oldin olingan texnikalarga buni qo'ymadik, buni. Ko'p xarajat ketdi, nima qilamiz? Asosan shu 17-yildan keyingi chiqqan texnikalar sotib oldik. 48 turdagi har bir yangi texnikalar. Buni hammasi davlat hisobidan bajarildi. Nima deydi? Pilotni proyekt shaklida. Agar shu hozir ko'rsatganimiz bo'yicha buni endi keng nimaga tarqatish mumkin. Buni qilish mumkin. Ana shu sistema точный земледелия. Rahmat e'tiborlari uchun. O'zbek tilini 15 yildan beri yoddan chiqarib qo'ydim, hozirgina noto'g'ri gapirgan bo'lsam kechirasizlar.
Katta rahmat, hurmatli
Abdukarim Salimov, sizga juda ham qiziqarli, bizga ma'ruza berganingiz uchun. The next floor for the report is given to the next keynote speaker of the conference, Dr. Jago Kui, Michigan State University, Professor of Geography at the Center of Global Change and Earth Observation at the Department of Geography, Director of Asia Hub, USA. Are you with us? Online demo? Well, sharing.
Okay, can you hear me?
Yes, we are here, but presentation not appear.
Okay, can I share the screen? Let me share the screen. I can't do now.
Okay.
Let me share the screen and I will make the presentation. I'm disabled. I cannot share. The host, let me know. Let me share the screen. I cannot share the screen now. Maybe the host needs to let me share.
It's okay.
Okay, well, this is okay if I can't share, but okay. Can I have first slide? I cannot share my screen and I cannot control the screen either. So if the host allows me to share the screen.
Professor Chi, can you hear me?
I can hear you, Alim.
Yes, your presentation now in the screen, everything is okay?
Yes, it is okay.
Yeah, we can see. We can see it.
Okay. Thank you for the opportunity to present this work with a cascade, particularly under the leadership of the Alim and others, so that we can do some practically collaboration between Michigan State University and TME. And can we go to the next slide? I cannot control. Alim, can you okay, if you can make it like a PowerPoint show your presentation instead of a clip. So anyway, this is in memory of our great friend and leader in the international partnership, Professor Umazakov, who was a victim of the COVID. And I feel sad about this, but this is in memory of his leadership. I want to give this presentation to promote international collaborations between Michigan State University and TME through a new initiative called Asia Hub. Next slide. What is Asia Hub? It's really a hub to provide the facilitate collaborations in research and education. This fits well with the Cascade and Asia Hub, and also build strong and win-win situation for international collaborations. And also it links to regional and international same in mind, similar-minded institutions and people together to form a network so that we can address much bigger challenges. Next slide. So the Asia Hub was formed in 2017 and based on the Michigan State University and Nanjing Agriculture University, and among other 14 research institutions in Asia. It provided 17 projects and also 3 grants from the US. And then we published so many papers already since, till 2020. And we have more in 2021 and 2022. Next slide. So the mission of the Asia Hub is to co-generate knowledge and solutions for societal resilience to emerging global change challenges, particularly in the area of climate change, water, energy, and food nexus. Okay, next slide, that's good. Next slide. So far we have 23 partnerships already, and Tiami is one of them, and then the Kasnau is another one in Central Asia. As you can see the list here, we have many institutions in Southeast Asia. And together we are addressing much bigger and challenging issues now in the Asia continent. Next. I want to talk about this particular initiative, Future Agro-Ecosystem Research and Innovations. And this is very much in alignment with the Cascade, the Central Asia and South Caucasus, Agriculture University Consortium for Development. This is really something that we can work together to address the challenges we're facing in Asia. Next. Why do we want to focus on agro-ecosystems? We need a lot of science. We need a lot of engineers. We need a lot of coordinations. This is just one of the examples to show that how much of the agriculture, cropland, make changes in carbon stocks. You can see the changes, and you can see the importance of different regions. You can see that Asia is a very important region, particularly in the Southeast Asia. So what we need to do is to look at the agro-ecosystems as a single system. Next. The single ecosystem is linked not only to the farms, but also linked to the environment on the left of the diagram, and then also links to the economics on the right. More importantly, it links to the society. But here, the diagram also shows a very unique aspect. It is related to the geopolitical entities or situations as well as the little pink circle to the lower right. So as you all know, emerging challenges around the globe really cause a problem for food security and energy security. How can we address those issues, with the research advances in agro-ecosystems? So it's being affected by and can contribute to the geopolitical systems. So next. So we need to have, from the engineer perspective, we need to have long-term observations, and our good science is built upon good data. So we need observations. So I want to go to the next slide. Next slide. We establish a network in the US. We have LTAR and LTER, long-term ecological research observations, or long-term agro research observations. So in this initiative, we want to establish long-term monitoring capabilities. Next slide. Next slide, please. Skip this one, yes. So we establish long-term agro-ecosystem observations and potential, collaborations with Cascade through the collaborations on the observation and research. Let's go to the next slide. We have established a network here and an observation station, long-term monitoring network here. Next. So here is the design that we built regional in situ agro-ecosystem observatories in the Hainan Island, but also in other parts of Southeast Asia. As you can see, we have those stations in Thailand, Myanmar, Laos, Cambodia, and Vietnam. And then we established those network with a lot of instruments. I want to acknowledge that, Cascade and also the many talks today from the engineer perspectives can contribute and also can benefit from this initiative by experimenting their new engineer technologies or the new ways of data analysis. I think that we can address the challenges of agro-ecosystems together. So this is the network that Asia Hub is going to establish. And I think this is a good place to collaborate with Cascade. Next. As you can see here, we have 3 pillars: big data, big science, and big strategy. So all the 3 combined or integrated together to address 10 challenges: observation, technology, innovations, long-term multi-platform monitoring systems, data and data mining, climate change and food security, etc., as you can see from the list. And one of the things that is very important is green agro-ecosystem innovations. That requires engineers and sciences. And the goal is to really reach to the carbon sequestration enhancement of agro-ecosystems. We also do the modeling and predict what the future looks like and how the past affects the future and what lessons we learned from the past. I think issues in Central Asia could be a very good place to start. We have a long history of research in Central Asia, and that could help us to build models and predict the futures. Next. So Asia Hub has this initiative with the 4 components. The one on the left is this ecological observation platforms that we talked about. And then second to the green colored is a research team that can collaborate to address those 10 issues. Another one that we can really collaborate is this, the one in the yellow, grayish yellow, greenish color. There's a talent, innovation, cultivation. I list there, Asia Hub University that includes Michigan State University, Tianmi, and others. So there we can collaborate to train next generation of young scientists. And finally, on the right, we are linked, the Asia Hub is linked to international organizations such as Future Earth. We want to engage them in the collaboration, and we want to do this together with the international organizations like Future Earth Nexus can. All 4 components can be mechanisms to collaborate with Cascade. Next. The design of the observations and the projects look like from the 3 levels: satellites, and also airborne, and then ground-based monitoring facilities. We have crews to go to the field and make measurements all the engineering work being done in Central Asia and South Caucasus and others could be very beneficial, and we can experiment those instruments, methods, and other algorithms. So this is really good, place we can collaborate. Next, we will have a lot of instruments to be deployed in the field, and this will be launched next year. And I wish we can, have Cascade to participate. And then we plan this for a 20-year operations, and we want to hire people, and we want to have ability to host visiting scholars, students, and others, and who can join us. So this is a really large effort to make this initiative to focus on the agro ecosystems. Next. And here is what I suggest. I think Asia Hub and the Cascade can work together to co-generate knowledge and solutions for sustainable agro ecosystems in Asia. So last slide I have next is a list of the collaborations, potential collaborations with the Cascade. Maybe we can establish, the two consortiums and establish a formal partnership through an MOU. And also we have resources to fund project, to provide money to support Asia Hub and the Cascade partners so that we can work together through, research projects. We can together fund, jointly apply fundings. We have a number of places that we can go, US-based, NASA, and NSF, USDA FAST, USAID, etc. But also there are some monies available in China and the surrounding countries, like the NSFC, the National Science Foundation of China, and most Ministry of Science, Technology, etc. And of course, there are international entities that provide money. I think we can provide, we can seek together fundings from ADB, Asian Development Bank, World Bank, etc. But Asia Hub can also provide postdoctoral fellowships. Any countries or institutions from Cascade and Central Asia, other countries in general, and can really, work with us. We can provide postdoc fellows here, and then provide funding to support visiting scholars, and also develop joint degree programs. I think the leader of Cascade, Dr. Alim Platov, and I have been working to promote and enabling the joint degree programs between TME and Michigan State University. I think Asia Hub can facilitate. Finally, we can share the data, not only remote sensing or geospatial, geoinformatic data, but also in situ measurements that could help us to explain what we observed from satellites and from other geospatial platforms. With that, I want to go to the next final slide. Want to thank the organizers of this meeting for this opportunity, and I want to invite everybody. Next slide. I want to invite everybody to join us, and then let me know if there is any potential collaboration that you would like for us to proceed. I'm very happy to coordinate this, and I'm looking forward to future collaborations with you all. Thank you very much for your attention, and have a good conference.
Thank you very much, dear Professor, for interesting and informative report. The next floor for the report is given to the next keynote speaker of the conference, Professor Alim Salimovich Pulatov, TME, National Research University, Head of EcoGIS Center, Head of Digital Technologies Cluster of Sustainable natural resource management. Please.
Thank you very much. Especially, I would like to thank you, Professor Chi from the Michigan State University. He's our long-term partner who's working with us from 2000, and very much appreciate that he's always support our initiatives, especially in the memory of the Tam Pardayish. Today, he's also make a memory speech dedicated to him. And especially, I would like also to add that from my conference speech, also what is the Tam Pardayish input to the Cascade and many other initiatives which is done at our university and in Central Asia. That's why, if you allowed me to come to our topic consortium, Cascade Consortium, experience in education, research and innovation in the Central Asia and South Caucasus of Agricultural University. Our Cascade Consortium, can you? As you can know, you know that Tam Pardayish was a leader of the Cascade, chairman of Cascade, and today in the morning you also listen greeting words of the Teklesi Zabayic Yespolov, who's also mentioned that he's a leader of Cascade, and Teklesi Zabayic is a chairman of the CIS Agricultural University Consortium network. And if we today put attention that he is a great leader and organizer who made a big contribution to the development of science and education in the world, not in the region, but also in the world, region and Republic of Uzbekistan. And his titles are showing this important moment for he was a chairman of the Central Asia and South Caucasus Consortium of Agricultural University for Development, which is shortly we say Cascade. He was member of Executive Committee of Global Confederation of Higher Education Association for Agriculture and Life Science in the world. Is about 900 agriculture universities combined under GGERA. GGERA is now existing, as you know, from the Nanking Agriculture University. We every year Cascade, including in the main GGERA board, we delivered World Agricultural Prize annually for the two persons from developed country and the developing country and developed countries. So this is a very prestigious honorable award, which is organized by Nanking Agriculture University, which is also leader of the Asia Hub, which is now Professor Li Chi already mentioned. He is also chairman of Council of Higher Education Institutions of Republic of Uzbekistan. That means he was a leading person in the country, and also his rector was a former rector of our National Research University, TIME. As you know, if you look on from the 2010 Cascade existing, and initially at our TIME, at our university, we initially combined 8 universities. Especially from the Central Asian 5 countries and 3 countries from the South Caucasus. Totally, we had 8 universities, and Professor Murzakov from that time was very much involved in the establishment of this Cascade Consortium. In 2011, due to CASIA project, which is with CASIA 1, CASIA 2, CASIA 3, and also Timur project, we increased the number of interested partnership up to the 14 universities, and after the Tam Pardayish has become a rector in 2017, we also can see that today we have 20 universities combined by his efforts under the Cascade umbrella, and you can see how many students. And our university, one of the leading universities in the Central Asia. Also, we have another leading universities from Kazakh National Agriculture University, is most in the main important ranking system of the QS, taking the 551. And I would like to show this example how it is spread in our universities in the Central Asia. This from all the Central Asian parts. Next. So I would like to only say that the Cascade was initiated to go only to contribute through the collaboration and partnership to agricultural education, research and innovation, and turning to contribute to agricultural development in the CAST region. Cascade contribution is going to only for the combining the all research among the 20 universities. Next. We have also mission, which is the mission of the Cascade is make the own contribution to in agricultural research, education and innovation through the collaboration and partnership for development of agricultural sector in the region. A specific objective is to provide a platform for dialogue and critical issues, assist the strengthening of organizational and management capability, also encourage and establishment of appropriate capacity, strengthening the cross linkages between the national, regional, and international agricultural development organizations. Yes, Cascade cooperation on the global level. We working with, as I mentioned before, on the GERA consortium umbrella and have linking in between the US and Canada Agricultural University Consortium, ICA European Agricultural Consortium. As you mentioned, Asia Hub is the Asian University Consortium for Agricultural. We have African, we have Brazilian, we have many other consortiums, 16 consortiums bringing under the umbrella of the Global Consortium Confederation of Higher Education and for Research and Agriculture. Cascade on international, interregional cooperation. It's on the global cooperation, and the interregional we mainly working between the European Alliance on agricultural knowledge for development. We're working with the AgriNatura. We're working with the Silk Road for Agriculture and Research and Innovation Alliance. You know that Bahadur Suyunch and we together in 2019 under the initiative of the Uktam Murzakov, professor, chairman of Cascade, we signed a membership agreement between the Silk Road Agricultural and Research Innovation Alliance and Cascade. In 2019 and 2021, we signed with the Consort Alliance, with the cooperation between Alliance of Agricultural University under the Shanghai Cooperation Organization. And recently in 2021 in September, we signed the MOU with the ARDO, African Asian Rural Development Organization. And we in 2019 signed agreement with the Asia Hub. So we have many interregional cooperation under our umbrella, and it was interesting for our university. Next. Here's about how many students we sent during this 2002-2018, 520 approximately students exchange in both European Union and Uzbekistan, Central Asia. Next. There's as you know, the double degree master program organized between the European University and the Central Asian, especially TIME, and under the Cascade umbrella. These are some examples of the defending of the master thesis at Wageningen University. These are the first graduated from in 2011. Next one. There's also recently in 2019 we visit the Northwest Agriculture University, where the Uktam Pardayanch discussed with the 5 students at this university, and also the days Sardur Hamidov is graduated first master thesis at this university in the joint cooperation with Professor Lee. Next one. This is all from 2000 when we started the joint education. There's a statistical part where we have a joint education master and PhD students. And there's a signed agreement from 2016, 2000 we have 17 and 2019 with the general 5 agreement signed for the double degree master and PhD program. The important part for the Cascade is do the research also and innovation. There's one of the highest priority of Cascade to promote a new agricultural development. As you know, the TME is working on the promotion of conservation agriculture, as Karin Sulic mentioned about zero tillage. As you know, that the zero tillage in Uzbekistan, we started one of the first in the Central region and also in the CIS country from the 1089. We started to moderate, use that, and still we continue this conservation agriculture in our region, Uzbekistan, especially with the FAO. This is also signed recently by Ukhtam Pardaich in 2019 in November, between the night organizing the Science Tech Park in the at the TME. Next step, hold on. This was also the time Ukhtam Pardaich and Cascade, as a chairman Cascade, signed agreement between the SuperMap. It's opposite program software, which is RGIS, and so now the second position in the world on the marketing. SuperMap. So we now have the capacity to promote for the Central region the SuperMap international programs also. Next. This on the left side you can see all the subjects which is we already developed at TME, and the right side we already starting from this year new subjects courses for master and PhD students at our university. Next one. The also important part that in 2020, when the pandemic time, Ukhtam Pardaich initiated to organize joint cooperation, not double degree, 2 universities, but now 14 universities established from the 1 semester, delivered 14 courses. And you next, 14 courses developed, and the one week by week, starting by from the TME, the digital economy, and finalizing by practical marketing by Karkonosta State University. These are a few examples. Is the leading of the professors and also coordinator from Karsat and the universities. Next one. And also due to jubilee on 2020, Ukhtam Pardaich also 10 of the December we organized to jubilee 10 of the jubilee of the Cascade. We organized the international conference in the Central Asia and internet on internationally wide, where we provide 150 papers presentation. Next one. In this year, we also the last in this year pandemic time, we also opened by efforts and also financing by sponsor, which is the very much likely for our university from the Aqua Group, that organized the digital technologies cluster for sustainable natural resource management on December 30, 2020 at TME. Thank you very much for your listening, for your attention.
Thank you very much, dear Professor Salim Salimovich, for interesting report. So, значит, поступило предложение с зала. Мы на сегодня уже исчерпали все, значит, доклады, но из-за того, что у нас мы перебрали со временем, поэтому предлагается, значит, вопросы и ответы перенести на круглый стол. Да? Таким образом, мы на этом завершаем сегодняшнее совещание, и до завтра. Завтра у нас будет, значит, заседание по секциям. В 10 часов начинается заседание по секциям. Регистрация в 9 часов начинается. Поэтому будьте добры, завтра вовремя придите. И до завтра.